Sometimes I wonder what is wrong with me.
Good morning, everyone, and welcome to KCD Sofia. Now, there's a number of reasons I'm really excited to be here today. The first one is that this is actually the first KCD in Sofia. We've managed to sell over 500 tickets in just a matter of months. And also because it's the first one, we can always get to say that it's the biggest one ever, until the next one, of course. Now, another reason why I'm excited is because this is actually my first time being a conference host. So my name is Zahari Dichev, and you quickly realize that actually hosting conferences and presenting speakers is not really something I do for a living, actually. But let me first ask you, do you know what C stands for in KCD? Anyone? That's right, it's community. And there's a lot of great things about community events, but one of its peculiarities is that you kind of need to deal with the resources that you have. And in this case, I'm essentially part of the resource. Nevertheless, I promise that I'll try to make the conference as smooth as possible for you. Unfortunately, I think that if I miserably fail, you probably can't really get your ticket money back. But so enough about me. Let's first see how many of you are traveling from abroad here to Sofia. Wow, that's actually quite the crowd. Well, thank you for coming to our beautiful city. I encourage you to actually spend some time to explore the city, immerse yourself in the local culture, try the local food, and if you're adventurous enough, you can also try the local alcohol. But be careful because your KCD ticket doesn't really come with an insurance policy attached to it. So enough about the place. Let's just briefly talk about the conference itself. So today we've managed to actually line up a bunch of topics for you, ranging from AI orchestration through security, all the way to observability. And these topics are spread out in various sessions during the day, as well as lightning talks and workshops, but more on that later. But this conference is not only about its content. Because it's a community conference, it's about the community, which means that I encourage you to actually spend some time learning from each other, meeting new people, and reconnecting with old friends. Now, there are a few housekeeping items that I need to mention here. The first one being that as a community conference, we are really thankful to our partners from CNCF. We are obliging to the CNCF Code of Conduct. And if you see any problem, you can just always talk to us. And as they say in London, see it, say it, and we'll sort it out. Another important thing that folks stressed on me is to tell you about the food. So there is food provided. You're not going to be left starving. There are snacks that are available during sessions. There are drinks, and there is lunch that I'll remind you of. Another important thing to note is that you should have received an email prompting you to register for 2 of our workshops. And if you haven't received an email, you should check your spam folder because we've sent it twice. So I encourage you to register for these if you haven't already and you want to, because space is actually limited. Well, that's what you get when you don't have a professional host. I need to consult my notes. Last but not least, I want to actually thank the organizers. So that's Ioana, Vladi, Orlin, and Spas. Without them, this event wouldn't really be... Thank you. Without them, this event wouldn't really be possible. And we were thinking about getting them on stage here so you can welcome them, but the conference is not done yet, and there's no point thanking them before the job is actually done. So I think you're going to see plenty of me during the day today. So without really taking more of the conference's time, let's actually introduce our first keynote speaker for the day, who is someone who is quite well known in the community. He's a developer advocate at Upbound and a CNCF ambassador, who you probably know from the podcast space and YouTube. So please welcome on stage Viktor Farcic.
Okay. Let's see whether this is working. Okay, I'm going to talk. It will appear, probably, my slides. Doesn't matter. I'm going to talk about AI, right? And it's a subject that half of you probably are very, very interested in. Other half really, really hate it because it's here to take your jobs. It's here to replace you. Your company is going to fire 90% of you and all that stuff. Anyways, AI, right? How many of you tried it, used it? Something like that? No? For operations now, not necessarily development, operations. Only a few. Okay. Let's see, I tried it a long time ago. And I started with something like this, right? I did not put screenshots, but this is real. I think that this is in Cloud Code. Create a PostgreSQL database in AWS, right? Just ask AI, agentic AI, and it will do it for you, right? That's usually how it starts. And that's where innocence dies very quickly, right? This is what I got. I got two options, which is amazing, right? Two options from AI. The first one is this, right? Open AWS console, go to RDS in AWS console, create database by clicking create database, and so on and so forth. Now, if you're unfortunate to work in a company where I work, and if you would be fortunate enough for me to be your boss, that would be your last day on job. Kind of no questions asked, there is no review, there is no explanations, why did you do this? You would be fired. Now, option number two is something that you wouldn't get fired, you'd be thrown out of the window where I work, right? Launch a EC2 instance, SSH into instance, install PostgreSQL, right? It's completely insane. And the curious thing about that is that AI knows stuff, right? Models contain the collective knowledge of whole internet, right? They know better than that. Yet I cannot say the word. So there are a couple of problems and reasons why I got such a bad result, why I got this. First of all, I never gave AI sufficient information. It doesn't know what to work with, right? I never said that I don't want EC2 instance and then SSHing into EC2 instance and what's or not, right? So I gave insufficient intent. The second problem is that AI, in the context that I executed, has no idea what are the capabilities of my system, of my platform, right? It doesn't know whether I use Terraform, whether I use Crossplane, whether I do really click on console to get something. It has no idea. Moreover, it acts in a similar way as somebody who you just hired yesterday, right? And that somebody might know a lot, right? Might be a very experienced person, but that person, in this case AI, has no idea what are the company patterns. It has no idea what are the rules of engagement, what are the best practices. It knows nothing about how you do stuff. It knows nothing about your policies either. And finally, even if you pass all that, you will get context garbage, right? Because when you work in operations, you deal with a huge amount of data, right? Schemas, APIs, this or that. There's a lot of data, and context gets filled very, very quickly. And you might not realize it, but after a couple of conversations with some agent, in my case, Cloud Code, it turns into garbage very, very quickly. Now, to fix that, we need at least 3 things, right? I'm assuming that obvious things you already have. You know what are models, you know what are agents, you're using Cloud Code or Cursor or whatever you're using. We need to figure out how do we manage context, how we do workflows, I will explain them later, and how we teach AI what is good and what is bad, right? Within the context of our organization. So let's start with the first one. I don't know why. Okay. So let's talk about capabilities first of your organization, what you can do, right? I'm a Kubernetes freak. In my case, it's Kubernetes. And I think it's very, very useful in case of AI because if you do use Kubernetes as some kind of a control plane, some kind of a gateway into your whole system, then AI can discover what are all the things that you can do by going to a single API, figuring out, okay, so if I query this Kubernetes API, I can do this and that, whatever that is. And in this context, that whatever that is could be, hey, through that Kubernetes API, you will talk to AWS or Google Cloud or GitHub or Azure or whatever it is, right? Kubernetes itself is an extensible API. You define what you can do, you create controllers that do that something, and then AI uses that to interact with the whole system, whatever that system is. Now, the problem that we have is that AI agents cannot really discover much from Kubernetes API, which is very, very unfortunate, because API is not built for that. You cannot go to Kubernetes and ask, give me all the resource definitions related to databases, right? Because there is no semantic search, there are no query capabilities in Kubernetes, at least nothing fancy, and so on and so forth. So if you just go and say, here's my Kubernetes cluster, create a database, it will get confused immediately because there are 1,000 CRDs probably. You said database and actually it's called SQL, or you said Postgres and it's called RDS. It gets confused very, very fast. It's very, very slow. And it's really, really hard to discover what you can do. And the key in discovery here is semantic search, right? It's similar to when you go to Google to search for something, right? You don't have to type exact words that exist in some site. Google will figure out that what is the meaning of what you want and find something related to that meaning. That's how semantic search works, right? So what we need to do is to translate something that is good for you as a human into something that AI can understand, and we call that embeddings, right? Embeddings are numbers. It's a multi-dimensional way how to describe something as numbers and convert those, and later on when you query, then you can find what is the closest thing to this thing. Oh, you said database, and I have Postgres over there. That's very, very similar. That's what you need, right? It's a way how to convert text into essentially multi-dimensional numbers. Then we store all that into vector database, right? From where AI can go and query and find the meaning of things. And after that, you ask your agent, hey, I want to create a database. I want to create a database, for example, or I want a stateless application. It goes to the database, finds all the resources that are related to it, and then it knows what to work with, right? It knows what it can construct that will give meaning to what you try to do. Then we have a question of, my slides don't work, patterns in a company, right? Or patterns in a company, right? And policies. Let's start with patterns, right? So what you do have in your company, maybe you don't even realize, right? Is that when you do something, there's a bunch of information stored in wikis that you read, in Slack conversations that you attended, in maybe YouTube videos that you watched, maybe Zoom calls that you had with your colleagues. There's a lot of information that you have somehow and you don't even realize that you have it in your heads. And AI doesn't, right? It has no idea what is all the information that you have. And the solution to that is still very, very relatively similar, right? Come on. Okay. Get all those patterns, scan all the information in your company, wherever that information is. We can do that now. More importantly, figure out how to extract the things that exist in your head, which is very, very bad for your career, because once you extract things from your head, then you're fireable, which is not good for you. But the agent that cannot access all that stuff, right? It cannot go through that, because even if we create a system that will allow it to go through all the information existing, the problem is that models do not have long-term memory, right? Whatever you tell model, oh, this is the pattern I'm using, this is the policy, and so on and so forth, it will be forgotten the moment you start a new session, right? So the same solution, convert those important pieces of your policies, or your patterns, into numbers, put them into vector database, let the agent read it. Same thing with policies. The only difference between patterns and policies, patterns allow AI to know, okay, when you say database, we always use RDS in AWS for a database, right? That would be a pattern. Policy is something similar, yet different. Like, when you deploy a database to RDS in AWS, it always needs to run in US East 1. That would be a policy, right? And the logic is still the same, except that we need additional defense against that, which would be Kyverno, Kubernetes admission, validation admission policies, OPA, whatever you're using, right? So same story as before. Extract the knowledge from your documentation, from your conversations, from everywhere, put them into database, and on top of all that, create policies. So you accomplish two things with that, right? One, AI can go to the database, find the relevant policies, apply them to what you're doing, and on the other hand, if it messes it up, there are admission policies in your Kubernetes cluster that will prevent things from happening. Then we have a context garbage, right? I don't know if any of you, here's a task for you, right? Go to your Kubernetes cluster and instruct the AI to analyze all schemas of all the resources to know what it's doing, right? It will reach the context limit, which is typically 200,000 tokens in like 5 minutes, before it evaluates all of them, right? So we need to think about how do we separate context? How do we separate, this is conversation, this is what I do with AI through an agent. How to separate that from analysis and things that generate a huge amount of data, but only a small amount is actually relevant for what will happen next. And most likely solution for that is do it somewhere else. If you're using Cloud Code, that would be sub-agents. If you're using MCPs like I am, just create your own MCP where you have agent baked in. It will do the analysis. It will do everything needs to be done, and then return things that matter, right? And finally, the big problem from the very beginning, I said something like, I want a database in AWS, right? I did not provide sufficient intent. I did not explain enough to AI what I really need, right? And the way how to solve that is something we've been doing for a long time, which is workflows, right? AI should be designed in a way that it goes back to you and say, I'm sorry, but you're insane. You need to give me more information, right? And it needs to do that intelligently based on the previous context, right? Some kind of a loop that it asks more and more. If any of you worked as a consultant or working as a consultant, that's what we do, consultants, right? Somebody tells you, I want this, and you say why, and what else, and how, and so on and so forth until you get all the information you need, right? So, let's try a live demo. I thought to do the slides, but let's try a live demo to show you all that in action. This is Cloud Code, right? This is the same thing that gave me garbage before. Create a PostgreSQL database in AWS. Now, this is my agent talking to some MCP server that has a separate agent, has a workflow, and says, yeah, okay, let's do it. I I might need to stop the demo if I don't have enough time. Let's see, 7 minutes, that's cool. Now, the first thing that it is doing now, it is evaluating what I told it. Now, if you use normal, typical agent, they're all eager to please. They want to please you, right? And immediately give you the answer. This is going to be different. It is evaluating what is happening, and it is trying to figure out whether that information is sufficient or no. And comes back to me and says, Viktor, soon, most likely it will say, Viktor, you're an idiot. That's really what it says. Can you give me more information? I need clarification. And this is the workflow, right? It's designed to go back and say, Viktor, you're an idiot. Do you prefer AWS? And you will notice that this is all based on what I initially sent. Do you prefer RDS in PostgreSQL? Yes. Do you blah, which region? And so on and so forth. So let's say it should be RDS, PostgreSQL. What's happening here? No. PostgreSQL, what else? Highly available with schema management, right? Now, what is happening now, this will take a couple of minutes. No, this will not take. This will take a couple of minutes. Now that it gathered all the data I need through the workflow, back and forth, you will see a lot of back and forth more. It takes all this information it got so far, and it wants to do that through my Kubernetes cluster. But it cannot, because its CD is horrible, right? It cannot query it effectively and so on and so forth. So what it is really doing is going to my vector database and created a query or a few queries asking, hey, this is what I need. Can you give me all the resources available in cluster? Because everything from a cluster is loaded in vector database. Give me the list of top 50 resources that are somehow related to what Viktor said. And what Viktor said was a database, RDS, PostgreSQL, schema management, and so on and so forth. Find all the resources that are somehow related to that. And once you get all those resources, then go to Kubernetes cluster, right? Get the schema of not of everything that is capable, but the schemas only of those that you selected because they're relevant, and then construct 2 or 3 or 4 solutions because we don't know in advance what Viktor might really need. And once you construct those solutions, go back to Viktor and start asking him more questions like, do you want this solution? Do you want that solution? What are the important pieces of information? And so on and so forth. Now, I will, let's skip. I'll show you the same output faster, right? So this is the output I got. I executed more or less the same query. And I got like, hey, based on what you told me, and based on a few other pieces of information, these are the solutions, right? But those solutions are not based only on Kubernetes API. If you look at the first one, it says DevOps Toolkit managed PostgreSQL database uses organizational patterns, right? That's that when it constructed solutions, it used not only information from Kubernetes API that is stored in vector database, but it went through company patterns, information that I have about how we work in this company, and later on you will see that it went through policies. So it combined API with the documentation about how we do stuff, and it came up with those solutions. And both of them you will see uses organizational patterns, right? One is a custom resource made by me, another one is RDS combination of stuff, right? Did it finish? Not yet. Takes a long time, thinking so far. So after that, I select one. I say, cool, I want that one. Goes back, another workflow continues for a long time. It asks me, okay, so now that you selected this one, what is the name of the database? What is the namespace? What is the size? What is the region, right? And you will notice that those names are not random either, right? Some of them are logical because you need to have a name. Some of them, like region, you will see policy requirement, right? Databases in AWS should run in US East 1 region, right? It, again, retrieve the information from my company policies, from documents, from wherever, and gave me the right choice. Then it continues like, let's see whether that, I finished the demo, look at that. It gave me, what is, four options. Let's do one, whatever it is. And then the next phase will be much, much faster, right? There we go. There we go. I chose one. One was, my own XRD combined with schema and database. And it is based on organizational pattern. As I said before, it's based on some of, at least one piece of information from my documentation. Now it asks me, okay, so based on that, what is the name of the database? MyDB, let's say MyDB, what is the second one? Namespace, and the available namespace, let's say A-team sounds good. What is 3? Provider. Yes, it already figured out that this is required by the policy. Let's say it's going to be AWS PostgreSQL. Database size small because I'm cheap. And region, it already told me that for US East 1, for AWS, it must be US East 1. So let's say that. And it will continue with questions. once it comes up with the, once it gets so annoying with questions over and over again that eventually says, okay, there is nothing else I need from you, and it constructs the solution somewhere, deploy them, there we go. It deployed it to the cluster, it's running, it's validated, and so on and so forth, right? So, what I'm really trying to say here, if you're trying AI today, don't be fooled with the idea that all you need is to fire up Cursor and use Anthropic Sonnet model, and then it doesn't work, and then you start yelling at somebody saying, AI is stupid. It's not stupid. It doesn't understand your patterns. It doesn't understand how you work in your company. And by the way, you can try this open source project. That's what I showed you earlier. It's garbage, but just to demonstrate how it works. So load all the information you have into places that can be accessed with AI, and then it will do something very, very, very useful for you. Thank you so much. We have no time for questions.
So hello again. So I was told that I should encourage you to kind of move towards the center because we want to free up some space for the folks that are actually standing. And you know, in fact, I can see like 2 or 3 black holes here in the audience that we should probably fill. When I talk about black holes, there is actually someone here in the audience who knows much more than anyone else about them, probably. Ricardo Rocha here is actually working in one of the most fascinating places to science on Earth, which is CERN. And there he's helping scientists use AI workloads in order to gain a better understanding of what our universe is actually made of. So please welcome on stage Ricardo Rocha for our second keynote.
I do need to plug my laptop. Which one should I use? I think I used that one before. All right, let's see if this works. Tech. Nope. This is not working. I cannot see it. All right, let me try HDMI. nothing. All right. Does this work? Can you see something? All right. There you go. The hardest part is done. Let me just check if I even have connection and everything. So it's all good. All right. So thank you very much for the introduction, and thanks for the invitation. I'm super happy. This is like an insanely well-organized event. It's huge, really, really impressive. So congratulations already. And yeah, so my name is Ricardo. I'm a computing engineer at CERN. I lead what we call the cloud native and machine learning platform teams. Basically, a lot of Kubernetes, a lot of AI these days as well. I'm also part of some bodies in the CNCF, the Technical Oversight Committee, and the End User Technical Advisory Board. So if you want to talk also community and governance of projects, pick me in the hall. Today, though, I will talk about colliding clusters. We do particle collisions at CERN. We also have a lot of Kubernetes clusters, and what I will talk about a bit today is this idea that actually there's no one cluster fits all, because we have a lot of different use cases, and we had to adapt over the time to what people are actually trying to do with Kubernetes, and this keeps changing. So just as out of introduction, I'm going to assume that everyone knows what CERN is, but just for some context to this talk. So at CERN right now, we have the largest particle accelerator in the world. It's 100 meters underground, 27 kilometers in perimeter. We accelerate protons to very close to the speed of light, and then we make them collide at very high energies in places like this that don't look like this anymore because they're full. This was during construction, but you can see the little person there. These are again caverns underground. We make a lot of collisions, and these act as like gigantic cameras taking something like 40 million pictures a second. Of course, these are not real pictures. What we are collecting is a lot of data. Actually, any of these detectors will actually generate 1 petabyte of data per second, which is a lot. And of course, we can't handle all that data, but I'll talk about this. But you can imagine them as like very large cameras, and then we have to reconstruct these events. For that, we have a large computing infrastructure. We have 2 data centers on premises, but actually that's not enough. So over the last 20 years, or 25 now, we actually built this great computing infrastructure where we put 200 centers around the world connected to each other, and this gives us more capacity. So we have around 1 million CPU cores, and we submit something like 2 million jobs a day. This is all very nice, and we also have one problem, which is in 4 years, 3-4 years, we'll increase the data by 10 times, and we have to figure out how to deal with this with the same budget. So, fun. And this is constantly the challenge we have. That's why we always look to new technologies and new opportunities, because we have to do more with the same, basically. Now, when we started looking at Kubernetes, this is what we thought. It's like, this is going to solve the grid. Like, we built all these custom components over decades, and they are really hard to maintain. And suddenly, we have this community that maintains this amazing tool, and we can replace all these centers with Kubernetes clusters, and it will be amazing. And this was back in 2015, 16. And our vision was we'll have Kubernetes clusters everywhere, and everything is federated. It will be incredible. But actually, Kubernetes was not designed originally for that. It was actually designed for traditional IT services that talk to each other. So you could pull off a demo, but you could actually not have this in production. So it was kind of, OK, we are there. We need to work with the community to improve this kind of functionality we need. But in the meantime, is there something else that we can use it? So we started learning that even our campus infrastructure is quite demanding, and Kubernetes could help us already streamline a lot of that and then free cycles to work on other things. So step 0 was the dream. Step 1 was actually trying, can we scale it to our needs? So we bumped into this blog post by Brendan Burns, which is one of the founders of Kubernetes, when he was at Google, and he described in the blog post, they were trying to do 1 million requests per second in a Kubernetes cluster. This was in 2015. And he actually explained why we all need this. And he said, like, developing a successful product might also include the ability to respond to changes in a predictable way, to handle upgrades elegantly, and to minimize downtime for users. This is what we've been all trying to optimize for many, many decades. And actually, this is where Kubernetes really showed its strength. You would declare what you want. You wouldn't have to care about nodes anymore. You have a lot of tools in the ecosystem that will help you getting the logs, the metrics in a consistent way. It does the orchestration for you. So there was really a promise. But again, if you have to scale, you have to test it. And Google published this scale this test where they would scale gradually to 1 million requests a second, and that was quite impressive. But okay, if Google can do it, can we do it ourselves? So we started in 2016, early 2016, or even 15 still. We tried. So on the left side, you see our own test in our on-premises data centers with 1 million requests a second. And I think it was at the time like a 500 node cluster or something like that. Then in the middle, we said, okay, Google can do 1 million, we can do 2. So in the middle, we did 2 million, and everything was great. It's like, okay, can we do 10? So we tried 10 million requests a second. We scaled it to 1,000 nodes, and then it didn't go well. So you can see it got stuck around 7 million, but actually it was completely blocked. Not only our test, but our data center. We actually brought it down for a little bit. We fried a network switch, which is always something that you can put in your CV. Like, it's not easy. We were all very happy, especially the younger crowd was really happy to be able to have the network team telling us, you just fried a switch, which is an achievement. But still, we could see that there is potential there. You can really scale things. So with time, this is our campus infrastructure. This is not even our core scientific computing. You can see the infrastructure grew quite a bit. So we have a lot of clusters, a lot of nodes, over 30,000 CPU cores just for this kind of use case, many pods. And then even the lower metrics are kind of our registry metrics. So tens of thousands of images and charts and everything. So basically, Kubernetes became the core of all our computing, not only the scientific computing. So that was step one. Step two was like scale and performance. Now we start talking about the core use cases. I was describing the detectors just before, and then things get real. They get real because, as I mentioned, a detector like Atlas that we saw in the picture before generates 1 petabyte a second of data. And this is not something we can handle. So what we've done traditionally is build these custom hardware components that are really good at filtering the data in nanoseconds. They reduce this in a CPU farm. So there's multiple layers. There's a hardware layer, and then there's a CPU farm that is close to the detector on the ground that will eventually reduce this amount of data to something like 10 gigabytes a second. But this has to happen really, really quickly. So for that, we traditionally use clusters with something like 3,000 nodes, and we have to have 30,000 applications running. Now, the trick here is that because this has to be quite dynamic, and when we are doing collisions, we call it a beam, beam running, and then sometimes we stop the beam. And when we stop the beam, we want to change what the cluster is doing. From 30,000 applications monitoring the beam and doing the filtering, we want to do simulation to not waste the resources. And this means we have to be able to change the workloads really quickly, and then when the team says the beam is coming back on, you have to redeploy 30,000 applications really quickly. And really quickly means in less than a minute. So we started testing this back in 2017 with Kubernetes 1.5. Who used Kubernetes 1.5? Yeah, painful, huh? Not good days, huh? It was not the same as this today. So, but it was quite fun. What we detected is that we could barely do like a couple of pods a second, maybe 10 a second. If you want to deploy 30,000 in less than a minute, it becomes really, really complicated. So we tested with, before we tested with a cluster with 1,000 nodes at the time. And we were seeing scalability problems that were not the size of the cluster. At those days, everyone was having 1,000, 2,000, 5,000 nodes. But our problem was not the number of nodes, was how fast we can deploy things. And there were a bunch of scalability issues. So what we did is we kind of tabled this exercise, and we worked with the community to improve the scalability. So we worked with SIG scalability in Kubernetes, and there were a lot of changes going on. And the result is that we redid the same test in 2022 with Kubernetes 121, 2,500 nodes, and basically we are fine. So we can actually deploy 30,000 applications in less than a minute, have them all up and running, and after an hour or 6 hours of Beam, we drop it, deploy something else, and half an hour later, we do it again. So the result is that what you see, like the core of our experiments that are generating all this data, in just 2 years, will be backed by a gigantic Kubernetes cluster that will run underground with 5,000 nodes in this case, because we can, and it just works. So this is a huge changer for all the teams involved. Now, step 3 is really back to the future, and because we are in the AI era, and we just heard from Viktor talking about AI, who remembers this movie? And there's a moment where he says 1.21 gigawatts, and it sounds crazy, and he's like running around in the room. We are not far from it. Like when you see what an H100 is picking and what B200s will request in terms of power, it starts getting as scary. So sometimes dealing with GPUs these days, I feel a bit like the same when running around the room. So, but it's really going back to the original dream, which is, can we use Kubernetes also for these core scientific computing cases? And this is what I will talk about in the next couple of minutes. So the things that were missing for us to achieve this dream were the ability to cross boundaries, to not have a single on-premises data center, to link different infrastructures together. This was not easy. It's hybrid deployments, but we are there now. High throughput. For us, it's very important. You saw like 2 million jobs a day. You need to really be able to throw a lot of jobs and monitor them and all of this. Traditional batch computing, basically. No more awareness, and I'll talk a little bit about this in the demo, where you need to really optimize the node scheduling so that when you're using a GPU and you're doing CPU usage as well, you're aware of these needs that exist in the system itself. Like we all live on the layers above, but actually you need to optimize also the lower layers. And this also is available now in Kubernetes. Software distribution, we have a lot and we need to push it. And then traditional batch primitives, things like gang scheduling, quotas, queues, all these primitives have to be there. Now, this was not there when we started. It's all there now. So this is a very impressive feature from the community. And what I will demo the rest of the talk is a new platform that we have dedicated to AI and ML. And basically the idea is that we have these shared resources, which are a set of Kubernetes clusters that are sometimes on premises, sometimes on cloud providers, sometimes even in HPC centers, but we kind of abstract all of this. And the key thing is what Viktor was also mentioning. We have to meet users where they are. Like we did the first demo of this platform to our users, and we told them, so you use kubectl, and one of them raised their hand, what's kubectl? And we said, oh, well, it's Kubernetes. What's Kubernetes? And they all left. And then we came back, and we showed them an alternative, which is use SSH. Like you're used to SSHing to a machine or a shared pool, you can do it. And you won't even see you're on Kubernetes. Or use Jupyter Notebooks, or use code. And then they're all happy. And in reality, they give us the freedom to play with the infrastructure, but we are giving them the interfaces they want. They can run GitLab CI, GitHub Actions, interactive access with all these options. They can do MPI. They can do distributed training with Kubeflow or serving their models. Everything is abstracted in the same way, and we can really separate the infrastructure management from the user experience. And this is where things really get interesting. So the last bit before the demo I'll show you, but I'll also show you some plots, is that the other thing that people really like is that when they were using machines, nodes, logging in here, there was no really separation of the workloads themselves. Like there was no individual workload management. with Kubernetes, this is one of the main advantages, is that if you're using your Prometheus, you're actually monitoring the pods, and the pods are the workloads. And suddenly, they have all these dashboards available that will tell them how much GPU utilization they are having for their workloads, no matter where they're running, cloud, local, HPC, whatever. They will see they will see the power matrix, so they can optimize and get this feedback live. So all of this is really a game changer also for our users. And it's really thanks to the stack we are relying on. So I'll go to the demo quickly. So in this demo, what I'll do is I'll show you how this usually looks. So the only thing that right now some users need to know is to build this YAML. But if you're using notebooks, you don't even have to care about this. But if you're using command line, you will have to deal with a pod, but it's just YAML for them. And then you will have some capabilities you want to enable. In this case, it's file systems. You'll tell the image you want to use, and you can customize. But we offer what we call LX Plus-like, which LX Plus is the environment they are used to. So that's the default. And then you say how many GPUs and which kind of GPUs you want. And I already created a couple. So you can see here, hopefully. All right, so here you have one example. So what I will do is I will actually kubectl. And this is what they didn't like. But I'll start with it. And here you see, like, I get my pod, but it's just a session. It would be a node. But one advantage is that when you're in a shared environment, you're kind of not fully isolated. But in this case, you can see this is my CERN ID. I have my usual file system here, my home directory. I can also be sudo. This is like when they were like, okay, you mean I can also install my own packages? Yeah, you can. It's your environment. You do as you wish. If you don't have it in the image, just install it at runtime. It's fine. And then, of course, you have your GPUs, which is what they care about. In this case, I have an H100 NVL. And they are fully reserved for them, fully isolated. And this is really like, they are getting the interfaces they want with much better isolation and functionality. So what I will do here is I will just start stressing this GPU, this node. And what I will show you is what happens here. So now this is where it gets interesting, because I'm stressing this node, but you see, like, in the green ones where you see some percentages, you see that the load is being done as Kubernetes does it by default, which is it fractions the load over all the available CPU cores. If you're doing any kind of high-performance computing, this is a game, like a no, it cannot be, because it's not reproducible. It depends on what else is running on the machine, so this doesn't work. So this was one of the things that we also had to work with the community and learn how to do better. So keep it in mind, in this case, it's really not working well. But let's do the same. I mentioned you, no one likes kubectl. So what did we do? Like, you go to your sessions, and now what I will do is I'll just tell the cluster and the name of the session I want. And I'm just SSH. And again, I'm in a pod where I'm my user. I have my GPUs. In this case, I have 2 GPUs with fully interconnected. And again, I can also sudo as before. Now, the main thing that I'll show you here is that in this node, I also did something better, which is I'm stressing the node, and you see that only some CPU cores are being loaded. So not only I'm isolating the number of GPUs, but I'm actually pinning the CPUs and the GPUs. And this is this notion of NUMA awareness. If you're doing scientific computing, this is what you need. And we can do this now with Kubernetes environments, which is pretty cool. Now, the third thing I mentioned is that they like SSH, but of course, they like code as well. So let's see how that looks. And I'll delete this one. So here is my code. I have my Kubernetes cluster, and then I will go here, and I have here another session. And what I'll do is attach. I'm sure everyone has done this, but if you're a scientist, this is really impressive because they don't have a lot of capabilities like this. So what I will do is, again, I got a session in my cluster, and you can see here. And again, if I do the same, I'm my user, I can sudo, And in this case, I have also 2 GPUs in this session. So what I'll do is I will also stress this one. And here you see that half of the cores are being used. This node has 4 GPUs. I'm isolated in this session with 2 and half of the cores. So in this other session, I'm actually taking the other 2 GPUs in the same node. And here, again, like the node is fully loaded. And this is exactly what we want, like reproducibility and predictability when you're doing scientific computing. And you can see just that some CPU cores are reserved for the system, and all of this is predictable. And this is where we kind of meet halfway. We give them the HPC capabilities they expect, the high-performance computing capabilities, but we use the traditional cloud APIs that everyone wants so that we can build on the usual tools. The last thing I'll show you is the monitoring. So this is live. All of this is running on the production infrastructure at CERN. So in this case, you can see that it's my area. I'm stressing a bit the CPUs. So you can see, as a user, I see how much I'm using. In this case, the CPU. I'm actually not using the GPU with this workload. I can see the power I'm drawing from all my workloads, and I can see my individual workloads. So I can also go here and see what each of my workloads is actually pulling individually. So this is where really we give a huge advantage to people that are trying to optimize their workloads. And that's what I have for my demo today. I will just finish with this. I explained a bit the journey we had at CERN. I think the main thing is that it really takes a village. It was a huge effort that we would never be able to do by ourselves at CERN. This is changing how scientific computing is being done all over the world, and it's really enabling us to push even further the capabilities we have internally. So thank you very much.
Thank you. Wow, the scale of this and talks like this kind of give me goosebumps. I mean, if we want to land on Mars in 10 years, it's good to know what's between here and there. Our next speaker knows a thing or two about scale and could probably write a book about scaling teams and companies, but she's probably not doing it because she is busy actually doing that in practice. Please welcome our next keynote speaker, Diana Stefanova, who is a managing partner at Brightcap Ventures.
Just give me a second to plug in. Good. Yeah. So maybe your IV team can help make sure that it comes up. Before that, while they're doing that, thank you for having me here. Thanks, Orlin, for inviting me. Thank you for having or being interested in hearing a different view, actually. Reality is that when Orlin called me a couple of months and said, hey, do you want to be part of our event? I was just puzzled. I said, how can I help such a great tech community like yours? And the reality is, it got us talking. I'm an investor today. And for a tech community like yours to understand that investors' view of how we look at startups, how we look at innovation, and what we invest in is key. So I felt like, yes, probably there's something we can learn from each other. So I agreed to be here. So thanks for inviting me, Orlin. It was a wonderful, wonderful experience to get to where we are here. So today, I will present a completely different view, the investor's view, not that technical demo that you looked at earlier, and hopefully that adds to your knowledge of how we are looking at investments, AI, and how AI is redefining cloud native, which you care about. So let's see. Before that, let me make sure I introduce myself properly, although I think you heard the highlights earlier. But how did it all start for me? The story even early days at school, started through a conversion between technology, math, and finance. I went to the Sofia math school, very good at math, computer science, but interestingly, when the time came for university, I decided to do finance. This defined my whole career going forward. It was all about convergence between technology and finance. My career started actually in Silicon Valley, where I was there during the dot-com boom. I worked for a couple of wonderful startups. One of them was successfully sold to Liaison Technology. And I was running their finance teams. But all of the companies I worked for were in the high-tech industry, from small startups all the way to big enterprises like VMware. In 2004, I returned to Bulgaria, and I was leading the finance as a CFO for Cyient, the company that was acquired by VMware. This is when I was given the opportunity to lead, as a general manager, VMware in Bulgaria. Later, my scope expanded to EMEA, then globally, and I learned a lot. We achieved as a team a lot. This is the phase of my career that I call, I chose finance, but technology chose me. And this is where I felt I need to do something different. So in 2024, I joined Brightcap Ventures as a partner. Now I'm an investor. And now, through my finances, I help technology. I fuel technology. So this is where the convergence of finance and technology has really defined my entire career. And this is where I think I have something to share with you. This is the cloud-native community. And as an investor, what we see today, every single startup that we talk to is defined somehow by AI. Not a surprise, right? We see AI as a critical trend, tech trend, but at the same time, the cloud-native platforms are the ones defining or running AI. So, excuse me. AI is no longer just an application that is running on the cloud. What AI is, it's really redefining cloud-native infrastructure. And I'm sure none of you will be surprised with the new term, cloud-native AI. Sorry, my clicker is not working, so I'm going to be coming back and forth, so apologize for that. But anyways, if somebody can fix the clicker, that could help us with logistics. But anyways, investors, how do we look at opportunities? First, of course, we start with the team. This is critical. We assess the team. How smart, how innovative, how resilient and determined to succeed the team is. This is number one. Number two is the idea. How interesting and how innovative the idea is, and is it solving a real problem? This is very key, and I would like to stress it. Is the solution that you're bringing to market solving a real problem, or we are just innovating because it's very cool? And sometimes that's something we need to remind innovators, because they're so hyped up about something really cool that might not see how this fits on the market. I'm not going to spend time on these two areas. What I would like to spend time on is the market in the cloud-native field with the intersection with AI. Recently, I got an opportunity in the cloud-native space. Actually, it's some ex-VMware colleagues of mine in US. And I had to do a research. And this is where we start, defining how big is that opportunity. Can this opportunity and idea be a real global business, reach global markets? Can it sustain multiple players on that market? In reality, the cloud-native platforms market is growing significantly. In 2025, it reached almost 8 billion, and with a growth rate of almost 27%, we expect it to be over 60 billion in 2034. I don't think it will be a surprise when I mention the cloud native. One second. Okay. Is the clicker working now? Okay, good. So it's going to be easier. So cloud native and Kubernetes are now the foundation for high-performing, cost-efficient, and flexible AI workloads at scale. No surprise here, right? I'm sure that you see that every day. That market opportunity, this market growth, though, comes, of course, with some pain points or challenges. And that's good, because there's something we can go solve for, and some new businesses can come out of it. Number one, no surprise, the Kubernetes complexity and cost are of a concern to the big enterprises, to the customers. Because there was a research and a survey, and it's like over 90% of the people that were surveyed basically said that they see challenges with Kubernetes complexity and management of cost. Number two, the fragmentation of tools that are being used actually are creating a lot of difficulties and pain points. So there's a huge demand for standardization. Number three, there's a skills gap. This huge growth, a lot of change, a huge transformation, of course it creates some challenges because a lot of tasks still are manual. So there's an opportunity to really address that by introducing some automations through AI, but also uplifting the entire skill set and knowledge. Number four is again related to cost visibility. The lack of cost visibility and control over cloud spend is a challenge for almost every organization globally. And this is why we're seeing a surge and a rising adoption of the cloud-native FinOps platforms. So these are the four challenges. Of course, there's many more, but I wanted to highlight the top four that my research showed. With challenges come opportunities, right? This is an opportunity for us to go solve these challenges, create new businesses, hopefully multi-billion-dollar global businesses. Number one, the overarching AI-powered automation. This can help us with managing cost, with optimizing resources, with standardization, with making sure that we have deployments at scale. No bottlenecks. Just imagine a self-service DevOps with human in the loop, the cloud-native teams being in the loop, that is able to deliver and provision infrastructure at scale. Number two, AI resource optimization. The reality is that AI workloads, LLMs, they're really sizable, right? GPUs are expensive, different, and difficult actually to procure. So for us to optimize resources is key. So a few areas to invest in: predictive scaling, and intelligent provisioning, cost optimization, cost management. Those are areas of opportunity that, of course, we see some solutions in, especially on the open source side, but definitely there's more to come and more opportunity there. Number three, I mentioned that earlier, the demand for standardizations. With AI, LLM workloads, we see sizable workloads that in the AI space could be in billions, trillions parameters, as you can probably tell. So GPUs, as I mentioned, are expensive. Tools are very, very dispersed and different and fragmented. Different libraries, versions, different platforms, different hardware. This creates a lot of difficulties when it comes to standardization and when it comes to automation through AI. And number four, no cloud lock-in. Every single enterprise is basically saying cost control is a challenge. Cost visibility is challenge. And with the growing AI workloads, that becomes even a bigger challenge. So the ability to offer multi-cloud solutions is going to be key, and it's going to be factors for success going forward. Now, having in mind all these 4 opportunity areas, AI-powered automation, AI resource optimization, demand for standardization, and multi-cloud, let's look at the ecosystem. These are just examples of a few companies that I looked at, and not a fully comprehensive list, but there's at least 3 companies that I started looking at that are trying to automate through AI agent the entire cloud-native infrastructure provisioning or the entire life cycle. I'll start with Encore Cloud. They're probably the oldest of the 3. They were established in 2020, started with AI DevOps automation. Now they're bringing to market a lot of AI offerings and AI agents. They're Stockholm-based, and so far they have received 4 million of investments. I'll refer to the investments as well. This is public information, just so you get a feel that investors' money are going in this space as well. StackGen is a San Francisco-based company. They were established in 2023, and they have received 12 million of investment so far, very early. All 3 companies are at pre-seed or seed stage, so that's early in the process. And Ingenimax was just established in 2025. This is the company that I mentioned earlier, ex-colleagues of mine at VMware. They're US Silicon Valley based. They have received less than $1 million, but they are starting to fundraise. They're starting to attract customers. Again, AI agents that are automating the entire life stack. Again, this is one side of the ecosystem. Of course, the open source ecosystem is more vibrant, and there's really more solutions and offerings in that space as well. In fact, all of the startups that I mentioned above are integrating with a lot of open source solutions. And just a few of them that I mentioned here, for example, Kubeflow and TensorFlow, they really are focusing on deploying and training the model side. One on Kubernetes, the other one is on a more comprehensive set of platforms. Then Kubernetes GPT, that's helping with AI manage the Kubernetes clusters. Then you have the model context protocol that is connecting, the open standard that's connecting the cloud-native infrastructure with different data sources, external data sources, and tools and services. So there's a vibrant ecosystem there, but still yet to see a comprehensive solution in that space. And that creates some challenges, right? You have to mix and match different solutions from the open source community to build a solution that matches one enterprise's needs. So that's that side of the business. And of course, the ecosystem also has the big hyperscalers. AWS, Google Cloud, Microsoft Azure, all of them have proprietary solutions, but also have open source solutions, right? And the specific for them is, of course, they optimize for their own clouds, right? Because they want the workloads to run on their clouds. So considering all of the different dynamics in the ecosystem, there's definitely an opportunity for collaboration between all 3. Open source runs across all 3, but definitely there's an opportunity for sizable businesses in that space. Hopefully that was a quick summary that gives you a sense of how we investors look at opportunities, emerging businesses, new ventures. There's no doubt, I think, in all of our minds that AI will impact every aspect of our lives. And cloud native would be key. The cloud native infrastructure would be key for enabling this transformation. This is the best and the most scalable platform to run AI. This is why my call to action to all of you, please be active. Think about the new opportunities. Think out of the box, because we need you to make that transformation, to help us through that transformation, bring new businesses and opportunities to the market. Because for AI to thrive, we need cloud native to thrive. So thank you so much.
Thank you. So after this set of exciting keynotes, we are going to take a short break, and I invite you back here at 10:30. I want to quickly remind you that there are still spots available in our the workshops that we are organizing. So if you're keen on participating, please do so. See you back in a couple of minutes. A set of talks that actually are going to have Q&A after them. So there are a set of mics in the middle of the hall that you can use for the Q&A part of the talks. And we're going to most likely limit the amount of questions to 3 in order to have more time for breaks and the whole community thing happening outside of the hall. Our next speaker who's going to come on stage is someone who, during the day, solves some of the toughest DevOps problems as a CTO at ITGX, and during the weekends is chasing adrenaline on a snowboard. So please welcome on stage Mihail Vukadinoff, who's going to talk about RAG.
So hello, everyone. Hope you can hear me well. Let's see if the slides come up. So today we'll be talking about retrieval augmented generation and how to do it easily using the EKS Automate in AWS. A bit about me. So hi, I'm Mihail, CTO of ITGX. So yeah, we are helping companies and organizations with their cloud adoption and also automating the software lifecycle processes. But enough about me. Let's see what we'll talk about. So first, we are going to go through the problem that we are addressing, what we are trying to solve for the so-called knowledge overload. Let me see, do this. So yeah, then we'll see what is retrieval augmented generation, then why are we using Kubernetes. I'll show you a real-world example of one of our partners, one of our customers, and then hopefully we can see the demo environment, which is a kind of a scaled-down version of that, and do a live demo. So first, the problem of knowledge retrieval. So yeah, now organizations are building large databases of internal documents and generally knowledge, which, yeah, when it's very big and when it's fragmented between multiple data sources like Confluence, document management systems, and so on, it can be hard to get what you are looking for. So typically, yeah, AI-powered search or large language models can help with that, but they come with their own set of problems. Like, for example, data privacy is a big one. You would not like your private data of the organization go out to whatever, ChatGPT. And the other thing is hallucination. So large language models, as Viktor showed, they need the context. They need to know what are your specifics. So why RAG helps? It helps us, let's say, not need to build our own complex models, but work with some of the best ones, providing just context. it gives us better accuracy and less hallucinations, and yeah, of course we can keep our data private. So what is retrieval augmented generation? By a show of hands, who has a slight idea what that is, or a good idea? Who? And who doesn't have a clue? Okay, and the rest, somewhere in the middle? Okay, I'll try to explain it. So first, yeah, what it does, it helps uses the generative functions of LLMs, which are good of writing natural language and yeah, structuring code and so on, but providing it with good context that yeah, would help us solve our particular question or task. So if we see the flow there, what we start is, you can imagine this as if we are training our database, but what we are doing, starting with our documents or data sources, databases, code, repositories, README files, and so on, we chunk them up to small pieces of, let's say, sentences, a couple of sentences. Those go through embedding, what also Viktor explained. We will talk a bit more about the next slide. So what you need to know is, yeah, through the model, we are turning this into numeric data, which we store in the vector database. This is down there on the right. Next, when we have a task or a query, we write our prompt. This is also getting embedded. It does a search in the vector database and pulls out the most accurate information that yeah, corresponds to our search. Then on the bottom right, it actually combines our context with our prompt and sends it to a large language model that would formalize it and then send back the response. And the good thing is that, yeah, using this, as mentioned before, many LLMs have a limit of the context that we can send to them. So yeah, it's important to tweak how much we are actually sending. And yeah, these are part of the things that you play with to get the best results. So more context can lead to more, let's say, inaccurate data, but yeah, less context might not be enough. So yeah, what's the process of embedding? So yeah, if we get a sentence, running it through the model would bring out a multi-dimensional vector. This is like a set of numbers. Each number, like a parameter, is representing how close by meaning is this word, sentence, or text to what corresponds to this parameter. Like, is this code? Is this, I don't know, geographic location or whatever? And this helps us. So if we imagine the vectors in a three-dimensional space, they would look something like this, but typically we use multi-dimensional, so 768 number of parameters, something like that, which you cannot imagine, but it works basically in the same way. When we are trying to find things that are close by meaning, we're actually looking for the closest space between the two vectors, or the Euclidean distance. So the closest ones can be put out with our parameter saying how much we need to get. And what the system needs to do is calculate many times. Let's say this, one of the ways is with this mathematical function. Unfortunately, I cannot really explain you this too good, because in the university, when we were studying math, I would not need this, and yeah, I'll be a programmer, I will not need this. Fortunately, people like this paid attention, and yeah, they have all the science and mathematics that now drives the AI progress. Anyway, for more plain example, what happens? So we have here 4 sentences. After the embedding, they would look like this is shortened version of the multi-dimensional vectors. And if we do a search query, the query itself would correspond to a vector. And if you see the numbers on the question, what is the city, what is the capital of France, are very close to Paris is the capital of France and the Eiffel Tower is in Paris. And they are way farther from the other two sentences. So yeah, this is how we are pulling the context. So why Kubernetes? It's a fairly complex system. Many data engineers use the SSH on machines or whatever. So one answer could be because it's interesting. Probably some of you remember the Ninja Turtles and how Donatello used to make coffee. Yeah, sometimes when it is complex, there are more moving parts and something could go wrong. But there are benefits of using it. So why Kubernetes and why automode in particular? So what is very hard is to set up your environment from the scratch. So you need to set up drivers for MVA. You need to do all of those things. There is no dynamicity like, you purchase this big machine with a GPU, you paid a lot of money for it. Are you utilizing it well? When would it make its return of investment? So yeah, with EKS Automode, for example, in AWS, we have this built-in dynamic resource allocation, which helps us easily position our pods, so tell the scheduler when we need a GPU exactly, and with the Carpenter integration, it can spin up machines just when we need them. So typically you would see afterwards in the example that we don't need GPU all the time. So depending on the, if we're hosting our model ourselves, or as you see in the example, we have other means. So that's the thing. These are the expensive machines that we really want to keep at low. So yeah, all the drivers and everything is already installed, and you get it out of the box and can use it from Python code or whatever. So in the real-life example, I wanted to show you. So this organization, really big organization, they are behind some of the most advanced mailing services in the world. So they have data everywhere, like they have their documentation, which is publicly available. They have their internal documentation in Confluence that has more than 100,000 pages across many spaces. They have infrastructure as code, all sorts of repositories, README files in the repositories. They have scattered PDFs in document management systems, mails, Jira tickets, all of those Slack messages, all of those hold really useful information, but you cannot really make use of it because it's hard to search. Even many of the people there said something like, Confluence is useless. I put up my search terms and it gives me nothing useful. So why did they need it? Something like initially they wanted to do this manually, but very often they want to rewrite their whole documentation structure in a different way. They have often audits which require certain types of information and answers to certain types of questions like security audits and so on. And some customers would require the documentation in a proper format. And there is always this problem with outdated documentation. So they've gathered this for more than 10 years. Some of the pages are not even relevant. So this is something also to consider. So what we did, we built this platform, which is based on some, a platform that we developed to run AI workloads, and had a custom retriever there, an embedding job, which a parsing job, which is kind of an agent that goes around all sources, collects all data, and after this is getting embedded. I'll show you in the flow afterwards. We basically run an EKS cluster, which talks with Amazon Bedrock, which is a service by AWS, which allows you, it's like an interface to many large language models. And it helps because the API is similar, let's say, almost the same, but you can switch models easily. So what's important here is we use the DeepSeek model here. in this example, we want a like an open source self-hosted model. Like Amazon is hosting some of the models like Mistral, DeepSeek for us. And yeah, it does all the computing and inference, which can be GPU heavy. And we don't need to run the model ourselves. We could do so. And yeah, by the way, there are interesting talks afterwards, which will show you things like Kubeflow and other tools, which allows you to run your model in the cluster. But then you would probably need the GPU all the time, because inference, I've tried it with DeepSeek. Without a GPU, it gives one word for every 2 seconds, like for the response. It's really, really slow. While with Bedrock, you are actually paying only for the tokens, so it depends on the use case. And yeah, the beautiful thing is that we only need GPU, for example, for the embedding. So we would fire up a GPU node only when the embedding job runs, or when we need to refresh the data, or we need to recreate it again. And then everything else can run on normal nodes, which are only with CPU and are more, let's say, less expensive. What we are doing, as I said, the parsing job would go through all of the document sources, normalize the data, add some metadata fields, store it temporarily in a MongoDB, and then the embedding job would run. That would vectorize this and store in a vector database. In this particular example, we are using this quadrant or quadrant database. And what is the pipeline when someone issues a prompt? So in this particular case, to get better results, the prompt will be transformed a bit. Then it would query the vector database that would retrieve relevant context, combine it with the prompt, send it to Bedrock, which in turn queries the local DeepSeek, and then we get our response. And this can be, like in this particular example, we were working more with like Markdown files, so it would issue it out as Markdown. In the demo environment, we're actually doing somewhat similar, but it's simplified. We switched the model, by the way, to be more interesting with the Anthropic one, and we have everything running in a single pod, like instead of a job. So both the embedding of data, then the queries and so on would go to the same backend for simplicity. And we have a UI, which is like a chat window, which I'm going to show you now. And we have a slightly simplified pipeline. See, we don't do any additional things like transformers and so on. We go directly to generate the response. And for the demo, we would be using our container platform. And by the way, I urge you to try it out. You can launch it very easily on AWS. I can show you how. And it includes in the template the demo application, which can serve as a blueprint if you're doing other AI workloads. And by the way, the next steps in the organization that we are working with, if everything proves to work well, we can go to agents that can actually do some of the daily tasks. Just keep in mind that if you're using the the UI to generate your configuration, select the AI workloads ready profile. And so, let's go to the demo. It works. So I have recorded this part. Is this visible? Oh. So because we don't have a lot of time, I'll show you how I've recorded the provisioning of the entire thing. So this is the raising of the Kubernetes cluster, the Bedrock settings, inference profiles, the authentication between the two with YAML roles for service accounts, all the policies. Then it deploys the things we need in Kubernetes, like Argo CD, which helps us then easily maintain our workloads and configure them through GitOps, through Git repositories. There will be an interesting talk afterwards about that as well, and a workshop, by the way. And I think even in parallel now, another workshop runs, which is letting you experience the AWS EKS in auto mode. So while this is running, we have time. I can show you afterwards the result. So we would have Argo CD. Okay, that's not great. Which has our rack demo application deployed. We can probably look at the logs here, and yeah, we have our chatbot tab, which yeah, now I can ask it a question. So yeah, in the background it seems like the platform is being provisioned with Terraform, but yeah, as I said, I already have one, so we don't need to wait for it. I already have one provisioned. So we can use it, let's say, with documentation of yeah, how to use this platform to see if it can help us. Now, the vector database is empty. So if I ask it how to so it will code the backend, and it would say, I don't have enough information to answer you. So this is a good thing, because yeah, one of the problems of the LLMs, when you ask them something, they always give you an answer. In this way, they're like my wife. So even if they know or don't know, they would still give you something. And this is not always good. Like it can turn you in the wrong direction. So if we provided some context, so I have the README, for example. I'll send it here for embedding, and probably here we would say, yeah, started document indexing, yeah, bunch absorted and embedded. So this is fast, but it's kind of a small PDF. So if we ask this again, yeah, it seems a bit slower because we don't see in real time how the model behind AWS Bedrock generates the words, but it would give us the response back. And yeah, here now when it has the README, which has this scattered information, it has it ordered here, saying, yeah, of course, sorry, formatting is not great, it's just for demo purposes, but yeah, it would give us even the commands and so on. So if we ask something like this, probably it would not know. So we can give it stuff like information from the marketplace. Yeah, we can give it info about the AI profile. And by the way, it's better if we send this in the background for embedding, but those would be pretty quick. I can give it sample configurations. Yeah, something about Argo CD. I hope this all worked. And those are all small files, so they are pretty fast. How much time do we have? Okay. And if I ask this again, and by the way, we can see here how in the works. Wait, it didn't. I think it didn't complete its work anyway. Give this a try. So it says, yeah, searching in quadrant, sending to LLM, then gives us the response. And yeah, we get out of all those documents the proper context, giving us the price per gigabyte. So yeah, see, very cheap. And if you want to say, hey, how can now it should be able to hopefully generate something. And it's very interesting. We were talking about you don't always get the exact same results when you do the prompts. This is because of some randomization in the vector search. But it can give us also what we need to set in the configuration. And this can be extended if you have an agent. It can do this for you. And as Viktor showed. So one more interesting thing I wanted to show you. And here I see in the background the other set completed. Let me clear this up. So we were talking about GPUs and efficiency. So we were working now with small PDFs, just for the example, but typically we would have way more data. You remember, like hundreds of thousands of pages and different documents. So we get this bigger one, which is roughly 350 pages. It's about PCI DSS. This is one certification that, for security, for systems that host data about debit cards or credit cards. And we have a profile in the platform, by the way, which is certified with this. So in a bigger one, we would actually see it would take a lot more time. And just to have time for questions, I pre-recorded this because we might need to wait for a while. Let me try to show you. If it's visible. So this is when I did a comparison. So with this same document, if you see, it took like roughly a minute or so to go through all the 315 pages after it got split to pieces. And when we are launching this on a GPU, the same thing actually happened for 3 seconds. So it's by a magnitude, like a big difference. And as I said, typically you don't need this all the time, but when you're doing the initial embedding of the huge data, or you found out that you can optimize it by adding more metadata or collecting it in a different way or changing the chunk size, and you need to do this all over again, then the GPU really helps because it speeds this up. So what I do, if this is the values file of the application that we have, and because the EKS auto mode has this built-in. Apart from requests and limits, we can have resources that are like NVIDIA GPUs. So we can tell this. Oh, and if we push this, eventually Argo CD will recognize it and reschedule just to check. Did we? So it completed also here, and you see in this particular case, it's 15. So again, a bit more than 1 minute, right? Something like that. Okay, I'll not wait for this to refresh. But because this might take time, as to be easier, we are keeping our small embedding model in the container image. Typically, you would cache this like on an additional volume, EFS or whatever. So every time you start, you don't need to download the whole thing, which is kind of bigger. But this might take time. I actually recorded this yesterday. Let me see it. This thing. To show you what's happening. So when we commit, Argo CD would change the requirements. It would start a new pod, which in turn would say, hey, I need a GPU node. And this Carpenter tool that it's now built in EKS auto mode would create a node claim saying, hey, we need a node with a GPU. Again, you see we are using spot instances. So after a few seconds, the node would be ready to use, and then it would schedule the container there and start it. And as I said, this is kind of the variable thing. So because the container is big, it takes a bit more time to download. So here I'm impatient and I'm checking. Come on, be ready. And yeah, after this is done, we get the container on on this new node. Yeah, Carpenter would let go of other nodes that we don't use, so we don't need to pay for them. After the job is finished, yeah, you can Carpenter would automatically terminate the node if there is nothing scheduled on it. So yeah, this is what I wanted to show you, and eventually it would happen here, but we'll probably need a few minutes. So I will not wait for that. And after the presentation, I'll make sure I'll shut down this pod because I don't want to pay for this GPU node. It's pretty expensive. So yeah, thank you very much. This was everything I wanted to show you in the demo. And yeah. We have time, I think, for 2 questions, maybe. So yeah, if...
I've got a question. How do you deal with semantic collisions when you have a corpus of like 100,000 documents and they're all very similar to one another?
So the question is how we deal with the semantic differences?
Collisions. So if you have version 1, 2, 3 of a document.
Versions, okay.
Or
when we have so many documents. Yeah. That's a good question. Well, we were actually looking only at the latest versions of the documents. So if you take Confluence, for example, yeah, the parser would go and look only through the latest, and also keeping the metadata of the like the timestamp when this was edited. So this helps us afterwards for also sorting the relevance, like prioritizing the newest information first, let's say. So,
thank you.
Thank you. Another one? Okay, thank you very much.
So the next person who's going to come on stage is actually someone who we can learn a thing or two from about building community. Why? Because she's a CNCF ambassador and co-organizer of KCD Bilbao and an organizer of a number of KCD events just like this one. So I hope after the conference she can give us a bit of tips about how to do better next time. But until then, she's gonna talk about securing clusters with Kyverno. So please welcome her on stage.
Thank you. Let's see. Did we get it right? Thank you so much. Okay. Here we go. That was a very lovely introduction. This is an amazingly organized event and a fantastic community, so I'm not sure I have much that I'm going to teach you. This is an example of community power. It's phenomenal. So my name is Cortney Nickerson. I'm head of community at Nirmata, the creators of the Kyverno project. When I'm not being a mom, which takes up a massive amount of my time, I am a CNCF ambassador. I co-organize CNCF Bilbao, and I'm an active member of numerous other CNCF initiatives in the cloud-native space. Today, I'm going to be talking to you about how platform engineering teams can actually build secure, compliant, and scalable Kubernetes platforms with Kyverno. And to try to make this a little bit more exhilarating, we're going to look at this through the lens of Formula 1. I have a motorhead at home, so this is where this is inspired by. My husband loves anything with a motor, and now my son does too. So trying to learn and incorporate into my world as well. Just like racing, Kubernetes is all about balancing speed, safety, and rules in the track. So we're going to see how Kyverno can help us do that.
In Formula One, drivers are super fast-paced, they're innovative, they're always looking for an edge. And developers are just like those drivers. Their job is to go as fast as possible, innovate as much as possible, and find the advantage at every turn. And just like a pit crew, platform engineers are there to facilitate the needs of their driver, right? They're supposed to be taking care of the car in Formula One, but they're also supposed to keep things safe, efficient, compliant, so that the car and the driver successfully finish their race. Success in racing depends on balancing three things, which is speed, safety, and compliance. Too much of any one of those things, you're going to lose out on the others. Software delivery is very much the same way, which is why both racing and software delivery teams need guardrails in place. Guardrails like Kyverno to keep people on track. So let's take a moment to look at the reality that is oftentimes in front of platform engineers. Most incidents in Kubernetes come down to misconfigurations, which in my mind are the same thing as a lack of policy, massive policy gaps. 73% of production incidents are traced back to missing or broken configurations, which are a lack of policy guidance. On average, platform teams still do around 47 manual checks and security reviews each week manually. So just think about the amount of time that actually takes for them to do that, just to check basic configurations. Additionally, when those reviews miss something, we see privileged containers, unsigned images, missing labels, cluster drift. All of those things start to slip into production. They're incredibly costly, not just in time, but in resources. So that's like letting a car with a loose wheel out on the track. It's not something that you really want to do, and it's only a matter of time before you suffer a big accident. So why do policies matter? For platform teams, this isn't just about security. It's about scaling your governance. It's about empowering your developers instead of slowing them down. That's the biggest thing that we should all take away. For platform teams, their job is to actually empower their developers, and policies really do help them do that. So to do this, you need consistent standards across dozens of teams and clusters. You need to enable safe developer self-service. You need teams that can deploy without waiting for approvals. You need governance that avoids bottlenecks. And that's where Kyverno actually comes in and can help out with your automated guardrails that get applied to everyone in the same way with the same rules, and it all makes sense. So why Kyverno? Well, for this crowd, this is a Kubernetes community day, and Kyverno is a Kubernetes native policy engine. So it fits really well with what it is that you're doing. It runs inside Kubernetes itself and has no external dependencies. It can enforce policies in admission control, run in background scans to check existing workflows. It validates in your CI/CD pipeline, and it can even run against infrastructure as code. And all of this is an open source oriented tool. So it's open for anyone to use and leverage. On top of it, all of its policies can be written in YAML or in common expression language, now called Cell. We see Kubernetes moving in that direction, and so we've also moved in that direction as well in order to incorporate everybody into the system. So you don't need to learn a new language in order to be able to use it. Also, Kyverno gives us 5 new policy types as we've moved into the rage of Cell. So we'll take a look at each one, and then we'll review a couple of use cases for some of them so that the policy as code concept and how that's going to help your platform team and your developer experience makes more sense. So in our latest release, 1.15, it just released a couple of weeks ago. So hopefully, if you copy my code blocks, they work, because I'm also very new to the common expression language. We've moved away from only YAML into cell-based policies, and with this move, we've added 5 new policy types. These types are super easy to remember for what they do. So we have validation policies. These policies check the workloads and to make sure that all of your workloads are following the rules. We have mutate policies, which are used to automatically fix or patch what's missing. We have generate policies, policies that generate different things and can create required resources when needed. We have verify images. This is a big one for most people because this makes sure that only signed and trusted images actually are running. And then we have cleanup policies. So these policies help remove old, stale resources and make sure that you're using your resources appropriately. And we'll try to look at an example of each one, and I'm very glad we can see my code block there. So this is a validate policy. It's written in common expression language. And if we look toward the bottom, where we see the cell expressions at the bottom, it literally says, block pods where any container has, privileged is true. So this one is the simplest and most important rules that you can enforce, because privileged containers are like giving a driver access to a pit wall control. That's really unsafe. That's not where you want your driver to be. Their job is to be on the track. So with this rule, unsafe workloads are blocked immediately. As soon as something comes up that's unsafe, it's blocked immediately in CI, in admission, and even in background scans. So the developer sees this clear message, and you can see the message at the bottom, privileged containers are not allowed. This is super actionable feedback. It makes sense to them, and now they know what they need to do. Next up are mutate policies. So if we look at the label line at the bottom of the snippet, you can see that what it's telling you to do is to add a label if it's missing. So in this case, we're going to add the label Kyverno in our Kubernetes.io app. If Kyverno is missing, it's going to add this label. Why does this matter? This seems like a very small thing when you're running at small scale. Labels don't seem like a big deal at all. But when you start to scale things out, if you don't have a naming convention and a labeling convention, things can get very difficult to debug very fast. So think of this as your pit crew actually adding a missing telemetry sensor to their car. The driver doesn't even notice, but the team benefits immensely as you start to scale out your workloads. It makes debugging faster, it makes scaling much smoother, and it makes everybody's lives much easier because you don't have to figure out how things are labeled based on different people's criteria. Next up, we have our generate policy example, and if we take a look at the namespace, it says request object metadata, a name, and then it has the quota values. Whenever a new namespace is created, this rule will automatically generate a resource quota with baseline CPU and memory limit. This also might not seem like a big deal at first. When you're first moving into this adoption, your developers start doing things like, well, I just need it to run. So they will put whatever CPU limit is necessary to just make things run. But oftentimes, that is much higher than what you actually need, and that is a massive cost at the end of the day. So what this means for every team is the tenant gets fair slice of what's going on in a multi-tenant situation. Everybody gets the appropriate amount of CPU and memory that they actually need to be running appropriately, to be fair across the board. It's like having a safety car almost. It makes sure that all of the cars start in the right lane. Next up is verify image. This is also a big one. If we look at the image scope and key, we can see that this policy says only run images from our organization's registry if they are signed with public key. So often we have folks who start doing things and they're running images that are not signed or they're not authorized, and this policy will automatically tell your development team that this is a problem. If an image isn't signed, it will automatically get blocked when you put this policy into run. This protects against supply chain attacks, it ensures provenance, and it gives auditors a confidence that everything is running the way it's supposed to be and that images have been checked correctly. Think of this as kind of your scrutineering in Formula One, where every piece of your car has to be checked before your car is allowed to go on the track. This is very much what that image verification policy does. And finally, we have a cleanup policy. So if we look toward the bottom again at the schedule selector, you can see that we have specific things that have been noted. So this policy deletes specific pods by name or namespace on a regular schedule. In this case, every 6 hours, as you can see. This ensures that your cluster stays clean. It removes clutter from old pods. It reduces waste on your resources, which will drastically reduce your cloud cost at the end of the day. So it's like having marshals clearing the track if there's an accident and there's debris on it. It makes sure that things continue to run safely, but also cleans everything up to make sure that you're not overusing resources that you don't need to be using. So now let's take a look at a couple of use cases for platform engineers specifically, because that's what we came here to talk about, is how policies can actually help platform teams. So integrating Kyverno into your CI/CD pipelines enables you to validate policies against Kubernetes manifests before deployment. This catches a massive amount of security and compliance issues before anything could possibly go wrong. And in the early development cycle, when things are much cheaper and easier to fix, this is super helpful. So if we take a look at the steps listed here, in our code block, we can see that there's a GitHub Actions step. And with Kyverno, you can run these policies directly in your CI/CD pipelines. This is an example of how you would do that with GitHub Actions. Unsafe manifests get blocked before they're merged, so developers get immediate feedback in their pull request, so they don't have to go anywhere else. Immediate feedback in their pull request that makes perfect sense to them to understand what the problem is, fix the issue, and resubmit in a much shorter period of time. So that feedback loop gets cut down, their developer experience immensely better than what it was previously trying to figure out these things on their own. And for platform teams, this means fewer late-stage surprises and less time spent on manual reviews, which is something that we mentioned before. 47 per week is a lot. So you're cutting that down immensely because those manual reviews go away. Let's look at another use case here of some of the policies that I was showing you before. Multi-tenant cluster management. This is a big one. Almost everyone is now in a multi-tenant situation. So policies are super helpful to ensure fairness. That is absolutely critical to make sure that your deployments are running appropriately. If we look at the quota snippet over here on the bottom, you can see this is a simple generate policy. It's very straightforward. Every new namespace automatically gets resource quota. So again, that ensures that your one single team can't hog all of your resources. That does happen. We hear it often in our community. So it ensures that that doesn't happen, and every team also starts on equal footing. For platform engineers, this often results in a much more consistent deployment. It provides self-service for their developer teams, and governance is then baked in, so they don't have to do anywhere near as much work, nor do they become the bottleneck for when things need to be fixed. And our third and final use case for today, automated security scanning. So we can't forget about security checks. I know everybody wants to. Security is constantly an issue that we're hearing needs to be shifted left. Developers are sick and tired of having everything shifted left. Ops teams still need them to do it. Security teams are off in their own world asking you to do tons of things that make zero sense. Using simple policies can drastically help with all of these siloed communication issues. So if we look at this snippet here, we have verify image snippet up there at the top, and it says very clearly what we need to do. We need to require a signature with org public key. This is the same snippet that we had before. This is how the use case actually works. So if a developer tries to deploy an unassigned image, it's denied with a clear error. It's very clear to them what the situation is. This is very much your safety net for supply chain security. This is shifting left. It's making things much more actionable and easier for everyone across the scope. Your security team can understand it, your dev team can understand it, your ops team doesn't have an issue with it, and they can also help set these things themselves before anything goes into production. So this is now a clear set of supply chain security through one very simple policy. Combined with simple self-validations, like disallowing privileged containers, you can also do both with images that you trust and you know how they're going to run. So that then becomes a much more robust stance on how you're going to be securing your pipeline. Now, obviously, There are a lot of other policy engines out there. These are a few of them. This begs the question, why Kyverno versus other options? And to be completely honest, I am a Kyverno fangirl. I run the community for our open source project. So, and also, I don't like having sales teams tell me their version of things because they always have their underlying messages that they want to get across. But these are the things that I've learned a little bit from our community. How complete they are or not, I'm not entirely sure. But from my understanding, from the feedback that I get from folks that are coming into our community, either from other policy engines or thinking about leaving our community to go use a different policy engine, this is what I've learned. OPA Gatekeeper is super powerful. There's no reason not to use it, but it does require learning Rego, which is a bit of a tricky language that oftentimes people get frustrated when they're trying to learn it. And also, it mostly works in admission, not in any other case. Polaris is a very good static scanner. People love it for doing static scans, which I think is great, but it doesn't really enforce anything. And Falco is a fan favorite for runtime detection, but it only monitors, which is often not enough for platform teams to actually build out much of a robust security stance. So that leaves Kyverno, clearly. It is Kubernetes native, which I mentioned before. It's fully open source, which also I mentioned before. Policies are in YAML, which is a language that at this point we all know and probably don't love, but there it is. Or they can be written in CEL, Common Expression Language, which is very straightforward to learn, apparently. I'm still learning, but it's nowhere near as difficult as other languages. It covers admission, background scans, CI/CD pipelines, infrastructure as code. So for platform teams, this really is a very wide range of things that it can do and makes it a viable option for them to be able to build out their governance and security stance. We see loads of platform engineers joining our community weekly with different use cases, but the three that I showed are very, very common use cases for folks, and it's a very simple way to get started with Kyverno. So we can break this down a little bit because a lot of times things boil down to real numbers. These are things that we're seeing in our community from our end user group. Here's some real outcomes that we've seen recently. Developer speed is overwhelmingly faster. 80% faster because fewer deployment blockers. That is a huge number. Obviously, for platform engineers who are tasked with developer experience and trying to streamline things, this is a very convincing number for most of them. And when they start to put it in practice, this is a number that a lot of people actually do reach, which is fantastic. Also, security turns into zero policy violations very quickly. You start off small with your policies, but as you grow that out, it becomes very robust, and all of a sudden, your policy violations in production after rollout can reduce to zero. Additionally, cost is always top of mind, especially when we're moving into a cloud-native space. We saw our previous presenter saying, I'm going to make sure, reminding himself to shut down his pod because he doesn't want to pay for it. These types of things all of a sudden drastically change. We're seeing folks who are really saving up to $50,000 annually through automated quotas by using Kyverno policies in production. While other enterprises have reported 70% reduction in manual reviews, so from 47 to practically nothing, that takes the platform team from being a bottleneck and all of a sudden opens up those lines for their developers to be much more self-sufficient along the way. So for platform engineers, these aren't abstract wins, they are very real wins, and this becomes a difference between fighting fires or actually enabling your developer to have self-service along the way. But let's be real, not everything is so simple. That is true, especially when you're trying to incorporate something new into your pipeline. And this is very much the situation with adopting policy use, and it doesn't matter if it's Kyverno or some other policy engine. There are a couple of, actually 3 big things that I have learned from our community that people need to keep in mind. First, Don't deploy too many policies at once. We all want to be super ambitious, but in this case, that's not always the best idea. We should typically start small, 3 to 5 policies, things that are simple, yet going to be critical and make an impact, and also things that your developers can understand, so that they can start to understand why it is that you're building these policies into what they're doing and see the benefit themselves of their own developer experience. Second, don't make rules too strict. Nobody likes to be told what to do all the time, and especially your developers who seem to think that they have the right to put their hands on everything. If you're an SRE, you know this. It's constantly, why can't I? There's a lot of reasons why they can't or shouldn't. But also, we don't want to make rules so strict that they can't do anything or experiment and learn. So a lot of times it's best to start in audit mode. Enforce from an audit mode so that you're blocking legitimate use cases, so that those dev teams are getting the actual actionable feedback at first, and then progressively tighten those policies as you move forward, because then they've bought into the fact that these really are guardrails that are going to be helping them along the way and empowering them to get their job done more efficiently instead of tying their hands down. And finally, don't skip testing in CI/CD. Otherwise, you will discover violations only after workloads hit production, and that is also a mess. There's no reason to do that to oneself when you can actually do your testing in your CI/CD pipeline. So this is all kind of like pushing a new car full speed without actually doing some laps first to make sure that it's prepared and ready to go. You kind of need to warm up the engine. That's probably the best way to get started with policy as code. So to quickly wrap up, let's compare before and afters from folks from our community who have been using Kyverno. Before using Kyverno, we hear a lot of teams saying that they're faced with 3-day security reviews, hundreds of tickets and quota that they have to then meet, and inconsistent governance. That becomes very time-consuming for people. But they started off small with their policies, started building that policy group up, and after using Kyverno and implementing it over a period of time, we've seen loads of teams that have moved into 30-minute deployment turnarounds because they have automated policies enabling confident releases. We've seen upwards of $400,000 annual savings for automation. Better resource management at scale is the exact reason for that, and that resource management has come from using simple policies to ensure that resources are distributed correctly. And automated guardrails across every cluster all of a sudden become consistent enforcement, and that reduces your manual intervention that's needed because all of a sudden things become a lot more easy to manage. So for platform teams, this is really a big winner for most of them and a big reason to start considering using policy as code. So we've made it to the checkered flag. We're at the end of the race. Kyverno is a CNCF incubating project. Our team of maintainers is working very diligently to try to push for graduation because we have so many people who are using it in production and such an active community. So if this is something that you're interested in, please do reach out. We have a very, very active maintainer team and community, and we'd love to have you be involved. You can explore our docs. You can jump into our Slack channels. You can try policies in our playground. We have a very cool playground that will take any YAML policy and turn it into cell, or any cell policy and turn it back into YAML, which makes that onboarding process a lot easier for people. And then also, please start small, and if you're not sure where to start with those small things, reach out. We have a huge number of people who are using this in production who are going to be willing to give you feedback about their own end user experience, what policies they started with moving forward. You will see immediate value, and so will your team if you get started. So that's it for me today. Thank you so much. And I think we have time for 1, maybe 2 questions if there are any, but nothing too difficult. Okay, thank you.
Hello again. You know, today is actually a very special day for us as organizers. And we really, really hope that we can make this day special for you as well. But what I know for a fact is that it is certainly special for our next speaker. Why is that the case? Because Velmira, who is a data engineer at SAP, is going to deliver her first talk ever at a conference. And you know, it takes a lot of courage to deliver your first talk in front of an audience that's so big. So please help her by welcoming her on stage with a warm round of applause.
Okay, welcome everyone. I'm Velmira, and as you hear, I'm data engineer in SAP, and today I'm here to present Kubeflow. I will share a brief introduction of the Kubeflow. We will walk through the stage of a classical ML workflow and see how the platform supports each step. And finally, we will wrap up by building a pipeline together. But before we starting the technical details, let's see why the platform like Kubeflow are becoming increasingly essential. Over the year, machine learning has gone through various evolutions from classical algorithms to deep learning. And today, we have a scalable system. At the same time, the modern ML project face enormous dataset, complex pipeline, and need for the rapid experimentation. Challenges that Kubeflow is specifically designed to address by automating, orchestration, scaling, and resource management. Kubeflow is an open source machine learning platform built to simplify how we deploy and manage ML workflows on Kubernetes. Traditional frameworks like TensorFlow primarily focus on building and training the model, but that's one piece of the puzzles. What Kubeflow brings are the missing links, management, automation, and seamlessly integration into the production environment. Kubeflow is not a single tool. It's a collect of the Kubernetes native project, and unlike of the monolithic platform on the market, Kubeflow gives you control over the entry ML lifecycle from data and training to deployment with the flexibility to use only the components you need. In the next few minutes, we will explore this component and see how it fits into the AI product lifecycle. If this sounds interesting and you want to start to work with Kubeflow, the official documentation is an excellent place to begin. I think many of us know how to work Kubernetes, and today I will focus on how it extends your skills in AI world. And let's see classical ML flow. We start with the data preparation, pass by model development, model training, evaluation, and in the end we need to deploy the model in the production. Today we will go through each of these steps because Kubeflow components help automate it and coordinate it every stage of this flow. And let's start with the first step. On the first step, we work with the raw data. This is an essential step before we move into the model development. At this stage, we focus on ingesting, cleaning, and transforming large dataset efficiently. To support this, Kubeflow leverages the Spark operator as an external component. It can be installed separately and integrated seamlessly with the Kubeflow pipelines, enabling scalable and distributed data processing. When we're ready with the data, we move to the next stage. On this stage, come in Kubeflow notebooks. Notebooks provide an ideal environment for experimentation, allowing data scientists to quickly test ideas, prototype model, and faster visualizing the result. But Kubeflow notebooks aren't just a Jupyter install on Kubernetes. This is our fully integrated and configurable environment where each notebooks run its own pod. Kubeflow launches an isolated environment for each user, and you can choose image among Jupyter Lab, RStudio, VS Code, or of course, if you want, you can create your own. And you can use YAML definition to control where it's run and what nodes it uses. For example, GPU, NVIDIA, AMD, Intel. This is insurance efficient use to the cluster resource and prevents overloading the nodes. And when we ready with the data, when we cleaning our data and defined our model, it's time to the train. Before this stage, the model is just a blueprint. It doesn't know anything yet. And now it's time to train, which means teaching it using our data so it can learn patterns and make accurate predictions. And on this stage, come in Kubeflow training operator. With training operator, teams can systematically deploy complex machine learning Kubeflow without worrying about the infrastructure. The operator schedules job across available nodes, balances GPU and CPU, and adapts to dynamic workloads, ensuring that every training session runs its peak efficiently. Kubeflow training operator streamlines the whole process, enabling faster iteration, higher model accuracy, and optimal hardware usage. And let's go back to diagram. So when we're ready with the data, we prepare our models architecture and we train our models. Now it's time to evaluate it. It's an important step that often involves adjusting hyperparameters, which are setting or configuration chosen before training that control how the models learn from data. Without Kubeflow, the process looks like this. We choose the initial values of the hyperparameter by experience. We start training the model, wait the result, record the performance, and repeat with other values. This approach is slow and often misses better combination because it's difficult to test many variants manually. This is exactly the problem that Katib, as part of the Kubeflow, solves. It's automated hyperparameter tuning, allowing you to systematically explore many combinations and find the optimal setting much faster. It's run on Kubernetes and can connect to different machine learning systems and framework. In addition, Katib is not limited only to AI. It can be used to optimize any task where we have input parameters and can measure outcomes. For example, to finding the faster ETL process or most efficient configuration for DevOps pipeline. And step by step, we arrive to the final stage where we deploy the model into the production environment. This means taking the ready model and making it available so other applications and user can send data to it and receive predictions. Deployment involves not just in the server, not just in the serving the model, but it but also ensuring scalability, reliability, versioning, and monitoring. So it can handle varying workloads and continue performing accurately over the time. For this reason, we have a KF serving was created as a part of the Kubeflow project and was later renamed to KServe to reflect its broader scope beyond the Kubeflow ecosystem. KServe is a tool for automated deployment of machine learning model in Kubernetes. It allows you to easily expose model for inference by defining a configuration. In that YAML, you describe the model specification, environment, and resources. When we create inference services, KServe automatically create all necessary Kubernetes resource to start serving the model. When a client sends a request, it goes through mandatory predictor. This component actually loads and serves the model. It supports a different runtime environment and provides a standardized way to serve model regardless of the framework. And if you want, you can pass by explainer, which adds functionality to interrupting model predictions, or transformer, a component that allows pre-processing or post-processing of the data. Kubeflow comes with a model registry, S3 compatible storage that manages metadata and artifact. It can be used from very beginning of the project and interact with throughout all stages of the ML lifecycle. But now let's look these steps again, because every of these steps can be part of the pipeline. You can use Kubeflow pipeline to create and run multi-step ML workflow as containerized task, executed pipeline with specific arguments, return with new data, schedule runs, use and organize experiment, track model, dataset, and metrics in artifact registry, and visualize pipeline logs and result with the Kubeflow dashboard for reproducible and scalable operations. Here you can see the full picture of executing a Kubeflow pipeline. We start with AI practitioners, and they submit a request. The web server has they submit a request to the web server. The web server has a user interface which provides a job creation to start the pipeline, run details with the ability to see the status of each run, and also display ML metadata, including inputs and outputs. And it visualizes artifacts like model and graph. Once the functions reach the compiler, it gets transformed, usually into YAML, which describe the DAC. The definition is passed to the execution engine, which prepares the pipeline execution by creating a Kubernetes custom resource, describe each step, and then hands it off to the orchestrator. The orchestrator is the component that loads the intermediate pipeline from via IR loader, track the progress of each step using the execution tracker, assign task to Kubernetes node, and write the result into metadata store. All pipeline steps are executed as Kubernetes pods, and there may be multiple nodes used for parallel execution. Here, I will stop with theory because this is enough to give us a clear picture of the process and the ecosystem, and we will take a look how to apply this in the practice in our project. For the use case, I've come up with an idea to solve a typical problem from our day-to-day work, consistently adjusting requests and limiting the resources. Let's imagine standard Kubernetes deployment scenario for application with 3 components: backend, frontend, and database. Instead of deploy each services on separate physical nodes in Kubernetes, we deploy them as pods, which can run on any nodes in the cluster. Suppose our cluster has 3 workers, each with 4 CPU cores, as shown in the picture. We create a deployment where we request a specific amount of the CPU. Let's assume the database and backend consume more, and we request, for example, 2.5 cores. And for the front end, we request 2. From experience, we assume that this is an expected behavior of the app. The Kubernetes scheduler selects a node that has enough resource to fulfill the pods requested and reserve the amount of the resource for the services. But what happens if the first pod actually needs more CPU than request? The app maybe lag, freeze, the container will restart, not the behavior we want. And if the backend consumes less than request, the problem becomes obvious. We have a CPU resource that are both unused and cannot be scheduled elsewhere. To address this, we will build an end-to-end workflow that can be used as a way to manage resources in Kubernetes. If you remember ML lifecycle, we start with the data preparation. And in our example, we start with loading data from Prometheus. And then aggregated metrics and add temporal features like weekday, hours, month, and also create features, lag features and rolling features. And when the data is ready, we split the process into parallel pipelines. In one of them, we continue to follow the model flow. We train the model, after that evaluated it, and we can use it to support operational decisions and capacity planning by visualizing potential outcome. On the second, we have a classified resource usage and generated actionable optimization recommendation. The main installation, when needed, are Python and Kubeflow. It's possible to install Kubeflow from official manifest. It provides a different installation that includes the core component like Ktip and Kserve to lightweight distributed, which make it easy to deploy it in different environments. I've already set everything up, and I have a Kubeflow pipeline installed. To simulate the situation, prepare a faker code faker code that generated the CPU metrics, and you can explore this code in the end of presentation. Let's see how it's looked data in Prometheus. And you can see a query that calculated the rate of accumulated CPU. Usage the same query in the pipeline. And this is a more interesting part of the code. In each step, we use the DSL components decorator. This makes every step modular, reproducible, and easy to connect into the full ML workflow. And this is turns a normal Python function into the reusable Kubeflow component. The function must be type annotated and hermetic, so all models import have to be inside the function definitions. And we come to the part where describe the full picture on how Kubeflow pipelines work. This is where we define the execution order of the step. A Kubeflow pipeline is built from components. Each component is a building block. It takes input data, executed some logic, and generated output data. Each functions call like load data from Prometheus, process data, train model, etc. Represents a Kubeflow pipelines component. When we provide a real input data in components, it becomes a task in the pipeline. And now the pipeline code itself just a Python. It only describes the steps and their dependencies, but Kubeflow cannot run Python directly. It expects a declarative file. And this is why we use the compiler, which translates our pipeline code into the YAML that Kubeflow can actually submit and execute. We can use the Kubeflow pipeline create command, where we pass the desired name of the pipeline and generated file. And this command creates a pipeline with specific ID. We can see listed the pipeline in the dashboard, and when we click on it, we open the DAC. You can see every step on code as a single step in pipeline. And now it's time to create a run. To create a run, you can populate the pipeline name, pipeline version, run of the name. If you want, you can add a description and associate experiment and start executing the pipeline. During the execution, we can select a specific step and click on it. An additional window opens. In it, we can inspect the inputs and outputs, as well as the result, logs, and error, if there are any during the execution. You can also monitor the pipeline execution and its individual pod in real time. Let's return back to our use case. Due to limited time, I will skip the intermediate diagrams and show you directly the combined chart. The historical data present in the blue and the forecast for the next 24 hours present in the orange. For the most of the period, the backend service run steadily in the optimal zone around 2 CPU and short dips. This clearly indicates that the declared CPU requests are more than enough. We also clearly observe the typical pattern of lower consumption during the weekend and outside working hours. This is the simple example, shows how the models can be used to optimize scheduler resources or automatically trigger alerts when abnormal consumption occur. And I think the example is interesting, but I want to return back to Kubeflow. What is Kubeflow? A platform made up of multiple open source projects, each addressing different parts of the AI or ML lifecycle. And today we walk through the main phase of the machine learning flow and saw how Kubeflow project interact with each one. And with that, I will stop here and open the floor for any questions and comments.
Velmira. So I hope that you liked this experience. And now there is another special moment today approaching, which is lunch. I know everyone's probably expecting that. So lunch is served outside, and I encourage you to enjoy yourself, and please be mindful of the queues. There is enough food, probably more than enough for everyone. So I'll see you back at 1 in the afternoon. Thank you. hello everyone again, and I'm actually seeing, I guess we're doing well because there's so many people coming back. Usually after such a good lunch, I tend to take an hour or two of a nap time, like working from home and all that stuff. I actually have a favor to ask from you. So we are heavily relying on organic publicity here, and we've got this beautiful LED wall with our logo right around the entrance of the venue. And taking pictures of a LED wall doesn't really do us any good. But if you could stand there and be beautiful and tag yourself if you're into that, that will generate quite a lot of publicity around the conference, and it will help us with future venues such as that. But of course, only do that if you actually like the conference. So now we're gonna continue with our next speaker, who is Engin Diri, and he's a solutions architect at Pulumi. And he's going to talk about how to bring AI in a world that is essentially defined by DevOps. So welcome, Engin, on stage.
So, hello. People ask me what's the best time for conference talk. I like after lunch or the last talk because people either are gone or are too tired to ask tricky questions. So I highly appreciate this slot. So one disclaimer before I start. The world of AI is very, very quick. So this should be some kind of newspaper. It's a German expression of saying nothing is older than the news from yesterday or the newspaper from yesterday. So it's highly possible that stuff I presented here is already outdated, or there are better ways to handle this. When I submitted the talk, that was the hottest shizzle, so let me continue. So yeah, AI, yeah. Who's using AI? Let me, hands up, who's using AI? Wow, that's good. So AI, and AI, why did clicker doesn't work? And because it's so great, AI, AI. So that's the new developers thing, what's going on. So we know this guy, and hopefully I'm not sweating as much after this session. So there are two kind of I would say, fractions inside the community currently. So there are one persons who hate the whole AI stuff. It's like, screw you, GPT and all the stuff, I need to be the most important person in my company or whatever. So we have these persons, and then of course we have the other fraction inside the community who says AI is the best thing which happened. For example, Viktor is not here, but Viktor is same, he just mentioned this also. AI helps him a lot, and we see this through all the places, people writing code and analyzing, debugging, and all this stuff. So one of the two things here. But let me tell you, now heading over to the talk, so let me say, okay, we are now at this point where we say ignoring AI is not just being cautious now and looking, is this a hype or not? At this current stage, and even now with the end of 2025, ignoring AI is not caution, it's straight up denial. Because here comes the point now. Maybe and high likely your competitor is not ignoring it. So while you're trying, let's figure this out stuff, your competitor already works on something, released something. And we could see the last couple of months how many companies released something around AI or enhanced their product set. And that's only the end user, the vendors, but we have also a lot of end users who use now AI and compete with each other, be it banks or whatever. So welcome, yeah, AI in a DevOps world. Let's talk about how we can bring AI in a DevOps world. So I'm not going to talk about training, fine-tuning, and all this stuff, but also from a practitioner place to say, okay, what would it look like in a DevOps world? Quickly, to my person, I'm not a big fan of plugging myself here. Yes, senior solutions architect at Pulumi, name Engin Diri, and this thing is, okay, and I love Bulgaria. So that's my second time in Bulgaria, and I really love it. So, of course, why is it not working? I had to also discover some new stuff. So this time I walked around here in the second floor and I stumbled over the shield and I go to my Bulgarian brother from a different mother. I'm like, bro, what is a hobo? So I don't know. He explained to me then, no, that's because you are Latin used and this is Kirill language. So a hobo is not a hobo. It means nouveau or something like new. So the pizza is new. And of course, I discovered the local cuisine here with Orlin. So he showed me banitsa, and that was really, really nice. And you see a boza. And yesterday I was a little bit busy, so I could not go to the nice places. So I went for Bilu. So I got some industrial-made banitsa, but I got at least my boza fixed. So the cuisine is very nice. And this is my baba, I would say. You say in Bulgarian baba. This is my grandmother. And her family is from a town here, or city, I don't know, you let me know. I was never there. So they are from Rasgrad. So I'm sounding like an American now, going through the ancestry and say, hey, I'm also a German, I'm also a European. So here in this case, yeah, the mother side of my family is from Bulgaria, is from this town called Rasgrad. And yeah, okay, so heading back to the talk, so that's a quick introduction. So I have the statement to say, okay, classic IDPs, internal developer portals or platforms have a problem by design. And here comes the point. So why do I give this bold statement? We still need to write code. We need to glue a lot of moving parts together. So it's not something like we have out of the box. We say, no, we still need to glue this stuff. Because here comes also the point, this is the CNCF landscape. People use this as a shopping list and go through and say, hey, my IDP should have this part and here, the orchestration, the CI system, and so on. And most of the time, this is like, whoa, it's overwhelming and what a lot of things going on. You need to learn, you need to write the glue code. And we come to the point again, is every line of code I'm write an asset or a liability? I'm always on the side of the liability. And here comes also this point, what I would like to ask you, how to say banned from KubeCon in Bulgarian, because I keep on showing this CNCF thing, and now I'm on a KCD event, and one day they will say like, is Engin mocking us all the time with our landscape and so on? So please let me know how you say this in Bulgarian. Okay, and additionally, the next point is, we need domain expertise. It's always needed. We need always somebody. We need to have people updated. And the latest thing, when changes happen, for example, people need to know this little piece I took out from the landscape, from one of the projects. How are we going to update this? How are we going to proceed with this when something happens? Okay, so here comes my claim now. IDPs should be pure agentic based. So that's a claim. And you see, I used also AI to enhance the image of Lisa because the original is not that good looking one. Okay, so let's have a look at the capabilities of a platform. And here we go back to the CNCF. There are different working groups. I highly encourage you to look at the link to check this working group, the white paper around platform capabilities and the platform working group, and they come up here with the capability map. You have your product application team, the platform interfaces like Backstage or your own created one, and then of course the different capabilities, scanning. We talked about Kyverno before, and all the stuff you throw in to say, that's my platform. So now let's head to the point to say, okay, how we can augment now these capabilities using AI. And here I really naively put now some icons on top of it and some names. We will go later a little bit more into the detail. We have still the user. The user is still interacting somehow with the platform. But now we have some kind of little agents which fill up some of the gaps. So we can say, hey, we have a dedicated project template. We have a dedicated documentation AI thingy which does some office work, and all of them, like in a real world, like when I go to work, there's always a boss. There should be something, because otherwise we would be headless chicken. So somehow they are also connected with this big AI boss, and this one setup. And then of course you can go down and say, okay, a little bit more. In every layer we can attach some of the AI thingies. So AI thingy. So just a disclaimer, and I know here's some changes, ChatGPT and so on, they keep on evolving, getting much, much better and so on. But in general, we can say, okay, ChatGPT, I would not count it here as a pure agentic AI stuff. A lot of people not using here the agentic AI approach. So this is a disclaimer. Not sure if I would keep this in the future because, as I said, they keep on evolving here. So then now let's talk about what is an AI agent, to just give you an idea. So the AI thingy, we name it now AI agent, and we can say, okay, it's an autonomous AI-powered component, which is running here in a loop. So this thing. So it has specialized capabilities, so it's not broad and knows everything. So I don't know the English phrase for this. It has an independent decision-making. It's goal-orientated, it has a behavior here, and continuous learning. You see reasoning, act, perceive, check, and then keep on looping this until we reached a stage where we say, hey, that's really cool, that's nice, I'm done here, do what you want to do with this. Another point is here to say, okay, how we can achieve this, an agent now can connect and integrate with our tools we have. So in a lot of frameworks, you will see there are ways to connect your external tools to the agent, because guess what? An agent, when you keep the vanilla model underneath it, it doesn't maybe know everything which is up to date. And most likely, it will not know your Jira board or whatever systems you have. So you have a way to create now your bespoke integration, depending on the framework you're using. And here, there's also some evolution going on, and we talked also about this. Again, it should be not something new for everybody. So MCP is the savior also for this. So rather working here on bespoke integrations depending on the framework, we have now here a cool protocol, an open protocol, which helps us to integrate LLM applications with external data sources, tools. We can even take other agents as a tool inside an MCP, so things are also evolving here very quick. And again, this is something you see from the beginning of the year. A lot of hype got around MCP, so people really jumped onto this. And you can see this rarely happens in our space, that something come up and people really see the benefit, play around. We have the first phase of builders working around. And I think we are now in this verge where we say, okay, everybody is creating, everybody, and my mother, I always say like this, creating an MCP. That's the builder phase. But we see now the adoption also in the mainstream of MCP. So not only coming up with an MCP server for PowerPoint automation, but also for some really cool use cases. And you probably started already to work on an MCP in your company. Shameless plug, Pulumi, of course, has also an MCP server, so you can connect your infrastructure to this or let you help to write your infrastructure. And then, of course, because I love AWS, we have also AWS MCP server, a huge collection, so they figured out it could be very useful. Okay, so before, very time intensive, you choose your LLM framework, you're like, yeah, I'm going to use LangChain or whatever, and this is like front-end modules. Every week there's a new framework, so it's very quick. Create your bespoke integrations with the tool. You cannot portable. Somebody comes and say, hey, this framework is better. You have to recreate the tool integration. Now, after we have a nice way here with our MCP, we create our MCP integration and let people consume it independent of the framework they're using. So we have a portability here, which is very, very nice. And then you can go literally crazy. That's cool. So that's very important. So head back to our capabilities map. And now we can cross through the AI thing and say, yes, they are now AI agent powered with MCPs. Or we had also a talk here about RAG. So we can also attach here RAG to this. That the agent gets even better feedback. Okay, so, and please tell me how you said that it's Amachaka. Yeah, Shaka. One moment, wait a minute. That was the idea of this, so sorry if I tortured your language. That was not intended. So, okay, how they're going to communicate with each other. So how can one agent work with another agent and say, hey, my package is maybe important for another agent to continue, because currently they are isolated on its own. Yes, they are capable, they are powerful, they reason and all the stuff, but now we talked about a collection of them. So, and here comes the agentic workflow in place. So they have different names. We call it here the whole supervisor flow. So we start here. Oops, that's a little bit unfortunate. So we got a task. The task gets executed. We come to a decision point. So task initiation, task execution, decision point. Then it's going to be handoff to the different agents. I don't know why this. And then it keeps iterating. So here we have this agentic workflow defined in different stages. And everything is powered by AI, and then we have in different cases some artifacts going back and creating the artifact. Okay, so we have the workflow place. They communicate here in this agentic workflow. So last point which is left here is what's happened with this big AI boss. What's the role of this one? Okay, so let's have a look. How do you say this? I spoiled a little bit. So the supervisor, I said, like in a company, who knows how things are going. That's the person who comes only with his telephone in a meeting, you know. Everybody comes with a laptop and he comes with a phone. And that's the person, you know, doesn't need to be anymore in executing. He's the visionary person. So same thing. He gets the task, the old task, you know, like, hey, do X, Y, Z. He classifies the task now for us and starts to route the task because he knows everybody is reporting to him, so he knows these are my collection of agents. I classified the task now. Rather than going through the task, I see, okay, this is a task for agent 1, make the decision point, hand off the specific subtask, and then again, the iteration fast. So when things come back to the supervisor, he can be like, I'm not d'accord with it, that's not fine, let's go again through the loop. So this is some case you can work. So the supervisor is in charge of routing the stuff, but also getting the decision here and going through the different stages. Okay, so how does it look like in an IDP? So here's an example also from our demo here to say AI internal developer platform, the demo. So we have an IDP multi-agent system now. So we have the planning layer with our supervisor agent, and then we have the agent layer with IAC agent for specific infrastructure as code. It could be Terraform, Crossplane, or Pulumi, cloud agent, and then we have maybe a DevOps agent, we have a documentation agent, and all the stuff. You can think about what's needed in your case. And everybody access the tooling layer here via MCPs, and then have a lot of MCPs by hand. It could be a self-written, and so on and so on. Again, you can imagine how this continues. Okay, so let's head over to the demo. Okay. So I use, in this case, I use Flowise. Flowise is a low-code, no-code platform similar to N8N. So there are also, again, a lot of platforms going on where you can create some agentic workflows. You can also code this. So LangGraph, for example, there are some Crew AI, for example, which also allows you this kind of pattern to create in code. Or if you don't want to code or you want to POC something, Flowise or N8N is also nice. We're using Bedrock under the hood. Yes, of course, Pulumi, because they paid the airline ticket. And of course here, GitHub. I'm joking if you hear this, if they watch the video. So, okay. Very important is also because we want to take some of our learnings from the classical way how we created IDPs, to say not everything is like, hey, we're going to scrap everything. There are some practices which are very useful. So one of the practices is also to have this kind of template going on, golden paths, we called them, or paved roads, depending with who you talk. So I made a similar approach here. I called it here now a golden AI path. And then I define, similar to my template I would create in a classical golden path, with cookie cutting or whatever systems you are using, I used here now a natural language. and then describe what has to be done, you know, like this is my task and this is the steps you have to go through and so on and so on. The more detailed you go through this, the better it is. And of course, you can change some of the properties you could have with a process before, like Viktor also showed in the keynote, to have some discussion wizardy style going on, and then fill out the properties, let another agent run the template, the golden path through a template engine, and then come up with a prompt which is completely filled out. You could also react on events or whatever, so it's not necessarily to have a one-to-one discussion every time. And that's here. Okay, and here's the whole flow. It's unfortunate, maybe a little bit too small. So think about when you go to Flowwise, you can create different boxes. You can select from a library, and then you can start to connect. You can say, here on the left side, we have our supervisor, and so on. You will see this in the demo a little bit detailed because I zoomed there in. Okay, so let's head over to the demo. I recorded it because I'm not doing any errors anymore, because sometimes I'm like, hey, do it live, and then it doesn't work. So, okay, but I did it yesterday evening, so that's why I went to Bilo for a low-level Banitsa. Okay, so I hope this is working fine. And I will stop it for some special events. So here, as I mentioned, this is our supervisor. And most importantly, we're going to define the supervisor prompt, give him some instructions to say, hey, this is your role, and your team belongs of following people or following agents, and then you can configure a little bit more. So that's the supervisor, and now have a look into some of the agents. So this one is, what is this one? Oops, that's the GitHub agent. Again, the better you write your system prompt, the better is the output here. And yeah, that's you will see with experience that this makes definitely sense. So that's one of the worker prompts. And then we head over to the Pulumi agent. You are specialized to do all the stuff around Pulumi, also connected here with the Pulumi MCP. And then the last but not least is here our documentation, to say, hey, you are the documentation agent, please create a nice documentation using the MCP from AWS Lab and so on. Okay, so let's have a look into the golden path. You see, I'm copy-pasting the golden path, and I speed up the place where I change hello KCD Sofia to show that's not staged or something like this. So, and then you see, the message arrives and goes to the supervisor. And we see here the supervisor. Let me stop this here on the right side. It already started to digest the overall golden path into a subtask and says, this is the first part, everything around GitHub agent. Let's hand it over to the GitHub agent. And now the GitHub agent is like, yep, I'm here. Don't have days off. And you can see on the left, I checked this to show, yeah, he started to work, he created the folder, he checked out my Git repository with the real blueprint code, because we still want to keep things as infrastructure as code. And yep, so let's stop here. We see I speed it up a little bit. So as you can see, he comes back now with the stuff he did. So he cloned the repository, he copied the static file, he updated the HTML file to display hello KCD Sofia in the starter template, successfully run npm install, blah, blah, blah. Okay, how long I have? 8 minutes. Okay, so that's done here. And why do I do this stuff on the side? Okay, so next point is, we see now the supervisor is happy with the feedback of the GitHub agent, takes the result and says, okay, fine with it, let's head over to the next part, and now please deploy the static website to AWS and hand this over to the Pulumi agent, because yeah, the Pulumi agent knows what to do with this. Again, you see on the left side, I show you that it's written hello world, hello KCD Sofia, because I have this urge to show that it's really working. So now we got the result. I speeded up the thing. The Pulumi agent went through the stuff, give his first feedback, and we could get now the website URL. I was a little bit too quick because now this is the result of the agent, but we would like to see, yeah, So the agent gave the result. You saw it's a little bit not formatted right, but I actually wanted to show you the final result of the supervisor. So this is the final result of the supervisor. You see it gets the report from the Pulumi agent. It shows what it done successfully. Everything worked fine. And then also extracted, as you know, with the output stuff, extracted the URL of the bucket. And if we run this now, we can see, yes, hello, KCD Sofia 2025. That worked fine. There's nothing coming after this. Okay, so let's head back to the slide. So we saw the demo. Demo time is over. Okay, let's generate in good AI way, generate our talk summary here. So please. Okay, so give me 4 key takeaways you should take here with you from this talk. And we go to our takeaway agent. I know that's so cringe. I'm so sorry. I thought that's a brilliant idea, but now I think it's cringe. Sorry. AI is here to stay, no doubt. Please, as Viktor this morning also said, if you another opinion here, I think you are in a lost position. Agentic AI is the way to go. So we really see that's the thing we should concentrate ourselves looking on agentic AI, nothing else. Don't write with bash scripts and so on. It's really agentic AIs in a swarm and so on. And AI agentic workflow can and should empower your IDPs. And yeah, go home to your office and try. But most importantly, first define your use cases, this typical stuff to show it really does what you wanted to do, and you're not becoming like a snake oil seller, you know, the picture with the police officers hitting there because people are like, AI is not working. I think Viktor mentioned this. Okay, we created this week, so don't say I planned this in advance. This week, on the 16th, we released our own agent. So have a look at Neo. It's called Neo from Matrix, and it is also an agentic flow inside Pulumi. And yeah, with this, thank you. This is my LinkedIn. Happy to connect. And yeah, thank you. Any questions? Everybody in ChatGPT ask Engin question. So, no question? No, even a fake question? Olin, I gave you some fake questions. Okay.
Security come into play here?
Sorry, I didn't catch this.
Where does security come into play here? So you have these agents working on your system. As they're getting smarter, they're getting better at escaping systems. If you have something running for 6 or 7 hours, how do you make sure it doesn't escape?
Yes, that's a big thing. For example, I can only speak now from our engineering team. That was a big thing for the Pulumi agent, for example, taking care that people cannot break out and do some other stuff, really setting up the guardrails. What we also highly encourage, and this is good that we had the Kyverno talk, is using policy as code as much. So that's the reason we still not say, let the MCP communicate with the cloud directly. Let's go. I'm not calling an intermediate format. I say, okay, let's still use the things we learned which are working to say, let's define the stuff still as infrastructure, as code, so we can repeat and recreate this. We could still an agent to say, redeploy this and so on. So that's some of the things to be sure. So not scraping and going completely YOLO and say, hey, we're going to communicate, say, okay, let's enhance where it makes absolutely sense, because nowadays, in my daughter and so on, they will not understand why we have this kind of, how do you call this obstacles to achieve something when it can be that easy. So get the easiness of the whole AI communicating stuff to not make Studio Ghibli pictures, but to deploy your full-blown EKS cluster. But thanks. I hope it answered you. I could also do the typical senior engineer stuff. It depends. But so there are cases where you don't need security to get speed and other things which make sense. Okay. Yeah.
One more question. First, thanks for. We're glad to have you back again. So thanks for being here. So these days I'm using the operator framework to manage my deployments. Will this replace it?
The
operator
voice,
framework,
like
lifecycle management.
Can you repeat again, please?
Operator framework. Lifecycle management of my deployment. we would be replaced with this with the agents.
It could be, I mean, there are, for example, projects like K-Agent where you could define your agents and say, okay, I don't need now the operator framework to do this kind of stuff. I could deploy different agents like this on my Kubernetes and define the template also as a YAML, for example, and throw it in and let them work on this one if you mean like this. So so it could be that you use your operator still under the hood to execute your deployments of some databases and so on, but let the agent define the blueprint for your deployment. Hope it makes a little bit sense. Thanks. Sorry, we can talk later if it's okay about this. Okay, with this said, 1 minute to go. I'm happy. So thank you.
Thank you. So it's actually really exciting to see that Engin here, very successfully navigated the complex food ecosystem here in Bulgaria and essentially managed to get to the essentials, which is banica, buza, and what else do you need? I guess for all the folks that are coming from out of the country, you should stick with him. He can be your guide this evening to the rest of the fun stuff around here, such as rakia and so on. But this is probably best suited for after the conference. And until then, I want to welcome on stage Dr. Constanze Roedig along with Vadim Bauer, who are going to do a joint talk today and are going to tell you all about BOP, the supply chain provided bill of behavior. So a round of applause for them.
Dobry den. So I will try some Bulgarian today. Give me some break. You'll see in a second. First off, 1 second. And I can only say what the others have said before. You've outdone yourself. This is I was part of KCD Austria organizers, but what I see here, it's like amazing. Huge shout out. And we got slides. Okay. You guys, all right. Yeah, we're going to talk about BOP. The question was, how does security come into this? So this talk has no AI, quite a bit of security, and Cortney's talk earlier on Kyverno, there was 47 manual steps per week that a team has to do. So I want to talk about something that's a very new idea. Well, the initiative is new, is to have an SBOP. I'll talk about what that is. And this talk is about to ask you, the community, for your input, your feedback, the things that you already know maybe from your products, feed it into basically us so we can make sure we can integrate this idea well into the cloud-native ecosystem. But before I get there, my name is Constanze. I'm a doctor. And you should not take medical advice from me, because I'm the wrong kind of doctor. I'm an independent researcher, and huge shout out for the individual people that have made it possible to stay independent, but also the big, of course, funding agencies that stand behind that we in this day and age can still be really independent. And with me on this talk is...
Hello everyone, my name is Vadim. I'm one of the maintainers of Harbor and supporting the SBOP effort.
Most excellent. So, I brought with me a container. And so who here is using SBOMs? For the video, that is about 5% of the audience. Okay, so I'm gonna read you not the SBOM, but the BOM of this container. Hang on. So this thing contains 1 milligram of dimetindene maleate, purified water, and a lot of other chemistry. Now, what this thing is important for is that I know exactly what went in the order of percentages that went into that container. And I'm not saying that this is not important, but what do you do when you want to know how the stuff that's in there behaves in your body? when you should take it, in the morning or in the afternoon. Who is it for? Is it for babies or is it for Alzheimer patients? Well, you прочетете листовката. So, and why do you read this thing? Why do you read this listовката? Because pharmaceutical companies are forced by the FDA and equivalent agencies to have like 10 plus years of testing of this stuff and condense it down in this little thing that should generally apply for most of the population. Of course, everybody is different, right? So there'll be, people can override prescriptions. And the idea now is, how can we transfer this to our software ecosystem? How can we have this listevskata for containers or artifacts? And let's start at the beginning. So generally, let's say you've got a cloud-native situation going on, and you want to detect tampering. So we're talking about runtime, right? So essentially, what you do is you get some data out, you collect it, telemetry, observability, etc. And then you have to somehow decide, was it bad? How do you decide? We had Kyverno talk earlier. Well, usually, you use rules. Who has written a security detection rule? Like 5 people in the room. And typically, that is you, the user, or the platform engineer, the SRE, who's doing that. And my argument now is, if I'm the user, if I'm the consumer of this medication, do I have 10 years of experience of developing this product? Did I do the experiments? Should I even have that information that went into that? So why don't we switch this over and say, well, as a vendor or maintainer of a product, software, I should hopefully have done some tests. Maybe not quite 10 years, but I certainly, as the vendor, know how that piece of software should generally behave. And how could I generalize this into a fingerprint at runtime and make it transferable? And this is the general idea, and the question on a technical level that I was confronted with in the beginning was, well, nice, Constance, yeah, you're, academic person, but in the real world, is it going to work? Is it going to transfer from a K3S on a kernel 4.2 into a, 4.4, into a K0S on a super recent kernel 6.11? Well, I have a live demo. If we don't have time for it, I will give you a live lab that you can try out yourself if it works, where the bugs are and where the difficulties are. In general, this is what we call an SBOB, a software bill of behavior. It's a generalized fingerprint, such like as this insert that encompasses what the general behavior is, such that you as a user can inherit it. And you can, from the first second that you install it, we're going to see in a second, maybe comes with a Helm chart, and out of the box, you have a reasonable, secure by default baseline that you can work off from. You can do overrides, as you've always done, but you get it from the vendor, and this is important. How about rule maintenance? We had those people that wrote the rules. Writing them is one thing, but maintaining them with each update, that is also a massive amount of effort. And so what we want to do is have the vendor ship it with each update. So what does it look like? I know it's hard to read, which is why I encourage you to check out the actual spec. This is done with Kubescape. Huge shout out to Matthias Bertschi, the lead maintainer from Kubescape. Very soon, I'm not going to say the date, very, very soon, Kubescape will officially support this externally supplied profile. And what it actually looks like in SPDX spec is it contains a single YAML, totally human readable, with capabilities, with executables, network endpoints, network methods. It contains the image hashes, but also the file descriptors and file opens, and a list of syscalls. This is nothing new if you've worked with an LSM before, like AppArmor, SE-Linux. This is nothing new if you've ever written these rules. What is different is that this is human readable, and you can pretty much understand what's going on by essentially looking at it. And the idea now is that the vendors produce this generalized profile with each update of the software. And from the user side, I would then be able to consume it, use my typical templating, mustache, whatever I like, customize overlays, and adapt it to my, for example, network endpoint. I use a port 8000 instead of a port 3000, so I override that. Now, something that is coming up, and here I very, very much appreciate all the input I have gotten from the community, which was intense, is like, how should this look like such that the ecosystem accepts it? So we'll need some functionality that basically parses one engine into another engine and makes the UX great for the end user, so the user experience. We're starting with Helm, because pretty much everybody knows Helm, and the runtime engine, as I said, it's Kubescape, the first one that will be supported, coming out very, very soon. Currently, I'm testing this on the Kubernetes that are listed here. And again, if you are a vendor that provides managed Kubernetes, I'm very, very happy to include you in the matrix. Talk to me such that this can be all-encompassing, such that I can do the tests and check whether your flavor of, I don't know, OpenShift running on something also works. Now, does it reduce the attack surface, or what I like to actually call it, the hiding surface? Because what happens here is that if I use the profile, anything that deviates from it will come up as an anomaly. So what we see here is the first line is the Kubernetes default in 133, where by default, nothing really happens with the capabilities. The network policies depend what you do with your network policies, and if your CNI supports it. File opens and execs are generally unconfined, and the allowed syscalls, if you use the seccomp default profile, that differs a bit, containerd versus something else. Typically, you have about 100 that are disallowed. And now I looked at CNCF Pixie, a very intense, so very much interfering, complex deployment. How would we be able to constrain its attack surface by using an SBOP? And if we look at the line with the longest number of capabilities here, the PEM, this is actually the edge module that inserts itself and live debugs, basically intercepts everything that your container does. It runs with a lot of capabilities. But if you look at the executable, it has exactly one executable that is allowed to run all these capabilities. So that means, can we use from the entire container whatever may be in there? We can say that's only this one executable that is allowed to use those kappas, nothing else. And this already is a huge amount of reduction in potential abuse that is happening. And this is especially important for programs such as observability and security tools that themselves have a lot of power. And if they get misused, you really want to know immediately. A question that I got a lot when I presented this originally in Munich is the question enforcing versus alerting. So we're going to start this out purely with alerting, meaning anomaly detection, because for most people that will already be a huge win to have anomaly at all out of the box. However, we know that some of these components are very volatile. So we know that in syscalls we cannot exactly predetermine what is going to happen. So if we go into enforcing mode ever, I would suggest we start with the capabilities executable tuples and use something well-established like the Linux security modules such as UpArmor and basically parse it into two directions. So this is just the roadmap in my mind for that question because it always comes up. I would also say, please don't go into anything enforcing unless you've really well tested it because it does break production. So now, how do you do it? How do you get such a generalized fingerprint? So you typically start with a maintainer or a vendor who knows the test suite for your application, in this case, Pixie. So I'm asking Dom, so how do I verify that Pixie is, so I'm triggering all the benign behavior of Pixie. So I typically do this on one cluster, and then I go automate this over a huge matrix of different Kubernetes. And then I extract a superset of all of this, and basically I retest it again to see, And this is important because I'm generalizing it, right? So I'm expecting to have a certain amount of fake or false positives and false negatives in the resulting fingerprint, so that I know what my blind spots are and what the false alarms are. I run another test on top of this. So basically, if you want to check it out, you can just look at my GitHub Actions and see how this matrix is currently implemented. And now, where are we with the time? We're good with the time, so let me go over to the live demo. So if you would like to try this out, and this huge shout out to Ivan Velichko, who is running the Eximius labs here, what I've made is a public lab that is for 1 hour per day free for all of you. You need to use your GitHub user to sign up. The link is going to be in the talk. And if you just have 10 minutes and you want to say, like, I want to see this for myself, including the drift and the bugs, everything, go to module 2, which is the user experiencing this. And here, now let's see. Okay, yeah. So here I am now in the situation where the vendor has produced a Bob, an SBOB, for a web application that pings things. And I will now apply this. I've already installed Kubescape in the background. I've already installed the web application, because it takes some time. And now I'll also test if you were listening. So I'll do two tabs. On one side, I'm going to look at the unexpected. So these are the anomalies, okay? So here. And we'll see something because I tested this earlier. So this is from my test run. So on this side is the anomaly, right side. And now I have my web application, and I included a test. This is the benign, typical QA test that the ping application is supposed to have. Now, question to the audience. If I now run Helm test, the positive test, and I'm checking for anomalies, what should I be seeing if this is working? Nothing, I heard it. That's exactly correct. Thank you so much. Now, let's see how many bugs have happened since I last maintained this. So this is a Helm test, by the way. It's a webhook. Nothing. So this is exactly what I'm expecting. So I'm basically pinging this up. There's a ping application, and I see no anomalies. Now, this application, however, is intentionally vulnerable. So now I'm going to do, and if you've ever done an injection in any security class, then you see what is happening here. I will do a command injection. Okay, and apologize for the unreadability here. So I've made it more readable on this side in pretty print. You see two things: unexpected file access, that is the underlying Apache main page, and unexpected process, bin-ls, right? So that is one of the negative tests. And we can make this even more aggressive. We can say, make attack. Okay, maybe we should go in the right direction. Make forward. Make attack. And we can specify, well, so there should be, yeah. So we can say, well, I have an attack suite, and I want to check if my detection is actually working, if I'll see the anomalies that I want to see, or if I do not see something, I'll have a blind spot in this particular detection rule in my incident response. I can also check for this. So if you have 10 minutes, do try it out. If something's not working, please open issues. I'll go back to the main slides. Just checking my time. Yes, supply chain attacks are work in progress. So, go back to play. That was wrong. Sorry. To borrow again from the medical terminology, what is happening here is we're going from, and there are many tools in the ecosystem that can record profiles and then build profiles out. We're going from describing something on the user side where each person does, or each SRE needs to do this for themselves and discover again the truth. We're going to prescription. And this is just like in science or in algorithms, right? I create huge amounts of scale by abstracting, by modeling something into a generalized fingerprint, and then basically I have this model from which I can then derive the future, like only these small deviations that I as a user need. And this is what makes, or what I think is going to create a huge impact if we can do it, because the maintenance goes away and I already have a good baseline by default. So that's the difference between I recorded myself to we have those guys transferable. So what, if you want to contribute, what is the most useful thing to do if you're a maintainer or vendor? The test suites and the knowing how it's supposed to behave is something I cannot replicate. I can give you sort of a emulation as a service, all these different clusters, but understanding how your exact project's supposed to work, that's not something I can reverse engineer. That's the whole point, right? It's again coming back. I don't have the 10 years of testing. So also research collaborations. I had a similar slide in Munich. A lot has happened since those 7 weeks. 7 weeks is what we're talking about here. We've checked that additivity of these profiles work. If we have init containers, jobs, anything that interacts with the runtime. So if you have a config map, that doesn't have a Bob. Anything that really has runtime, consumes either CPU or memory, well, interacts with the kernel, is where we can get a Bob from. We're building up, TU Wien has, Technical University of Vienna has sponsored hardware to run this emulation. And since this week, I have a new student who's going to check what level of granularity is optimal for alert fatigue. Basically, what level of abstraction is the optimum between transferability and annoying the user with false alarms. And of course, we also have to take into account performance. Right? So such profiles can be hundreds of thousands of lines long if you have installers that do lots of chmod, chown, you know, that kind of thing, mount propagations, etc. If you install those without modification, your performance is going to degrade a lot. So this is another thing we have to take into account, is how much performance degradation should we have. Of course, we want it lightweight, again, versus how many false positives do we allow. And at this point, I want to head over to the totally different thing, which is the artifact side. Now, I've talked about runtime, but when we transfer something, we have to go through. And here's the harbor maintainer.
Yeah. So now that we have understanding the concept, we shift over into the hands of the user, and we look into, okay, how can we make this more accessible towards the user? So the user from our side is, of course, the software vendor, someone who is building those bit of behaviors. And then, of course, the user who is consuming or running the software, and he wants to analyze that. And there is, from the perspective of Harbor Container Registry, it's a perfect spot where you would bring those things together, right? And as I said, the SBOB and SBOM have a lot of similarities because you attach them to the artifacts. And this we need to display and show in our user interfaces, in our tooling. And one of those toolings is, of course, the container registry, where you have the SBOB information and SBOB details alongside your artifacts, right? The artifacts are the images and also the Helm charts. These are the artifacts that are residing in your registry, and they contain the SBOB information. And so the goal is extending the user interface to provide this information, giving you the ability to have a report view on those topics, and then the APIs. And this is kind of nicely aligns with the other implementations like the SBOM, our SBOB, and then the CBOB and stuff like this. So it aligns nicely, and this is also a work that we're currently doing as part of the LFX mentorship program. So it is kind of sponsored and supported by the LFX Foundation. And if you would like to kind of contribute, in a sense, if you would like to get started with it yourself, I mean, the best entry point is starting with the lab. Right? You can just it takes 10 minutes to get started, so it's really easy and convenient to just dive into the topic. And then, of course, you probably want to run this on your own software, right? You want to also profile your own software and to see how it's working. So you will try to use this one find errors, problems, and this is where you can actively contribute without diving too deep. Just try to use it with your own software. If you find problems, report them, engage, and then we can figure out what is missing and what is maybe not doesn't have the proper user experience that the software vendor or software provider needs, or the user, so we can work on that towards. And this is like a good way to engage with the cloud native and the community into driving this effort forward. Right, and yeah. In summary, so I hope you have a really clear understanding what is this SBOB topic and what is the software bill of behavior, that we're recording the behavior of the application, then can verify the application behavior afterwards and see, alert, and prohibit actions that the application can do or the user can do it. Yeah, that's from my side.
Yeah, looking forward to working with Harbor on this mentorship program to basically bridge runtime and artifacts and integrate it. We'll hear more about this actually. Cloud Native Austria in Vienna, we'll actually see Harbor as the second CNCF project that gets an SBOB after Pixie.
Exactly.
Yes. So, and again, I just want to also point out the individuals that have come to me with input of all sides, constructive input since day one, and I just, this is incredibly important if you're basically an individual person coming up with something like this. You need a lot of constructive but challenging input. So thanks to all of those individuals. If you want to hear more, Cloud Native Denmark will be talking about it, Cloud Native Austria for Harbor, in Munich at the IT Security Summit, and in Atlanta we have a talk with the CTO of Armosec, this Cubescape, and with Dom Delnano from Pixie. What is the big picture here? That this is a small part to build an open source SOC for Kubernetes. And so if you want to see how that fits into the whole landscape and reduces the data volume, that will be happening on Monday in Atlanta. With that being said, if you think the idea is cool, please start or open issues and questions. Thank you for listening.
Thank you.
I have one. First of all, thank you very much. Vadim, it's a question for you. When do you think SBOB will be in Harbor?
When it will be in Harbor?
Yes.
When it's done. Well, in open source we cannot make timeline guarantees, but we can promise that we will work on it, and eventually it will be available and working. And I think it also depends on the adoption of SBOB. So the more users are using it, the more pressure there is to have it in Harbor. So it's like one side feeds the other. So the more people using it, the sooner it gets.
Thank you. And now a question for the audience. How many of you are going to try SBOM in their environments after hearing all that? Good. Thank you very much.
Other questions? Oh yeah, there is one.
Question to Constanze. A short one. Have you thought of extending this to AI agents because of their probable anti-deterministic behavior? I think specifically there it might be of even more interest.
So to AI, so there are some parts. So first thing, what you should not use AI for, really quickly, if you were to use this and you see the currently regex expressions, you should not use AI for those regex, even though it is vibe coded. So that's the wrong use case for AI. Can we use it to detect the behavior of AI or if it's poisoned? Yes. For example, one important part is where do they talk to? Because MCPs, they talk to all sorts of backend servers, and we actually know, or we should, when we engineer them, know exactly what endpoints we're talking to and which could be poisoned. We saw the NPM attack September 8th, I think, where the debug package had a crypto miner in it. So that is the thing that is very, very easy for these SBOBs. We can say this is a database, it should look like a database. And again, for all the telemetry tools or AI tools that talk to someone else, we know what they should talk to. We can do DNS and we can do TCP. So that means we can check that is an allowed endpoint, that is really the GitHub Copilot and not fake GitHub typo squatted. So I think that is actually one of the things we should be doing, and I'm surprised that under the CRA regulation, we're not mandated to check where is the software talking to, because typo squatting has become such a big problem, and we're exporting either our AI prompts with our sensitive content, or in case of the observability tools, we're sending telemetry with sensitive content somewhere. So this is, I think, one of the most sensitive things that we should be using it for. Yeah, thank you for the question.
Thank you. Our next speaker is actually, what's interesting about him is that he just got out of a technical workshop that he was doing next door, and now he's going to be here on stage delivering a talk that I hear contains a live demo. So quite the stamina for anyone, really. He is no stranger to the community with 20 years of experience in the cloud-native ecosystem. He's known to most of us. We can see him very frequently on events. And today, he's going to be talking about how containers are built from scratch. Because, you know, before you eat the sausage, it's good to know what it's made of. Or rather, try to make one yourself. Warm welcome for Valentin Hristev.
You can use, yeah, that one. Doesn't matter for me. Oh. Alrighty. Go back, go forward. It seems everything works. All right, so how you guys doing? KCD, first time in Bulgaria, right? Just want to thank the CNCF community here, Vlad, Spas, Orlin, that made this happen, right? We were talking with them for years to that, and that the CNCF choose to allow KCD in Bulgaria. If you guys don't know, there was a ton of KCDs out there, and at some point, the CNCF just stopped them and say, this is going wild, so we're gonna just approve which KCD can be happening. So right now, just to know that this is not a coincidence here. So what we're gonna do today, we're gonna build container from scratch. We're gonna deep dive in the Linux kernel. We're gonna play with the namespaces, and I love doing demos because this is the easiest ways to get embarrassed and things to go wild. I just like the challenge, and that's why we're gonna do a demo. So we're gonna do 2-3 minutes introduction of what we're gonna do, and then we jump directly to a demo. So first of all, we are DojoBits. I'm a co-founder of DojoBits. We have more than 20 years experience. We have 6 countries which we're serving clients. We have more than 3,200 hours of delivering trainings, and we use more than 30 technologies. As the guy said, we have a workshop there for GitOps. Ilian is leading that right now there. This is me. We were part of the technical advisory group of runtime. This year in London, there's no more TAC runtime. They changed a lot of things there. I want to thank the Kubestronauts fellows here. Me and Ilian are also part of this great community. There are a couple of Kubestronauts here among us. And that's pretty much it. So just to know that this lecture is inspired by Lisp. If you're aware, Lisp is part of Isovalent. Cisco bought them. They created Cilium. But they call it the Liz Rice Company, right? If you know Liz, she's great. So, a little bit of history of containers. First of all, containers, there's no such thing as a container. It's actually a process. And we use container just to think about it. So back in days, the BSD, we start with chroot. It's coming from change root. After that, we have the FreeBSD, which we use GEOS. We use GEOS to hardcode your home directory, so you cannot go back. So all of the FTP servers was working like that. Soares zones still used in the ZFS. After that, a little bit later, OpenVZ, we have the Linux containers, the LHC, and the Docker. So, do you guys know why Docker was so popular and it was a breakthrough? Anyone? CLI? Docker files? Something else? The idea is you can see that the containers are not something new. The only reason the Docker was succeed was because it was super easy. That was the main idea. Because now, with a simple CLI, you can mess with those namespaces and create containers, stop containers, distribute them, and etc. So now we're going to talk about Linux namespaces, not the containers at all. So what we're going to do, we're going to build container from scratch. This is not the images. We're going to play with the namespaces. So we're going to use a couple of namespaces to create our container. And when the container is created, actually the image, then you can put your application inside. So we're going to do the container part. How we do that? We are exploring something which is called Linux namespaces. You can find them under Linux/process ID and the NS. You're going to find there a bunch of files. And those bunch of files are actually those namespaces. So there are 8 namespaces. We have the C group. This is not the C group S. This is the C group. So the devil is in the S. The inter-process communication, the networking part, mounting, process IDs, Unix time sharing, and user. And 2020, the time was introduced in the namespaces. So if you watch a little bit older videos, you can see that time is not there. Awesome. So something else that we're going to use is the change root, the ch root. So the ch root is going to change your directory to some other directory, and that's your root from now on. So you're like kind of fake root, so we isolate the file system. How we do that? In the Linux, we have 2 main things, the user space and the kernel space. And we as humans live on the application level in the user space. And through the syscalls, we get to the kernel. And inside the kernel is the kernel space. So we're going to play with that today on a low level. That is what actually Docker is doing. Docker is playing with the namespaces, create a container, isolate them, and that is how it works. So for example, if you run a sleep command, and let's say that the command is sleep 1000, you can see the process ID. This is from the host point of view. From the container point of view, you see 1, right, as process ID. So it's totally isolated. And for example, if you want to see from the container the host machine process ID, you can use docker pit host, and that's going to give it to you. Alrighty, so are we ready for the demo? Perfect. So, question, do we have a Python developers? Yes? A lot of people. Sorry about you guys. We cannot do it on Python. So, there is no direct way of Python using the system calls because it's a little bit hard language. So we can use C. If you want, we can use Rust. And the native way, the Kubernetes way, the Docker way is Go, right? But it's whatever you prefer. So now, over here, I have my application, which is called main.go. And we start from here. How I can fix that? You never know. Okay, now I cannot see it. That's why we love demos. That's weird. Okay, let me just try something. Try to connect again. Yeah, but I cannot see it from here. Here it is. Nope. Perfect. Ready? Can you hear me? All right. So now we have the main Go application. So we're going to create a little brother of Docker. What we're going to do, we're going to use the Go, and then we're going to say run, Go, and main.go, and then we're going to say run. And when we use Docker, we specify the image. Here, we're going to specify a command. And after that, we're going to specify arguments. So here, let's create our function, main function, which is going to check for this run. Right? So we're going to say function main. We open the brackets. And here we're going to say switch OS. And in case of run, we want to run the program, the function. And here we're going to have a panic if anything else happens. And we're going to say, now it's time to panic. Right? Tip, tip. Perfect. So now we have our main function. So let's here create the run function. And to be a little bit verbose for visibility, we're going to use the FMAT. So here we're going to say function run. And we're going to use FMT print F. And we're going to say running. And we're going to say arguments. So we're passing whatever, when we say run and we check the program is running, whatever we run after that, we're going to pass it here. So let's test that out. Yep, I'm going to open a new screen. Can you see it? Is it fine? All right. I'm not going to go to the Mac. It's pure Unix, so we have a Vagrant machine. And inside of a Vagrant machine, we have a demo. I am a very lazy guy. And yes, demo, something like that. But so now here we have the files, like everything from my computer in the Vagrant. This is the same. So we're going to use the same thing which I used for Go, run, main.go, and then run. And here's my command. I'm going to use the echo, and I'm going to say keycd. All right, so of course, we need to close that over here, go back. Perfect. It looks as hell. So let's just add a new line. And all right, so we can execute echo. That's perfect. So let's play a little bit. And the easiest way is to interact some shell. So we're going to run a shell and play with it. So let's play with a shell command. So here we need the OS exec to be able to do that. Yeah, and here we're going to say command and we're going to pass whatever the shell, right? The first argument is run, the second argument is going to be bin bash, and now we say everything which is inside bash and whatever arguments we give to the bash. So this is the command over here, and we want to be sure that this is going to run. All right, finger crossed, we run it again. Okay, echo is running. Let's say bin bash. Now, question. Do you think I'm in a container or not? No? Yes? Maybe? All right. So this is the container, and I'm going to open another session over here, which is going to be the host one. So we're going to have those both view. One of the things is I can zoom in, and I'm going to use PS, and there's something which is called forest, right? So now we can see it. And it seems that this is my session to the host, but this is my session for the container. And it doesn't look very well, right? And that's because every single program, for example, if you execute sleep, and let's say sleep for 15, and list the proc number of the pit, and then FD, do you know, guys, what is FD? File descriptors, right? So we have standard input, output, error. And our program doesn't have that. So over here, we need to implement standard in, out, error. So again, with the CMD, we're going to do CMD standard in, standard out, and standard error. Perfect. Now I'm cleaning everything. So I'm back to the view, and I'm going to run it again. Same thing, right? Nothing obvious. But when we go to the host and execute again the command, the forest one, now we can see this. Huh? So we can see that we run a command, it's running bin bash, and here is our exe, which is the binary, and we are inside this bash. So look these numbers over here, 23, let me just do it like this. Now you can see that the container is actually a process. Perfect. We are getting somewhere. But the problem right now is I cannot say which is the container and which is the host machine. Okay? So what I want to do is to set a host name. One thing that I can do is directly inside the container, because right now we know we are in the container. We can say host name and say keycd. What do you think is going to happen when I hit the enter? It's going to change the host name? Yes, no? Yeah, you need to be root, right? So we exit the container, we switch to sudo, and then again we go to the ground demo, we run that, and now when we say host name, we see it's Vagrant, and when I say keycd, now the host name is keycd. And when I walk out and walk back, what do you think is going to happen? The container is still not going to have this host name. Let's check from the host point of view. Whoa. So the container was able to change the host name of the host, which is bad. This is a security problem. Do you guys see any kind of isolation here? No, no isolation, right? So this is bad. First of all, on Vagrant, very bad idea to change the host name. Things start getting slow. So I can bring it back. So we need to change the host name, right? And what I need to do is to implement the namespace. So here we start playing with the namespace. So the namespace, which is for hostname and domain name, is called UTC. So this is the Unix time sharing. So implement UTC for isolation hostname, right? And we're going to use the sysproc attributes over here. And we need the syscall, right? And over here, we're going to say clone flag. And we're going to go back. We're going to delete that because we don't need it, and we're going to close it. So we use the flag which is called clone new UTS. If we come over here and open the man page for namespaces, you guys can see this, right? The second column is actually the flags. And this is why we're using the syscall, and then we're using the flag, whatever the namespace is. If we want to play with IPC, with the net, with the NS, right? Actually, the mount, which is NS, was the first namespace. That is called NS. All right. So save, and we go to the machine again. Am I inside the container? Who knows? Maybe I was there. And I'm going to run it again. Let's see. Sys proc attribute. Okay. Now I think it looks better. All right. So now if I change the hostname to keycd and list the hostname inside the container and go down, and this is my host, the green one, and say hostname. Awesome. So do we have isolation now? Perfect. So we're moving slowly but surely. Now we need somehow to set the hostname. We can set it here inside the program, and we can set the hostname using, again, syscall, and we can say syscall and of bytes, and we can set the hostname. And we're going to say keycd Sofia container, something like. Do you think that is going to work? The Go programmers? Those are my 4i principal guys here. So if you see me do some crazy stuff here, please slap me. So the problem is you need to have the namespace to set the hostname. And the namespace is going to be executed over here when the run starts. So I cannot put it here. If I do it after that, it's still not possible because it's out of the entire process, right? The process is going to run, and after that, this program is just hanging in the middle of nowhere. So we need to figure out something else. And this figuring out something else, it's called fork, right? So we have a process, and this is the parent process, and the parent is going to create a child. So what we can do here is to copy that, the entire thing, and I'm going to paste it. And I'm going to go down. I just copied the entire run function, and I'm going to call it child. And I go back because I forgot very fast, and I want to be sure the child is going to run, right? And we're going to run the child. And I want to tell the run command, after it's done whatever it's doing, run the child. So one of the things I want to do here is to say main process with pit, and the pit is going to be this. Oops. And I'm going to get the pit from the get pit from the OS package, right? As I told you guys, I'm lazy, so I'm going to copy that. I'm going to put it over here, and I'm going to change the process name to be a child. So this is the logging, right? Whatever we see on the screen. I just want to be sure that you can see how we run a process, and after that we run another one. All right, so we're here, and we don't need that command anymore, because this command is going to run the main one, but we want our main program to run the child, right? So here, we're going to use the same thing, but we're going to use something which is called exec. And as you can see over here, we're using proc self, right? So if we go a little bit here, I don't think I need the host anymore. If you list the proc self like this, you're going to see it's a link to a process pit. And this is the iOS command. When I run it again, and again, the process ID changes because the program starts doing whatever it's doing, and then it's over. And this is what you have with the exe, right? It's a bin-iOS. So we're referring to the main program itself. All right, again, we need those three guys. We create the UTS namespace, and we're not doing the hostname here. We're going to do it in the child. And there's not so much change here, right? We run the program. We don't need those because the namespace is going to be creating the main process. So the main process is going to create the namespace and create a process in that namespace. And this is the child. And the child is going to set the hostname. Finger crossed, and we run the thing again. Let me just, okay, I was inside. So now, I know you didn't get there because there was no applause, but now the host name is changed. Yeah, you can see it over there. Thank you. And you can see the two processes. We have the main process, which is the father, and here is the child, right? But there are a high number of process IDs. And we want to have the isolation, because when I hit PS, I can see the host machine process IDs. So what we can do here is we can implement another namespace, which is called pit, right? So we're going to do something like this. And I'm going to go here, and I'm going to exit, and I'm going to run the bash again. And now you see it's 1, right? So now the main process create the namespace, put the child set the host name, but now it's process ID 1. Let's see PS. Now it's bad. It's worse than previously, right? Now I can see much more stuff here. And this is because actually all the programs are working from, let's say we're going to run a sleep command, and we're going to, let's go back, and we're going to run sleep command, and we're going to run, for example, for 15 seconds again. And we are getting that from here, 23. And if you run the namespace, you can see the namespace over here. So those are the 8 namespace plus those 2 childs. But the idea is the program is working with /proc, which means file system. And this is sudo file system. We use it for the kernel. So what I did here is I create another Ubuntu file system. I just download the root file system for Ubuntu. But I put this, I just touch a file so that you can be sure we're in the right place. So now we're going to use the chroot to change the directory to the new one. And that's inside here, right? So in the child, where I change the host name, we're going to say chroot to root fs. So now we're going to use again the syscall, and we're going to say background demo. And it's good to change the directory to be the /, right? To be the root. So let's run it again. And now you see how I'm changing the root directory? When I say ls, do you see that now I'm in this jail? Right? This touch file prove it. And the cool part is I want to go back, right? And the problem is I cannot go back. So when you create an image, this is what is going on. When you create an image, you just, the Docker program change root you in that image file system. Perfect. So now the PS should work, right? Yes? No? Maybe? No, it's not going to work. Why it's so negative? son, right? It's not gonna work. Because this file system, now the proc is like directory, nothing special. And actually, if we use mount, we should see it here. But we changed the directory, but there's no special mounts. That's why the mount fails. That's why the PS fail. And PS give us a hint. They say, you maybe want to mount the proc file system from proc to destination/proc. It looks obvious, right? Let's do that. So now we need to mount the proc, right? That's what we need to do. So now we're going to do again the syscall, and we need to get those parameters right. So we mount the file system, source, and destination. And do you guys know what is going to happen if you start mounting file systems on top of them? Last one wins. So it's good to unmount when container is gone. So now we're here. We run it again. Now the PS is 1, the master, parent process, and now we have the pit, which is 1. And now we isolate the process IDs. So if I run sleep in the number of the universe, when you do PS, maybe, yeah, no, you, like this. Now you can see the process ID from the host machine, 4242, is higher number, 23,000 something. But from this machine, right, it's going to be a different one, but you get the idea. Here is how the host is, and you can see the process ID from the container is actually 10. So now we isolate the host name using the UTS, we isolate the process IDs using the PIT. And for example, when we start isolating users, we can use the user namespace. Couple of years ago, I made a talk for Kubernetes networking one-on-one. So we create software-defined network from scratch. We create 2 containers, we create namespaces, we put the TCP stack there, we create IP address, network mask, gateway, DNS, then we start playing with the ARP. The networking maybe is the hardest one, so we're not going to do it here. So that much pretty it, guys. So that was our program, which is around 70 lines of code. And after that, you can implement the C group and the C groups to the control groups. We're using them to limit the CPU memory, whatever I/O we have. And the C group namespace is, because the C group, the new model one, it's version 2. I need a file system and do archi inside that now system. So the namespace is going to take care about the file system, and the C groups is going to take care about the limits of the resources. And this is how you build a container. Thank you. I think we have time for questions, yeah? Please don't ask anything. Now I want someone to ask anything. Right. Okay, so if there's no question, thank you for attending my session.
Thank you. So just a quick reminder, we're going to take a break now, and we should be back sharp at 3. There is a cocktail after the event, so please, if you can, you should stay. There's going to be drinks, and, well, drinks, really. That's what you get on a cocktail. Feel free to check out the booths of our partners. They are essentially a big part of the reason why this event is actually possible. Thanks. Welcome back. I hope the break was refreshing. We're going to continue with yet another joint talk by Yuri and Tobias, who are going to talk about application abstractions the Crossplane way. So please welcome them on stage as well.
Still don't see. Are we on? Hello, everybody. Hey, hey. Hello. Mine? Hello, everyone. Welcome. I hope you had a good break. My name is Tobias, and I'm here with Yuri today. We're both a solutions architect at Upbound, and we're going to talk about application abstractions the Crossplane way. So, first of all, we assume a little bit of Crossplane knowledge, so we don't have the time to do the full introduction. And as you most probably know, Crossplane was more built and designed for managing infrastructure. So with the recent release of V2, this changed fundamentally. That's why we'll talk about V2 a lot in this talk. And let's go further. First of all, what was wrong with V1 in terms of managing applications? So first of all, everything was cluster scoped. That means if you want to give your developers access to manage an S3 bucket, your only way was to wrap it into a composition, then expose a claim, and then you could give that claim, because it's the only namespace component, access to your developer to deploy that claim. So we changed that. So managed resources are now namespace scoped by default. You can still have them cluster scoped if that's what you want. And that should simplify a lot of things, and it doesn't put like a constraint on your architecture, and it should fit more use cases. On top of that, you no longer need to wrap objects in provider Kubernetes, which was a massive overhead before. So we fixed all that. Composite resources are also namespaced now, so you can freely choose what you want to have cluster scoped, what you want to have namespace scoped. You can have RBAC policies giving your developers direct access to managed resources, so that hopefully makes your life a lot easier when managing applications and giving your developers access. This is how the architecture looked before. So as you see, you have a clear separation of concern between the platform team and the app team, but that boundary is also enforced. And as you also see, like the claim is like the only object which you can have namespace, which was a lot of problems, and also the whole the definition of a claim created a lot of confusion with people starting off with Crossplane. This is how it looks nowadays. So in the default model, everything is namespaced. It looks a lot easier. So you have your composite resource, which is in a namespace, and it creates managed resources, which are also in a namespace, and that highly improves the security posture. And as I said, it really simplifies the design, and without putting any limitation, because you can still be cluster scoped if the previous model is what you prefer, but without the need of claim. Just as a refresher, this is how like composing an arbitrary resource looked before if you were using Crossplane for managing, for example, a config map in this case. So that creates a lot of clutter. You need to always wrap it, and if you have like a bunch of resources in comparison to a Helm chart, for example, it looks way more complicated than it's supposed to be. This is how it looks now, and for me personally, it feels like a breeze, because now you can finally use it properly in a way to manage applications. So we have a few intricacies as well. So as with every redesign, there always comes a couple of pitfalls and a few changes, and one of them is like we unified the way how secrets are managed. Before you had this write connection secret to ref. We removed that because you also can compose secrets in your composition, and so you have a clear separation of concerns, and you know exactly there's one way of managing secrets. Also, we introduced spec.crossplane, because before everything was sort of polluted under the spec, Crossplane internal properties, and now that's all namespace, so
there's no need to, what users did before, introduce something like spec parameters or any similar pattern. And one word of caution, if you use namespace managed resources and you had something like a VPC ID ref or other Crossplane references, you can obviously not use that to reference objects across namespaces because that would break isolation. So we're coming to a few demos. The first one starting now to just, Yuri will show you how that actually looks in action.
All right, let's try with the first straightforward model covering V2. But first of all, quick show of hands, who used Crossplane before? Cool, and who used Crossplane in production? Very nice. And who used V2? We have some work to do, so that's why we are here today. Perfect. So, by the way, all the repositories that we are covering in our demos today, it will be 3 of them, are available in open source manner, so you can check them out and play with them afterwards. So, first one is app model. So, I will quickly switch the context, and we will check what we are. So, Crossplane cluster is ready, right? And we already have some applications that is running. So, it's some theoretical app with your custom API version group, so everything is abstracted by Crossplane. And there is some spec that you as a platform builder or application builder can create by XRD and implement the logic in a composition manner. So we will use a standard beta trace to see the app that is already deployed. And here you see if you used Crossplane before, you will immediately notice the difference between V1 and V2. Now we have an ability to compose Kubernetes in-cluster resources directly with a Crossplane composition engine without any provider Kubernetes wrapper object. So now it's much more better. That's exactly this direct composition ability that is available for you. Then you will have ability to implement this application model in any language you like. Here we picked our favorite language of KCL. Who heard about KCL, by the way? Yeah, cool. So KCL is a pretty advanced configuration language that we are frequently using in Crossplane scenario. And here we have an ability to express the logic, composing the stuff directly. As you can see, like ingress directly compose without the wrapper object, and we have advanced schema validation that is implemented in KCL. So this is what we love, but you can definitely switch to other Crossplane composition functions like one for Golang or Python and implement in any language you like. So this is a very short demo that is targeting on in-cluster Crossplane V2 capabilities. So what we just seen, just to recap, direct in-cluster object instantiation with the Crossplane composition engine, implementation of app models that we didn't invent anything from scratch. We basically, Tobias re-implemented in KCL with motivated by Helm create, and we can package it nicely as a Crossplane abstraction and benefit from a strong typing like KCL in this case. And as you can imagine, next to the standard Kubernetes in-cluster object, you can drop in any kind of databases in multiple clouds and do the standard Crossplane way and put everything, including application, behind the API line. So that is for the first straightforward demo. Back to Tobias.
Thank you, Yuri. So here we saw how we can all manage this app model declaratively with Crossplane with all the benefits, and that by leveraging V2 features. And instead of just like redesigning and fixing the problems we had, we also came with a few advanced features which you will need if you implement the proper app model. Let's start with the most important one, most probably, is operation functions, because what we didn't have in Crossplane so far was day 2 operations. So maybe you want to do like a snapshot of your database, or maybe like your application changed and you need to restart an external service, or whatever it is actually you want. So it comes in 3 flavors, like just a one-shot operation, a cron operation, or even a watch operation where you can watch any Kubernetes event and react on that. And it keeps the existing pattern of Crossplane functions. So if you already have Crossplane functions, you can also like operationalize and reuse them. And that brings your application on the next level, because now you can handle the whole application lifecycle, Crossplane native, Kubernetes native, and
This is how it looks like, for example. So this is a normal cron operation. Maybe you want to continuously check certificates and renew them or whatever. And most importantly, they also enable AI, because it's actually the perfect place to inject something like here function Claude. And we will see in a second in another demo that with this system prompt, you are an intelligent RDS scaling system that analyzes XSQL instance resources and makes scaling decisions based on CloudWatch performance metrics. We already built a prototype of how next-gen infrastructure could look like if we want to handle operations off to agents. Yuri?
All right, let's run some fancy AI stuff. I will not be asking who heard about AI, so let's switch to our second demo. And first thing first, we need to switch the context. Sorry for that. Yeah, that should be the correct one. So what we are going to run and to look at is a simple database abstraction. So we will start with it. And here you will, like, if you work with Crossplane, and actually if you run any RDS, you will notice like a standard spec for the database. We're going to deploy it, and Crossplane will do the external API call, so pretty standard thing. And we control the spec of the database, like instance sites, etc. What is special about this example, though, is if you look at the composition RDS metrics, so it will use a standard composition function for composing the managed resources, and also we adding to the pipeline a function RDS metrics that is going to collect the CloudWatch metrics from associated database, and it will be like a self-monitoring abstraction. So effectively, it will look like the following. So I'll just get a runtime SQL instance abstracted by Crossplane and pipe it to IQ, so we will get some colors. And we will see that, yeah, it's running, it has our spec, as I showed before. And now the interesting part is that we have metrics that are published runtime with some time period, and SQL instance is basically monitoring itself. It exposes its own performance. Good. So now what we are going to use with these metrics? We will use a cron operation, and it will look like the following. So the cron operation, that it's a new V2 concept that can run a function in operations pipeline, not in a composition pipeline, but outside action, right? So we will use a function Claude, and this function is like it pipes some request to AI, right, and provides the in-cluster context. So here we are going to run an autoscaler. So we are asking, like, please act as an intelligent RDS scaling system, and we providing some criteria. And effectively, we kind of writing RDS autoscaler in a plain English, which is kind of fancy, and provides a nice use case for intelligent control planes. So this stuff is already running for us, and we can get a cron operation like as a spec, and we can see the operations that were already executed, right? So, and we can, for example, describe one of the operations that were executed a while ago, and we already see that our intelligent operational function, it evaluated the spec, it evaluated the performance metrics, and it makes a decision. Like, no scaling needed, we are cool with the performance, and it set the special annotations, right? So we have a direct exposure of the things that are happening on the runtime SQL instance spec. So our operator of the instance is aware what our AI-based autoscaler is actually performing. So what I'm going to do now is to run a perf test. So basically, intentionally stress test the database for performance metrics. And we don't have time to wait, but I will run a simple scale monitor. And we will watch the annotations and run it for a while, and we'll see if the stuff works end to end. So wish us luck. And back to Tobias, back to slides. We'll return to it in a couple of minutes.
Thank you. So if you connect the dots to what we saw previously, so we have an app model and we have this XSQL instance, Crossplane makes it easy for you to put this all under one umbrella. So you have one API call which you can offer to your developers. So your developers can provision an app with a pre-configured database, and then as a cherry on top, you can even have it like automatically scaled by AI, or maybe you want to troubleshoot it automatically. That's all possible now. I've skipped over the recap. Okay, so the next feature, which is completely new with V2, is managed resource activation policy. So for those of you who have been using Crossplane for a longer time, you most probably know that Crossplane is notorious for bringing a lot of CRDs to your cluster, which in the past did even break clusters on some cloud providers. Not blaming Google here. Yeah? So now that you have managed resources both as a cluster scope version and as a namespace version, you're actually creating the same problem again, because now you're multiplying everything by 2. So to kill, so to say, 2 birds with 1 stone, you have now managed resource activation policy. That means you have a simple object that will show an example in a second, where you can define which CRDs you want to install in your cluster and which not. Just that you see, like for all of you who want to try out V2, everything which starts with an M is like the namespace scope MR, and the other ones is cluster scope MR, and this is how the policy looks like. Here are 3 examples. For the first one, we have modern V2 style S3 buckets, so this enables exactly the buckets S3 API and nothing else. And the second one, we choose like V2 style namespace RDS instance, or you can even use wildcards if you want to, for example, enable all V2 style EC2 APIs, which are also quite a lot. Okay. So a word for tenant safety, because Crossplane does not automatically have access to manage all your custom resources. So that's why if you want to manage resources controlled by an external operator, namely external secrets, for example, or similar, you need to actually extend the Crossplane service account manually with the permissions, and remember to be as restrictive as possible to comply with principle of least privilege, to keep your cluster as safe as possible. How does that look like? For example, here, simple cluster role for a little bit foreshadowing another demo, which we're going to see in a second, KGB. And here we just give it access to manage the DNS endpoints, also part of the external DNS API. Now for Yuri and the third demo.
All right. So let's go for the third demo. And what we will operate here is a so-called global app abstraction. So this demo is based for one of we implemented before as a global blue-green deployment. So I'm also creator of a Kubernetes Global Balancer KGB project, and from time to time, where it makes sense, I'm combining both project power of both projects into one. So that's one of the case where we creating some form of global app and global control planes. So here I will not run a full global load balancing demo, but we will focus on actual machinery that enabled by V2 in this scenario. So here we have like a global app deployment. We can standard way Crossplane beta trace it, and we will see that in our, that global app abstracts the external resources creation, right? In case it's Azure, right? So previous demo was AWS. This demo is Azure, so we are truly multi-clouds. When we work in with Crossplane, we encapsulate an in-cluster release, which is actually in-cluster application deployment, namespace-based in this case, and we instantiating the GSLB. It's a special custom resource that reconciled by KGB controller. So basically, additional operators that we bring into picture, and everything works out of the box. So here it's just a glitch of beta trace, so we can ignore it. It's because I'm using in my other project Crossplane style references, so that's why Crossplane beta trace is getting confused. Otherwise, everything works. So what we have in this cluster, we have this deployment, right? And we can look at the GSLB customer resource itself, and it will expose transitively, it will monitor the healthiness of application and a global state, right? So it will say to us that service health is okay. And then we pick up the status by a global app. And global app actually defines the logic, how to behave according to the JSLB scenario. So if you look quickly at the architectural diagram, so it will make it everything more clear, hopefully. So we run Crossplane v2, we are watching this custom resource of JSLB for a health, and then we're making this decision during the composition of standard managed resources, which management policy to apply. Either we doing it read-write, like a star management policy, so it's an active cluster, or we are switching to read-only mode in a passive if something goes wrong. So, that's roughly how it works. And we can look at the current management policies on our managed external resources. It is star, so everything is healthy. So let's actually introduce some disaster. So in this case, it's easy. We just scale deployment, and we will see how our overall distributed system reacts to this event. So we can look at the underlying JSLB resource. It's already detected that application is unhealthy, so is that expected? We can look at the global app and see that JSLB is already switched to observed. It properly detected that the cluster is unhealthy, and so JSLB traffic is routed somewhere. And we can double check that everything was properly propagated down to the managed resources. So now we have a get for Redis cache and same for resource group. So everything is properly in read-only mode. If we scale the stuff back, eventually it will also heal itself and will make the cluster active and put everything in read-write mode. So what we just seen, just a quick recap. We can, thanks to V2, we can directly compose namespace resources for external things like resource group and Redis cache, in cluster like release, and a custom operator like JSLB, KGB stuff in this case, and put everything behind the single consistent abstraction. It will create a resource for your custom operator, expose enough data in a global app status so everybody aware what is happening. We will propagate the management policies. When we, in case of any disaster, it will pick the status immediately up and will propagate the read-only mode to the composed resources by the application. So the cluster will still be alive, but it will only read data from the external APIs. And the same will happen when we heal the deployment, and everything will be routed back. So thanks to this mix of the machinery, you can already see the pattern, right? So here is an example for KGB controller, but you can drop in virtually any operator, and you can mix in the power of existing operator, Kubernetes operator ecosystems, and abstract them cross-plane way. So that is for this demo.
So connecting the dots all again, so we see like how you can hide behind this simple API, which you can give to your developers, like a globally scalable app, which is resilient and self-healing and including databases or Redis caches, and all by potentially using type-safe tools like KCL. And this all is enabled by using V2. So if you didn't check out V2 yet, please take a time. Let's talk a little about future-proofing and the whole ecosystem around V2. So first of all, it's fully backwards compatible, so nothing stops you from using it in your existing cluster, and we guarantee it to be at least 4 or 9 months. Like all providers, XODs, and compositions will keep working as they are, but we also removed a few deprecated features. They're deprecated since a long time, so you shouldn't worry too much about them, except for using Crossplane since the very beginning, namely native patch and transform before we introduced functions, controller config, which is superseded now by deployment runtime config, external secret stores, and also we require now to set the default registry for Crossplane packages explicitly everywhere. how do you upgrade? So an upgrade is very simple. You just do a Helm upgrade with the right version. You just need to have the right Crossplane version, namely re20 in this case, and the right Helm version installed. And we advise you to install one of these managed resource activation policies in order to not like kill your cluster with a bunch of CRDs which you're never going to use. If you're going to write new compositions and you want to use the namespace compositions, then you need to replace all the MRs with namespace versions, as you remember with the .m, and we have a little bit of a guide. You can check this out later. And for existing compositions, there is actually tooling on the horizon. There's nothing finalized yet, but stay tuned for that. Then last but not least, let's talk a bit about the future of provider Kubernetes, because there's still valid use cases for using provider Kubernetes. The first one is if you use Crossplane to manage actual clusters and install workloads on that cluster, you still need provider Kubernetes in order to deploy to that remote cluster. So it gives you full flexibility without limitations on where you deploy, and also advanced lifecycle management. So if there's resources which you only want to observe, you can use management policies, or if there's some stuff which is which you never can drop, which is has some persistence to it or whatsoever, then you can use deletion policy of orphans. So when Crossplane deletes the resource, then the actual backing resource is not removed. And before we go to questions and answers, we will check on our AI demo and see if the system automatically scaled.
Yeah, let's try and see AI stuff. I have no idea if it worked, so let's see. So we are continuously, so recap what we are doing here, we are continuously monitoring the performance events, and apparently it didn't work for some reason, because recent scale up 70 minutes ago, current low utilization. We didn't manage to stress the cluster, the database enough. But I can show at least how it's supposed to work. So in a standard scenario that we rehearsed multiple times, and obviously it failed. So what we have here, the performance metric are getting collected, right, and evaluated by the cron operation with function cloud. The original spec is dbt3 micro, and after a while, with the cron operation, when everything is overloaded, an AI will see that CPU utilization is serious, and it will automatically scale and patch the instance class to the next more powerful instance. And this way, it will effectively drive the auto-scaling, and it will also scale back when we have any when the performance load is getting lower. So I probably don't have a time to debug it now, but let's at least see how it behaved, and if we have any performance data got back. Yeah, it's just too low for some reason, and I'll just stress test it again, and maybe after we answer questions, you'll be more lucky. All right, question and answer. Any questions to what you've seen? We have some time for AI. Anything Crossplane related?
Well, thank you.
Yeah, thank you so much.
Just too powerful database today. That's it, I guess. So, observability in Kubernetes is kind of a gnarly story, right? Like, you've got a bunch of tools that you need to choose from. You've got Datadog, you have Grafana, you have some of the service meshes doing some observability things, some better than others. There are some eBPF tools, and it's just kind of like an interesting ecosystem that's a bit all scattered all over the place. I guess that's version 1, right? Version 2 is something that Nicky Doksky is going to tell us about. So let's welcome him on stage.
Right. So let's get started. Anyway, welcome to the session. We're going to talk a bit about observability, and I was thinking we have 30 minutes for this session, and I wanted to convey a single message to you. So one takeaway that you can get when this session is over. So I will not bombard you with too many information, but I would rather take you to kind of a personal journey in time with me. So, how everything started. So last year, Kubernetes turned 10 years, which is quite impressive per se as a technology. And my journey, or when we started with that technology, was around 2016, 2017. I was part of a product organization where we have a classical three-tier architecture cloud application, where we had on a bunch of application Apache HTTPD servers in the front, offloading static content. Then we had Apache JBoss and Tomcats for the application servers. Next to them, we have Kafka, Apache Zookeeper, Apache Solar for searches. And then at the end, we had these mighty persistent layers. And at that time, the biggest problem that we had was how to reduce the time that we invest in effort in validation cycles for these mighty cloud applications. And because when we have all these components, a lot of things are moving around, configurations get scrambled, dependency gets wrong, and it was really, really painful. So we said, hey, Kubernetes just came around, and we said, maybe we can take it and provide an environment where all these things can get quite stable, predictable, and repeatable. So that was our selling point, to get our time and effort invested in this technology, and it get accepted. And Kubernetes in that time was kind of this sweet spot of a technology which is not ready for production for sure, but still good enough to be interesting and to play around. So we sat down and pet sets were there, the stateful set were not, or at least not finalized, init containers were not there, so we had to invent certain things. RBACs and CRDs, they just came around the corner, and dynamic persistent volumes, and scheduling, advanced scheduling were also kind of an interesting thing. Of course, the only way back then to provision these kind of environments, it was only the hard way, so no other way. How many of you know about the Casey Hightower Kubernetes, the hard way paper? Yeah, cool. It was super interesting. Nobody can get it running for the first time, maybe from fifth, but it was fun. And of course, the moment you bring your Kubernetes up, at that point of time, you are starting to put the observability stack. And at that time, we didn't speak about observability. We had a logging stack, and we had a monitoring stack. And of course, for the logging stack, we use the mighty Elk stack. So how many of you are using Elastic, Workstation, Kibana? Right, yeah. That was the logging. It would work, yeah, okay. It was good to the extent that, we were able to collect all of our logs there. We had a problem with scaling up at that time, but then we put a message broker in between, so we separated the producers from the consumers and persisting, so it was kind of okay. Metrics were there. There was no Prometheus stack. Prometheus operator was around the corner, but it's still part of CoreOS, as far as I remember. And basically, we said, okay, here are walks, here are metrics. We try to collect them, put them in a backend storage, run the tests. If something goes wrong, then try to hope for the best. So let's take a few years forward. So that was 2016, 2017. Back there, when we walked something, it was a plain text. No context attached to it, just whatever the application would spill out, we collected. And then slowly, in time, we start to add additional context to these walk messages. We put maybe not only the message, but let's say what type of operation, what type of the user. And by 2020, there was this prominent article on Kubernetes about structure logging. So it took us 5 years to come up from a plain walk message to the realization that we need to wait to put a context in our observability data. And now later, when 2023, then there was another attempt to go a bit smoother, where we have contextualized walks. And these days, we are more or less came to the conclusion that it's a very good idea to write our walks in a structured JSON format, store them, and maybe later, when we want to extract the data, then we can have a query type of specification to only extract the meaningful data. Okay, now, what we have today. So for these 10 years, the tools get more mature, the ecosystem grows bigger. There were a number of commercial vendors, quite okay. We introduced a different type of observability signals called trace, but the way we put context in these observability signals didn't change much. And just for example, so here, I'm running a small test environment where I have two services. One of them is a front-end service. I'm hitting regularly with some kind of request. It's humming around 5 milliseconds, so we are quite performant. Everything's fine. And when we talk about observability, usually in the situation that I just showed you, usually there are different types of questions, or at least those are the most prominent 3 types of questions when people are asking themselves when they interact with a running system. So usually how I'm doing, right? And that is usually the metrics are playing around, so how I'm doing quite well. So 8 milliseconds is quite good. But things get interesting where I introduce some kind of a problem into the system. So let's simulate a bit. So here I'm just curling around one invocation. This is interesting. This will generate an error message, or I can also generate some kind of delay. Let's get back. So the response time will spike up to 8 seconds. And this happens quite a lot. Even now, when you're running the operating system, this is usually what you observe. And now the question is why? Well, what actually happened? And this is the second question that we have frequently asked ourselves. So how I'm doing, and if I'm doing bad, then what happened? And if I have a multi-service type of architecture, then who is involved? And so here it is. Usually the current dashboards that I have seen or I'm seeing much often they don't tell you much, apart from they signal, say, a problem. And usually, I'm sure what everybody does is try to see which pod or service is generating this type of situation, and then goes in the UI and search the logs or search other related type of information. But there is no immediate way to interconnect or relate or correlate the data, the different type of data or information. In Gartner today, so as I said, 2016, they were running only 1 or 2 clusters. It was painful to set them up, but it was fun. And 10 years later, and this year, I'm running in totally different environment. So right now, we operate tens of thousands of clusters or control plane for these clusters. Some of them are very short-lived, so they come up and go for, let's say, minutes, because they are part of some CI/CD type of environment. Some of them are development clusters, so they live longer, but still they don't run production workload on them. So they're not that critical, but they're also quite of critical clusters which run production workload, and where observability is really, really important for them. So, let's see. I generated the error, and this is the error that was shown. And now the question is, yeah, why I have this? And this is really a problem statement, or some other dashboard reveals some deviation from an accepted range, and then alerts are getting fired, and so on and so on. And to me, since couple of years or months, the people or the community or the practitioners around us, they more and more speak and talk about how important is correlation between the different types of data is, and how that can be achieved. And here comes the observability 2.0 term. So we don't fundamentally change the questions that we ask towards the system, but we have a different means to represent the data and to ask and correlate the data which are coming from the observability signals. By the way, for example, on the question how I'm doing, usually this is metrics, but it's not necessarily. There are many examples where we have walk serving or answering these type of questions. For example, when we perform a walk aggregation type of queries. To what happened, these also traces can play in that round, and who is involved, also walks and traces come. So it's really, when we ask these questions, there are multiple sources from where we can get information about this. Right. In Observability 2.0, what are the key ingredients behind them? It is a unified data model, meaning that walks, traces, and metrics now share a common data format. Of course, the real or the actual implementation of this is OpenTelemetry, but OpenTelemetry, it's not only the implementation or SDK, it also defined a set of standards, and that is crucial for actually getting into this space. The other more interesting part, not only to the unified data model between the different components, is the shared semantics of the fields. So when I look at data, and when I look at the contextual information where this data comes from, if I want to easily correlate them, then I look into fields like Kubernetes namespace name, Kubernetes pod name, container name, and so on and so on. The trouble is that usually these fields, or how we name them, have different formats, different representation, different structure. And with OpenTelemetry and Observability 2.0, we actually come to a shared semantic model where these things are having a standardized format. The context propagation, especially in the multi-service type of architecture, becomes really important. And actually it has been, to be honest, the way that we track invocation between systems is not revolutionarily new. It has been in the industry at least for 20 years, as far as I remember, because back then we have these dual stack systems running next to each other. And 20 years ago, we were able to track conversation or calls between those two systems using a very similar approach, but back at time we called these passports. Maybe not that convenient name, but it was about the context propagation. Many people, when you go and see or check talks or papers about observability, you also will get into the auto-instrumentation space. Although it's very important, to me, it will give you probably the 80% of the path that you need to fulfill to get there, but will fail you in the last 20%. So not everything is auto-instrumentation. And I'll give you now an example. So this was the services that I show you. So we have a front end and a back end. I invoked 3 URIs from the front end. Some of them went to the back end, but everything in this architecture, simple architecture, emits all types of signals. There was direct metrics propagation. There was traces which are getting collected from these services, and there are also traces, metrics and walks. For UI part, it has different ways to interact with data, but I'll show you what are the key ingredients that you need to take into account when you design the next observability system and why. Okay, so let's get here. As we said, now everything's back to normal, but of course, if it was in the problem state, so if I go into last 15 minutes, then we observe these spikes. And if this happens at 3 a.m. in the morning, it will be quite interesting how this can be actually point to the actual problem of the system. What we can see, or what we can organize data in a different way, and hence observability 2.0, is if we have something like this. So this is, again, the same view of the same services, but slightly different representation of the data. And here, for example, I see this 500 status code that I return, so the error message. And would it be nice to actually get and see not only why this happened, but who participated in this? So this is a tracing part, this is a trace ID. And if I execute this query, then I see, of course, who and how was participating in this part. So that's a very easy way to go from metrics or how I'm doing type of questions into the space of who gets involved in this problem. Or let's have a different view. Let's get back to the dashboard. And this is the status code, the error service. But this latency that I introduced was also interesting. Here we don't generate a message or error message, but we generated a delay. And then the same question is extremely relevant. So how this can actually see of what and who gets involved. And here you see the traces which are generated and all the parts that were participating into that. But actually, what I really like is if, for example, I go into the Works UI and just these are the most meaningful work messages you ever seen. Unfortunately, those are quite common into the typical works. But, for example, I can go and trace or QRI, and then I can go you need to increase. Or maybe I can have a different entry point to this one. So if, for instance, I get here into this delay method, yeah, and then I query this way, and then I get the traces of it, and then I go to my logging system and just ask about it. And then, what is nice about it, that it goes and actually shows all the parties which are running into this conversation. So it not only gives you the entry point, but also can propagate context between the different participating parties. Our path in this domain has just begun, although we have the tooling around it, so we have the means to correlate the data between the logs, metrics, and traces. We still, on the tooling side or the UI part, we have a long way to go. Right now, most of the community there, or at least the commercial vendors, they try to integrate everything into place, but they still see quite a gap between how we quickly switching between one context to another context, or one type of questions to other type of questions. And when I see, for example, the auto-instrumentation part or the code generation part, let me open this one. Then I see a lot of space that we need to actually go and put additional effort in. For example, here we have just a very, maybe this is a nice, a better example. So how many times have you seen a log generation message which extract the context from the request that it comes into the system? It's rarely seen this. I mean, in most of the cases, whenever something enters a component, if something goes wrong, we walk the error message, but we forget about anything else. So we are not usually checking for the context. We're not usually extracting the identifiers that would allow us to link that particular log to a certain metrics or certain trace. And on the tooling side, I don't see a need to have a common backend layer for managing all these type of questions. To me, it's perfectly fine that we have one backend for logs, one backend for metrics, and one backend for traces, simply because they are different type of structured data, which probably can benefit from a highly optimized backend storage. But what is important is how I query this data and how I aggregate this data. And today there is no that many tools which allows me to connect different vendors or different backends from different vendors in a way that would allow me to simply ask the three basic questions: how I'm doing, what happened, and who is involved. And to me, this is like the next step of what needs to be done. Of course, AI, I forgot about it. Sorry. But it's not that far away or not that stretch from reality. Again, those questions that we want to put on observability domain are pretty much relevant, or how quickly we can actually use like an MCP servers and bring those agents into the game, which allow us to get deeper insights on the same question that we ask in the observability. Some say that this will be observability 3.0. To me, we are not there yet, simply because LLMs and AI, they fundamentally doesn't change neither the protocol, neither the data format. They probably only change the deep insight, if any, that we can get from asking these questions. Right now, there is a lot of effort, at least in the Kubernetes space, to get traces on board. I would say that we are still not yet there. The most of the traces I have seen that which are coming from the Kubernetes API servers, going down into the kubelets, going down into the containerd, they are more or less auto-instrumented, which they show the path, but the path I already know. And the really interesting questions or information usually comes from the fact that I need to go and put some, through the development, to put some additional error message into the code that emits these walks or generates these walks, which gives the actual value of what is happening. Like this example here. So I need to extract, or if I go into the status example, this is a lovely error message, but it doesn't tell you what. So auto-instrumentation is coming into the game. It will help us to generate traces into standard format, which come from OpenTelemetry. If you haven't played around with OpenTelemetry, I encourage you to do so. At Gardener, as an open source project, we definitely put observability 2.0 as a strategy for us. And if you're interested in what exactly we are going to implement and how, you can always go to the site. There are a bunch of papers there, and also documents which are describing the exact path how we are going to do and what we plan to do. And I think it can be served as an inspiration for many future implementations. As I said, observability is an important topic. It exists from day zero, so from the moment day one. So if day zero is setting up the cluster, the day one is setting up the observability stack. We are closer to having everything aligned using OpenTelemetry and open standards, which, by the way, just a side remark, frees you from the vendor walk-in of the backends. If everything speeds OTOP, everything provides an auto ingestion endpoint, then you are free to choose whatever backend suits your needs, architecture, and whatnot. Which was not the case like 5 years ago or so. And as a final words, we still have about 2 minutes. Please do pay attention to observability. Don't fall into the trap that, or promise, so to say, that auto-instrumentation will give you everything. It will not. If you don't spend enough time to think about how you organize and how you emit your observability signals, the more you invest there, the less it will take you later on when you investigate some type of issues, especially in 3 in the morning. And that's it. Any questions? If not, you can catch me around and we can talk about it. Observability always available.
Thank you. So I guess that was certainly much more advanced than version 0, which was essentially tailing logs left and right. Our next speaker will be talking to us about when it makes sense to run agentic workloads in Kubernetes. She is actually coming from quite far away. She's coming from all the way from California, which is a huge commitment to this event. So join me in thanking her for doing that. Please welcome Christina Donoff on stage.
Nope. Sorry, just one sec. Okay. There we go. Hello, everyone. My name is Christina Andonoff. I am a senior specialist solutions architect at AWS, where I guide our customers on how to use Kubernetes at scale. I'd say I'm very passionate about Kubernetes, and I have a side passion, a side hobby, I would call it, about reading psychology books. So, because this is the Agentic AI on Kubernetes session, we'll be talking about Kubernetes with a side of therapy. Because in this AI world, I think we can all use a little bit of therapy. So, can we all agree that we are living in the AI technology revolution right now? Okay. I'm glad we can all agree on that. And for those of us old enough, we've lived through many other technology revolutions that have changed our world forever as we know it. For example, when I was growing up, there was no internet, phones were not smart, and clouds were certainly not made out of Linux servers. And yet, today, all of these technologies are the norm, to the point where there is not a single organization today that doesn't have a website, a smartphone app, and some cloud presence. And as we all agreed, we are in the AI technology revolution right now. But this one feels so much different, doesn't it? Why is that? Well, for one thing, it is because everything is happening so fast. And we've really been feeling that fast pace of innovation since 2023. We're just right here. And there's so much that has happened. And if we were to zoom in, there is not actually only one revolution happening in here. There's so many sub-revolutions. We started with foundational models, and then there was inference, and RAG, and agentic AI, and I don't know what next week is going to be about. The human brain is just not designed to ingest this much change for this short period of time. So if what you're feeling right now is anxiety, well, congratulations, you're a human. And all of us are right there with you. But it's not only anxiety, isn't it? It's also excitement, because this revolution has a potential to automate so many unpleasant, mundane tasks, like validating your taxes were done correctly, self-driving, even self-flying is now a thing. Also, we'll be able to simulate the world around us like we've never been able to do before, so that we can better predict the climate change, we can read the human genome. And I don't know this for a fact, but I know that one day when we have a cure for cancer, AI will have a lot to do with it. So today, if you're a business in this whirlwind of change, you might be sitting on the sideline and trying to figure out, well, when is the best time to start building this AI into my business? When is the right time to start? Because when there's so much happening, you were probably waiting for this to slow down in order to build a plan, because how do you build a plan against a moving target? So the question becomes, again, when is the right time to start? So I'll tell you when the right time to start is. The right time to start was yesterday. Because while you're waiting and evaluating, your competitors are already up in the race. And that's important, and actually that's not that important. The important part is who finishes that finish line first, or who would be the first few to finish the finishing line. Because whoever finishes that line first will be able to create competitive advantage so fast and so wide that at this moment in time, the bigger risk is not, the bigger risk is not being wrong. It's being, the bigger risk is being left behind and becoming outdated. So here's what I'm gonna do. I just covered the why you should start building your agentic AI applications. So now I'm gonna tell you exactly what they are and how to put them in production on Kubernetes so that you have enough information to build this plan. Because when you have a plan of action, you remove the unknowns, and naturally, that reduces your anxiety. So what are AI agents? We have a really nice definition here, but I have a different definition. Agentic AI, AI agents are the new business applications with a slight difference. They can reason, unlike traditional programs. And because they're just applications, like any other application, well, you can install them as any other modern application. In AWS, we have many compute offerings where you can install modern applications, from the new Agent Core runtime to serverless AWS Lambda to ECS and our managed offering for Kubernetes. And since we're at KCD, we're going to be talking about how to deploy these agents on Kubernetes. But first, why should you deploy them to Kubernetes? We see customers who have already built their platforms. They're just extending their platforms to deploy both AI agents and models for inference for those agents on Kubernetes. We also see customers that are starting from scratch or are moving to Kubernetes for all of the reasons that we know Kubernetes is amazing. It runs anywhere. You can scale it to infinity, probably. I wouldn't call infinity, but we just had 100,000 cluster node for Anthropic announced last month, I think. And if you configure it properly, you can probably get the best cost performance out of it. So when you start, the first thing when you're building an agent to start with is an agentic framework. And actually, that's not 100% correct. You can build an agent without an agentic framework. You can build everything in code without the framework. What frameworks does, it abstracts some of the things from you. It's a library you import, and it gives you some goodies out of the box. There is a lot of open source frameworks out there. Strands is an open source framework that came from AWS for building agents. LangGraph is one that if you use like graphs and logic, like graphs is a good one. CrewAI is famous for its multi-agent orchestration. Llama Index, Pipecat is famous for audio, and so on and so forth. These are by no means all of them. So when you're looking at this and you're trying to figure out which framework should I start with, you are going to probably have evaluation criteria. You're going to pick the top 2, 3, 4, evaluate them, and figure out what you're looking here is pretty much how many lines of code can I cut, or what is the minimum amount of lines of code I can use with this framework. So one thing I also would like to mention is prior to the world, like prior to a year ago, whenever you picked a library to put in your code, you had to make a very tough decision, because for those of you who have instrumented their applications with a monitoring library, you become vendor locked. And when you're looking at these frameworks, you might be having a déjà vu. Like, if I pick one of these, is that's it, I'm set, and once I build my applications with it, then I'll never ever change it. Well, keep in mind that we live in a Gen AI world, and Gen AI will help you re-instrument your applications, and also will help you change that framework in case another one picks up. So just the moral of the story here is pick one and start with it and move on, because you want to move fast. So in this example and talk, I'll be using the Strands framework that, again, we open sourced this year in May. Actually, AWS has been using this internally since 2023, so it's it has robust capabilities. Even though it's relatively new, it can do a lot just because we have been developing it internally before we open sourced it. So if we were to deploy a multi-agent application like this one, how would we get started? Usually, you probably start with just one agent. So if we were to pick a weather agent for this weather agent, the first thing we have to do is give this weather agent a large language model that it can use in order to reason. And because you're testing, you want to be able to test multiple models and how they reason. So you might run them on Kubernetes, or you might use OpenAI or Bedrock or somewhere where that model is managed, so you can test its reasoning capabilities. You also can build a chat interface for that application. And you'll probably pick, again, 2 or 3 of the most famous models that can reason and provide that to your agent. So this is what the actual code looks like. And as I mentioned, agents are the new business applications, with the only difference that they can solve problems where reasoning is required. This here is a Python application. This is almost like every other Python code that just calls a model of your choosing. So as such, you can just take it and put it in a Docker container, push it to a container registry, and deploy it to Kubernetes. You can reuse all your pipelines. So at this time, how this agent is, you can ask it, what is the weather in San Francisco? And it's going to go talk to the LLM, and it's going to come and answer to you. And probably the answer it's going to give you is, well, the weather in San Francisco is like this in January, like this in February, yada, yada, yada. It doesn't know what the current weather is, because that LLM that it's talking to was probably trained with data that is 6 months old. So it can give you a general feeling of what the weather is, but it cannot give you the weather forecast if you're asking it for the weather right now. In order for it to give you real-time information, it has to talk to a real-world API, in this case, a weather API. And how agents talk to APIs and databases and all other things is via tools. So what is a tool? Well, tool is just part of any agentic library. There's a tools library. And what it does, in your code, you can just put add tool on the right hand here. I have the 2 lines of code you need in order to turn this into a tool. So then the agent knows whether to call a tool. The agent uses the LLM to make a decision if you're asking for the weather right now versus if you're asking for the weather generally in the winter at that location. And then it makes a decision whether it should talk to the API, calls the API, and returns the weather for you. So now that's great if we have one agent needing to talk to one API, but what if multiple agents want to talk to that same API or that same database? Well, in that case, you want to just take that tool and wrap it in an MCP server. And the code to do that, in the agent, you have to put the code for an MCP client, and then in the MCP server, you can just import the MCP tool library and serve it as an MCP server with only a few lines of code. So what creating an MCP server does, it does if you have more than one agent that need to talk to that external API, and you need to authenticate to that API, and you need, you can create an MCP server, you can give the MCP server the keys and the permissions to that API or to that database, and then many agents can use that same MCP server. Of course, for your applications, you can use, you should add a few other things, such as authentication, such as session state, so that the weather agent, if you add authentication and you're Alice, the weather agent will know that it's talking to Alice. And then if you save the session state, it will know what happened during that session. And then the other thing you might need is agent memory, so it remembers your conversation. And of course, you can build upon that how you would build almost any application. And how we started is like when you need to add other agents and they need to talk to each other, usually you would use another protocol called the agent-to-agent protocol. That is an open source protocol that came from Google. And that is how you would build multi-agent systems to test them. Once you are finished testing, to put them in production, you need observability. Please don't put your agents in productions without monitoring. So when it comes to agentic observability, the 3 pillars of observability still apply, which are logs, metrics, and traces. The only difference here is that you would use different metrics, like a few additional metrics that you'll show on the exact same dashboards, and that logs and metrics feed into traces, and you get a little bit more out of your traces. There are 2 frameworks, open source frameworks, that have emerged for agentic monitoring. One is Ragus and one is Langfuse. Langfuse provides you the metrics and the structured traces you need to monitor all the behaviors of the agent, meaning like how fast does it take you, like how fast does it respond, and things like that. Whereas Ragus gives you the evaluation of the agent, meaning how relevant is the answer, what's the quality of the answer, what is the clarity, and it can also do benchmarks for RAG. So again, those two are just two libraries. You import them, you instrument your agents, and you deploy. Nothing crazy here. And LangFuse comes with a nice dashboard where you can view your agentic traces. And with all that, the point was that these agents are not that scary. They're just another application. And you can install it like any other container. You can install the UI, the agent, the MCP server as containers in Kubernetes. And you can connect them to all the services that you're already using to monitor, for memory and context, to serve, load balancing, etc. I wanted to talk a little bit about, like we called the bedrock model here. And there is, as I opened, I said, like, you should consider using Kubernetes as your platform for everything. So there is a point in time when you're testing, you can use Bedrock or OpenAI. We have found that at certain scale, it does make sense to move the model into Kubernetes as well and run a GPU. And that point is usually either a price point or a performance point. When you need, when you get to scale and you need certain tokens per second becomes cheaper in a GPU over a managed offering, or when you need that model to be right next to that agent for latency, sub-millisecond latency. So again, at that point, you will compare both. You have your evaluation criteria. This, by no means, is all the evaluations that we should be looking at. These are just some examples. And with that, when you build your agents, when you put them in production, we also have the marketplace of if you want to publish your agents and you want to sell them to other companies. That is an option right now in the AWS marketplace. We announced that earlier this year. And so just to wrap it up, Kubernetes can be your platform where you not only run your business application, but you reuse everything that you have built to this point to just extend it, to run your agents, to run your inference endpoints, because it does provide you the flexibility, the scalability, and the performance you need so that your organization can be one of the first that along your website, your phone applications, your cloud presence can finish the crossing line and start putting your first agents in production. If you want to get started with building agentic AI on Kubernetes and you'd like hands-on guided experience, we have agentic AI workshops. We run them once a month, one in each time zone, so there should be a time zone that suits you. Sign up, they are completely free. Also, we have a code sample that you can go through and explore the weather agent that I just showed you. And with that, I want to thank you so much. And open it up for questions. All right, well, we're all set. There's no questions. That means everybody knows how to build agents. Oh, okay. Right behind you.
Yes, could you tell us a little bit for some use cases already around business, using already agents, some probably examples in the business world of what you've demonstrated?
The question was examples of real-world use cases for running agents in production.
Yes.
Yes. So the first two use cases are that we see most often. The first use case that we see most often is actually automating or developer helpers. So those are kind of your clients or your cursor and your those plugins that build in your IDE. I don't know if you've tried QCLI, but QCLI right now has agentic behavior that it will make a decision, it can do PRs on your behalf, and so on and so forth. Another use case is audio and making your call centers better. So that is certainly a use case. And then the third one I could think of is generating recommendations, for example, based on, if you go on Amazon.com, we have recommendations that are AI generated. It's not per se agentic, but it has a potential to be agentic.
Thank you.
Thank you.
So we just have one more talk before the break. I'm actually surprised that with this packed agenda, you've all made it so far. And then we're going to follow with, after the break, we're going to follow with another talk and some awesome lightning talks that we have actually curated for you that are going to be short in nature. And then we get to go to the cocktail. Our next speaker is going to tell you about how some of the hardest problems in logistics are being solved in a modern way. So please welcome on stage Pale Simpson.
Good afternoon. So I have the pleasure of being the one stopping you from the next pause. So let's see if it connects. Of course it doesn't. Okay. So, yeah, this actually starts pretty well by just finding the right window among the displays. So while we do that, I can tell you a little bit about our company. It was incorporated in Sofia in 21, and currently we have offices in Sofia, in Rwanda, and in the Delta State, Nigeria. So let me see if I can get this up. Yes, sir. And then we just need to figure out how to do this. Good. Yes, so This is a little bit about our company, what we are doing, and the projects that we have done. And the talk, if we just go back to the title now that everything is upside down, is basically from pods to neurons, and it's also about how you can use Cloud Native as a strategic platform for real-time AI agents. It's also how you can do enterprise AI at scale. So we're actually going to see some real agent use cases. We're going to see a different way of using Kubernetes than we have seen previously. So without further ado, let's go into it. In a way, creating an AI agent is not actually that hard. As the speaker from Amazon was telling you, AI agents is basically just business logic, but it's non-deterministic business logic. Normally when we create business logic, it's deterministic. We code in Java, in Python, or whatever. We code if then else, and it's actually deterministic logic. It does the same every time. It's all wrong every time, all right every time. It does the same. When you do AI agents, it's business logic with reasoning, and it's business logic that is non-deterministic. That means that for the same input, we don't always get the same output. It might be slightly the same, but it's not always exactly the same. So it's a bit different. But actually just creating the AI agent is not the difficult thing. The difficult thing in our experience is when you have to manage thousands of them at scale, when you have to deploy in areas where there's no search and rescue, when you can't use normal observability, normal metrics, because if you are too chatty with your metrics, you might get discovered, and getting discovered is not always a good thing. So that's the kind of world that we also live in, besides logistics. So the way that we normally try to solve those problems when we are met with something new is to make it more complex. We invent a lot of frameworks, and we reinvent the wheel over and over again. Let's have some service mesh. Let's have some complex orchestrations. Let's have some massive stream processors like Flink, for instance, in the middle of everything, and get some cloud builds on top of it. And actually, we should try to make it simpler, not make it more complex, not make it harder. Years ago, when my hair was different, there was one that made a very good mathematical proof. You know, you have in computer science, you want to optimize things, you want to make them better and faster, use less memory, use less CPU cycles, and so on. He created a proof that no matter how bad an algorithm you have made, you can make one that can do the same, but is worse. You can always make it worse. And we know that from our own experience. It's not always going exactly like we hoped it would. So what we are trying to do is actually to make it simpler and saying we already have some extremely good tools. We have Kubernetes that has been developed over years, and a lot of people in here have been bleeding with Kubernetes and swearing at 3 a.m. in the morning with Kubernetes, but it's quite stable now. So if you use it within its comfort zone, it's an extremely stable platform that you can lean upon. The same with the Postgres SQL, PG SQL. You have the normal RDBMS, but you also have PG Vector. You also have PostGIS. You also have JSONB. So you already have a very good tool. And the last tool we selected to use here is Kafka. Kafka can be a beast, actually. It can fight Kubernetes, so you don't know what's up and down. But when you get it to work, it's really, really good. It can handle up to billions of events per second at scale. And handle is not just put them in the right table. That means analyzing, reacting. to up to billions of events at scale. So it's a very good platform for stuff like this. So that's basically what we chose as the platform, saying, okay, agents. What are agents? Agents are small services, basically. They react on inputs and they produce output. So the simple agent has one Kafka topic going in, another Kafka topic going out. And more complex agents are taking an input from several Kafka topics, maybe producing on one other Kafka topic. And some, if it gets really complex, produce to more than one Kafka topic. But to handle all of that complexity, let's try to keep the base simple, otherwise we have to fight on all fronts. And we don't have the time and we don't have the people to do that. So basically, as I said, we see the agent basically as a pod. We have a prediction agent, we have a lot of anomaly agents when we deploy with port anomaly here, flight anomaly, weather anomaly, and so on. There is a code agent you can see in there. There is a hill filter agent. So we actually filter input from human in the loop, and we actually are managing it, measuring it for gaming attempts. So Bobby tables, you all know Bobby tables, so that of course is a code. But also if you try to do prompt injection, stuff like that. So again, by keeping the agents simple, by keeping the agents doing just one task, it's actually not that difficult to create an AI agent. If you just forget about saying, I need some A2A, I need some MCP, which framework should I use, and what have we, then in reality, if you boil it down, it's just non-deterministic business logic that has to take decisions. And the more you narrow down those decisions, the easier it becomes. For instance, in logistics, we have anomaly agents that just look at port anomalies and nothing else. They look at all of the port alerts and say, okay, now we have so many alerts from Mombasa or Djibouti, or there is a port strike, for instance. Right, let's raise this as an anomaly. So that's what they do. So let's move on. The way we start up these things is basically by creating agents, actually. So we're not coding agents, we are creating the first version of an agent using a rather large LLM to do it, but anyway, we create agents, so we have a starting point. So an agent typically reads from a Kafka topic, produces to a Kafka topic. There is an A2A capability card, which we store in Postgres SQL. And then we also create a testing agent for it, so we can produce test inputs and so on. So I have prepared, first of all, these two boring examples of monitoring a transmission system, substation, and so on, for a fat edge and for an IoT. But it became this instead. I don't know if you can see what, it's in real time. And sorry for the bad coding. But anyway, you can see what it's creating is an IoT agent on your left for monitoring a rakia distillery. And on your right, there is the hub agent for collecting all of the IoT signals for a rakia distillery. It's actually quite important because if the pressure is too high, even if the temperature is low, this still can explode. And also, if you get too much copper into the rakia, it doesn't taste well. So it's actually a very important thing that the agent on the left is doing. So, so this is how fast it takes to generate the agents. Let's just see them in motion. Again, real life, real time, sorry. So you can see that the agent on the left, which is rule-based, is doing some measurements, and then the anomaly agent is raising some of it, escalating some of it for anomalies, and some of it is not escalated for anomaly. So how does an agent look? Now it becomes dicey, because I don't have those things up here. I should never have used this one. I should just have used PowerPoint. Anyway, see if I can do this. I can't. Okay, I'll show you. I'll leave some space at the end, and then I will kill the presentation. Then we can just see how the agents look. Okay. So let's go on here. This is the event. So this is an event in JSON for a rack distillery. So you can see there is a lot of boilerplate, and then there is some domain-specific data in the middle. So this is just one of the events that is produced from the IoT agent that the hub agent, the pod, is reacting to. And it's all for a good purpose. We don't like rack distilleries exploding, and we like our rakia to not taste of copper. So, yes. We have another way of doing observability on agents. So we actually have an agent, which is just another pod that is monitoring all of the agents. And they are monitored for drift. So when the certainty starts to drift, when there's too much human in the loop intervention, then the agent is actually singled out for retraining, so to speak. So it monitors, it runs every 4 hours, then it monitors all of the decisions from the last 4 hours from all of the agents. And if there is a sign of drift, then it's actually singled out. So that's what we call the immune system. And it does all of the things on this slide, basically. It's right from the code. And it's very important to have some kind of observability in a system like this. But we don't just end at observability. It actually feeds back. So it can feed back so we can generate the agent based on input from the observability agent, so to speak. So there is an example at the end of this where I can show how it looks. So it actually suggests a new context engineering in that example. So that's a way of keeping all of this running, keeping it automated. Let the AI manage the AI, so to speak. And yes, we are currently in a partnership with another company here in Bulgaria that does soil monitoring from satellites. They have their AI, another way of doing AI. And the 2 African companies where we are deploying this are going to deploy this to 25,000 farmers. And this is where it gets to be thousands of agents out there. And this is also where we are going to deploy it in places where you cannot always send a service technician. So 40% of the area where it's being deployed is in contested areas. So you don't just fly out if there is something messing with a wire or something. Good. So for us, the future of AI is not about necessarily making it more complex. It's not necessarily about what you call using more and more LLM power. It's about building a better nervous system. It's about taking all of these small special purpose agents, string them together, let them work together, using the tools at hand. Kubernetes is marvelous. It's fantastic. It restarts any failed pods, as you know. It can auto-scale, and it can actually work together with the way that Kafka scale as well, so they don't fight each other too much. PostgreSQL with its clustering is a very, very stable platform for persistence. So building all of this on a stable platform, so you don't have to fight all the way up, but say, okay, we keep some of it boring, we keep some of it simple, then we can use our power where it matters, where there's business value. So there's no business value in building Helm charts, I'm sorry to say, but there's business value in the market, in getting agents out there, get them to produce value where it matters. Yeah, and this is just the dashboard. There is, of course, a dashboard. So you can see the various Archaea things. There is a fermentation anomaly, distillation process deviation, and so on. So I created some breweries, some wine cellars, and some Archaea distilleries. So they're all live. Good. So, before we go to that, this is actually how it looks when the agent of agents singles out an agent. So, yeah, you can see some adjacent, but the thing is that the agent is not performing as it should. So the certainty of the decisions are getting worse and worse. There's more and more human-in-the-loop intervention that's picked up by the monitoring agent. And in this case, it actually suggests a new context engineering, a config map for the agent. And we can actually take this out and basically replace what's in the agent with this one, and it will perform better. So good. Let me see if I can kill the presentation so we somehow can get something up and running on this screen. Yes. Good. Yeah, sorry, I have to see if it's there. Anyway, so this is how an agent, the Rocha distillery agent looks. So this is actually what we call a neuron config. You can see it's just some YAML that defines which Kafka topics goes in and out, the config map it reads from, and so on. In this case, it just uses a Claude 5 model. And there's a temperature, how many tokens to use, and stuff like that. The other kind of agent that was generated is this one. So you can see this is a rule-based language that we call DCL or declare. So this is basically the other agent that was generated. So you can see in that case we have distilled knowledge basically from the LLM down to deterministic rules. So it looks quite simple when it just flew over the screen, but there's actually a lot of things going on in order to do this. So, good. We have some time left, so any questions? Otherwise, then we have a pause.
Thank you. Thank you. Well, thanks for this great talk. So how are the energy levels? It's already past, what time is it? Well, it's almost 5, so there's going to be a 30-minute break, and for the survivors, there's going to be actually one last talk after that, which, to tell the truth, is my favorite topic. So please stay tuned for the talk that's coming after the break. And now, feel free to go and recharge with some caffeine and whatever else is out there. See you in 30 minutes. And we are going to actually see our last full format talk for the day. And, it's always great to leave the dessert for later. Actually, this is probably the talk that was the most interesting to me in terms of title. And maybe that's why I left it for the end. So let's welcome Nir Adler, who is going to talk about the hidden signals in your Kubernetes clusters and what they actually tell you.
Can you hear me? Yeah. So hey everyone, I'm Nir. I'm part of the CTO team at Commodore. We are building an observability platform for Kubernetes clusters, so it's very connected to my talk. And my main role is to push AI and to provide the meaningful signals that we have, because we have lots of signals. And after the observability talk that you already have, I hope you listen, and I hope you don't tired anymore. So basically, I'm going to continue from the part he stopped, right? How we going forward from point 2 to point 3, how to use AI, and how to use all the tools that we gather until now. We have lots of observability tools that we gather, how to use them the most efficient way to find those signals that are hidden or more sneaky to find. So just about me, like I said, I'm part of the CTO team, pushing the innovation in the company. And last time I've been here, I was visiting Bansko for ski. And I love League of Legends, and my social media is basically GitHub. I really like to push code and open source. Hit me if you are interested. So what we're going to cover, what are those signals? Why do we care about them? What are the costs to missing those signals, right? Like, why do we care? What's happened if we miss them? And OK, so signals. Kubernetes have lots of signals that it produces. Kubernetes is event-based, so every time we schedule the pod or we have any action in the pod, we have an event, right? Our application, logs, metrics, all of those are signals, but not all of these signals are interesting for us. We have lots of noise around. We have logs, metrics that we are collecting all the time, but we really want to see the one that connected to the issue or something that we are now investigating. So we need to find those issues. Like you can see in the middle of all of this chaos, we have a specific signals that are interesting for us, and how can we find those? So the cost, right? Because we need motivation. Why do we really need to put effort on finding those signals? So I'm giving you 2 case studies that really had big impact, and it's quite new. So this one is about OpenAI. It was major thing because ChatGPT, everyone is using it, right? And let's imagine what happens if tomorrow you don't have ChatGPT anymore. So one of those examples is ChatGPT issue that they had. they had an internal telemetry service that was overflowing the Kube API and caused downtime, right? They lose money, they lose their reputation, really bad stuff. Another use case, I think both of those use cases are very, very interesting and something that you can take and learn on how you can monitor your infrastructure better to avoid those issues and find them early. So in this case, by the way, Calico, we have a booth here outside. I hope you talked with them. So Calico is really in the center of the cluster, right? Without, if you have any issue in your networking layer, all your application can be not available. Okay, so it's something that you need to monitor very well, to understand very well what is the meaning. For example, they upgrade the cluster, so every changing in your configuration, you need to understand what is the effect on the rest of the application. Okay, so I hope everyone knows what this is. This is K9S. Every time you have an issue in your cluster, your first place that you are going to go, open a terminal, K9S, and just see what is the current status. You can see sometimes that the service is down. And that's, I think, a good part, because if you have issue and you don't see any signal right now, it's much harder, right? So Kubernetes, like we said, it gives you the basic current state. Does my deployment have replicas? Does it run? That's the simple signals, and it's easy to gather, right? Like I just showed you, you can go to K9S, see what is the current status, and based on that, you can start your troubleshooting. But if you want to find the most critical one and the most sneaky one to find, the one that's hidden, but we really want to see them to solve an issue or even to prevent issue that is going to come. So to find those, you need to do much more advanced analytics, right? You need to find events that connect to other events that affect other one. So how do you connect those dots to the reliability insight, to the one that really solve the issue, even if it's hidden in like my deployment is running, you have a replica, but we still have something that we don't see, like something in our autoscaler or something else that it's not in plain sight, but if we will see it, we can prevent issues that is going to come. So to gather all of these events, we need a very good infrastructure for our analytics. We probably who uses like Grafana, Datadog, all of those stacks, right? Who try to do it yourself and who's paying to product like just like Datadog? Who uses Datadog, right? Raise your hand. Datadog guys? Okay. So usually, if you use a SaaS platform that's already doing that for you, it will give you like the best practice for their platform, how to collect those events. Behind the scene, they need to handle lots of events. We have, like we said, lots of signals all around application, Kubernetes itself, metrics that we collect. All of these together need to be collected, and then we need a visualize tool to do a more deeper analytics, right? We need to correlate. We want to do time analysis. Time analysis is very crucial to connect the dots over time to see, okay, I have one restart right now, but if I can see restart happening much more closer to a specific time, we can get a much deeper understanding on the issue. Configuration, we just talked about the upgrade that broke Reddit. So connect all of these dots. It's not just our metrics and not just our logs. Signals can come all over. Okay, so like I said, I encourage you to use one of the SaaS platform or the tools that already established and know how to collect, handle those events, lots of events. It's very hard and costly to do it yourself, but we have to do it unless we want to lose those signals. And if we will have an issue, we will not have a way to understand what is the issue, what is the source, and how to solve it. So a little bit of examples on these insights that we can gather if we have the right tools. For example, we just talked about container restarts. Container restart itself is not saying the whole picture, right? We want to see it over time. We want to see what is the root cause, what is causing our application, what is the time they restart, what is the frequency of the restart. And then, for example, in this case, we can see there is out of memory, so it's very easy for us to see if we use the right tool, right? We use time series database that can show us specific metric over time, and to see exactly in which time the restart is going faster, and we can know, okay, this is probably the root cause. In this time, there is more request that's causing more memory usage, and then out of memory, so we need to scale. Okay, so this is very classic. Autoscaler is configured to a lower threshold from what we need. The threshold needs to be higher because we are using most of our threshold that we get from the configuration. And basically, seeing that way, right, if we use the right tool again, we can see exactly, okay, we need to raise the threshold because we're already using most of our application that we configured, and we need to change it and give it more resources. Okay, so totaling is very, again, a very big signals that we want to find. I think that's a very, very big sign that if we have a totaling issues, straight away going to your metric infrastructure, check the metrics, see it over time, correlate with other services, and connecting all of these dots together will give you the best insight, right? What is the issue, how to solve it, if I want to scale, for how much I need to scale it. So configuration, we just say, every time you're doing an upgrade, don't forget to understand what is the meaning. Make sure you have metrics on the right places that you can cover it, and be prepared every time you're doing an upgrade. It can cause any issues. So noisy neighbor is very common. Every time we have, especially in Kubernetes, right? Because on the same node, we have a couple of workloads. A specific workload can affect other workload. It's something that's happening all the time, but it's harder to find, okay? I'm going back to the hidden signals. If we want to find those hidden signals, you need to understand exactly how you're running your application, what exactly was the node that the pod is running inside it, and how it's affecting the other pods inside the same node. Again, this is only available for us if we're using a right tool, if we're collecting those events in the right way, if we know how to correlate those events together. This is like the basic thing for us even to start the investigation. So, for the interesting part, I guess, if you remember the observability talk, he finished with, okay, the next thing will be observability 3.0, right? AI will do it for us. AI can make it much shorter. I agree with him that we are not 100% there, but we are on the way. And I think if we will not use it, we will not be there never, okay? So we need to start using it. It is very good in some part, and in some part, it's less, but even we still use our current product, right? It's not replacing our products. We still need to use Datadog or Grafana. Everything is still there, but we're just adding another layer that making us life much better and easier to understand. So my example, that's what I'm doing in my daily job, okay? I'm doing a troubleshooting agent. Troubleshooting agent is an agent that connected to my infrastructure, and it can pull logs, it can pull metrics, it can see what is the current status, it can talk with the Kubernetes API, it can connect all of these dots. It can go to Datadog, it can go to the Kube API to see the application. It can go all over if you give it the right tools. And then it can correlate and giving you the meaningful insight for you, right? It's much easier to just dump everything into, okay, who's copying like infrastructure issue and pass it in open API chat? raise your hand, right? Open API chat, you don't? For sure. Okay, so if you have an agent, and in a second I will show you that everyone, most of us at least, have agent that you can use to do that for you if you give it the right tools. So for effective agent, we need to give it a good context. The good context is coming from tools, from like if you have a knowledge base, if you have like your own guide on how to do clustering or your internal AIC, how to do it the right way and how to solve issues. If you give it to the agent, it will know and we will have the right context on how to solve common issues that you already have and you documented. So a little bit demoing on how you can use your own agent. Like if you use Cursor, like me, okay, you already have agent, right? If you have Claude Code or any other coding agent, by the way, you already have agent. So why are you not using it? If you give it the right context or access to the cluster, write only, try it, and it can find and correlate those for you. Also, you can connect by MCP Datadog or any other metricing system and logs. And if you connect it to the agent, it will gather those metrics for you and already give you the insights and even how to solve it. Let me see if it will work. Okay. Okay. So that's the one that I already ran, and I will not let you wait. So that's so easy, just to say, okay, this is my issue, right? And I will say, okay, what is the problem? And while it will do stuff, I will show you what is already done. Okay, by the way, I really like those to-do. The to-do is, I'm going to the cluster, direct availability. Okay, I have the instruction that I give him. Okay, and based on those instructions, it will do a to-do list. I need to go to the cluster. I need to check what is the status. And in this example, is basically found the issue. It's a scenario that I created, which the secret is not correct, is causing the availability issue. The deployment is not going up. And basically, he already doing the investigation for me, and he will, yeah, and somewhere here, yeah, so he will already find the secret with the issue, and he will say, okay, you want to solve it, this is the root cause, this is how to solve it. So basically, he did all the investigation for me, and even suggest me how to solve it. I'm sorry, we don't have a lot of time, so I'm going very fast. So this is how it's looked at in Commodore, right? That this is my daily job, building AI SRE, basically agents that have access to my cluster and give me root cause analysis and even one-click solutions. And that's it. I want you to take this forward and like don't forget to use AI whenever you can, and at least start with that, and maybe it will make your investigation much faster. Thank you very much.
Hello again. We are nearing the end of our program today. And does anyone know what's happening right after the program? I think I've already said it. Anyone? Cocktail? Well, no, it's not the cocktail. We have to say goodbye. And only after that, the cocktail might be happening. Yeah, the cocktail is happening right after that. But before all of that, we actually have a set of pretty cool lightning talks that are 10-minute long each and are going to be delivered by a number of speakers that are going to introduce themselves. So first, I want to welcome our first lightning talk speaker for the day.
Do we have the mic now? Okay. Beamer warming up. Folks, hopefully you are not too exhausted. Okay, I'm going to talk about a topic which is near my heart, so you can be sure you will get energized in a minute. First, to energize the beamer, of course. Yeah! Okay, my name is Jordanov. I am leading the Gardener team in Sofia, and I'm from SAP Bulgaria, and I'm going to talk about EU digital sovereignty. Okay, before we start, let me bring you back in time. Do you remember when when Google decided to open source Kubernetes? It was 11 years ago. And it was a decision which was taken quite hard. So they were thinking about, aren't they revealing too much business critical know-how? What about the container source? Who might remember them? Was it already enterprise ready? A lot of questions, standard questions. Nevertheless, they worked with Linux Foundation to form Cloud Native Computing Foundation. So we have an event under that umbrella today, and offered Kubernetes as the container seed technology. All good, all basic things. Fast forward to present days, you all know container wars long gone. Kubernetes evolved into something much more foundational and far-reaching. What is key here? Competitors in the infrastructure domain, like Google, Microsoft, and Amazon, are practically collaborating in Kubernetes as a technology. Just think how cool and appealing is that. Technology unites. And what would you say is the moral of the story? Open source is most successful when it is played as a positive sum game. Just keep that in back of your mind. We'll refer to that later on. Okay, that's the dictionary of the abbreviations we are going to cover. Don't be shocked, you don't need to remember them. I have you covered. First, here you see the platform economy map, or the top 100 platforms according to their market capitalization and grouped by region. Some obvious things. US leads. Asia is showing good presence. Africa and Europe, a little bit of something. And it is what it is. So, by definition, sovereignty means freedom from external control. You cannot claim sovereignty if you lose technology or service or infrastructure relevance. And there are many reasons for that picture. Interestingly enough, market size is not one of them. But we know the other reasons. So, in Europe, we have quite huge difference in regulations, legal systems, natural language barrier, diverse political agenda, and what's not. And it's not all of it. So access to venture capital is also more difficult. You might have heard of Y Combinator. This is an American startup accelerator. And they launched more than 5,000 companies. What is the analog for Europe? We don't have actually such. And where is the Silicon Valley in Europe? We have, it feels like a network of Silicon villages. So, problem clear. What is European Union planning to do to address this? You know, there is a joke. While America innovates, Europe regulates. In every joke, there is a little bit of truth. And the first abbreviation, IPSI, stands for Important Projects of Common European Interest. What does it mean? This is a special framework which was designed by EU to allow member states to provide coordinated state aid for ambitious, large-scale, cross-border industrial projects. As you know, state aid is normally not allowed. With this program, it is allowed under special conditions. The projects must be of strategic importance for Europe in areas where market alone wouldn't invest at the needed speed or scale. Several constraints: no market distortion, no drastic changes in the price, co-financing, so you receive public funding and you participate with private capital. A very important constraint, the last one, spillover effect. So you cannot receive public funding and keep all the results of your innovation just for you. So you must allow reuse within European Union, not necessarily for free, but at least with fair licensing. Okay, so many programs under this umbrella, IPSI, of different areas. What is of importance for us? End of 2023, European Union approved the next generation cloud infrastructure and services. Initially, the budget was 1.2 billion euros, and the program rapidly evolved. Nowadays, we have 12 participating member states, and the budget is up to 3.5 billion euros. You now may ask me, how is SAP part of this? But we are not quite there yet. Now we have the European regulation, then we have to talk a little bit about the country or member states. And no surprise here, for us, this is Germany, with their initiative ORA, the next abbreviation. Let's keep things simple. ORA is just a trademark, or we can treat it as a trademark that will subsume all the results of the different IPSIS projects. It defines also a collaboration model, a steering, so that ideally all projects complement each other to a holistic solution. Okay, and the main objective of ORA is the multi-provider cloud edge continuum. We are talking already about infrastructure. When we think about cloud providers, we usually think about the biggest players like Google, Microsoft, Amazon, but the reality is that we have quite a good diversity of cloud providers also in Europe, which are also gaining some popularity in the last years. And it can be also provider on country level. In Bulgaria, we have this e-government portal, which is also some kind of proprietary infrastructure built by the government. And we can go on-premise, which is also getting popularity nowadays, and why not on-device? So when we talk about mobile phones, we usually treat mobile providers just as network providers, but that's not necessarily the case. It might be a bit more than that. So, as a software provider, normally you would like to be everywhere, but the reality is that that's not possible because they're all different. So, at the end, what happens is that software solutions are only provided again on the hyperscalers, which then again increase their market advantage. And this is where the multi-provider cloud edge continuum comes into play, targeting to implement a software stack that abstracts from these differences. Quite an ambitious goal, but let's see. And now, when we have the legal framework with IPSIS and Germany and ORA, we can talk about how SAP as a company is part of this. And this is SAP project Apeiro. Apeiro is an ancient Greek word that stands for unbounded or unlimited. And as the name indicates, we aim to develop a powerful open reference that can be flexibly adapted in the 4 major categories depicted on the left, starting from the infrastructure up to the platform. And we surely recognize that all European market players have walked in multi-million euros of investments, just like we in SAP have. So we cannot come up with something brand new and disruptive and expect that everybody will just migrate. Not realistic. So we built the reference architecture based on something that we all can agree on, cloud-native principles. Why? Because Linux and Kubernetes are the common denominator. They are just well adopted. Okay, so we can look at a payroll as a set of projects, or if you will, a fruit basket. So you can, every IPSA participant or everybody else can take one individual project and adopt it, or a set of projects for implementing end-to-end scenario. And we expect that in return, companies will contribute back some implementations of common interest so that we have this positive sum effect. And here comes the interesting part. So, starting building the stack, starting right from the bare metal. And here we have the Iron Core, which is a cloud-native infrastructure as a service, and bare metal automation. So we talk about managing compute, networking, storage resources, discovery, provisioning with Ignition, day-to operations, third-party integrations, KVM, safe storage, whatever. So it's all not, we are still using well-known open source products, and we have to fill in the gaps in a lot of places. And we have Cobalt Core, which is an opinionated OpenStack distribution that builds upon Iron Core foundation to support non-cloud native workloads. And I am already talking more than 10 minutes without mentioning AI. It's about time to fix that. But we have our own Garden Linux distribution with a huge focus on being clean, small, and security hardened. And why mentioning AI here? Because at this place we have to start thinking of it. So Garden Linux is Debian-based, forgot to mention, and we have already native support. Sorry, we have already native GPU support with the kind help of NVIDIA, and going up to the stack, the Kubernetes GPU operator is on the way. Then we have Gardener to abstract the infrastructure and to allow managing Kubernetes clusters in an infrastructure agnostic way. To be honest, we are doing that in SAP since many years, and we are managing huge landscapes. We are talking about tens of thousands of clusters. And actually, this is one of the products with biggest maturity, and still heavily investing in it. Going again, okay. And going up into the stack, we have platform mesh, data fabric, and confidence, which are part of the platform layer to abstract or allow cloud-native way of defining and using services to define the communication between the services and metadata. So, what is the value proposition of Gardener? Again, glimpse from the past. 30 years ago, Sun Microsystems coined the slogan "War, write once, run everywhere" to illustrate the cross-platform benefits of the Java programming language. Now we kind of repeat this, but in the cloud by writing once your cloud-native application, and with Gardener run it everywhere. Okay, I have to get in a hurry, a little bit of a demo. Now here you see a Payro showroom portal, which is built on micro front-end platform technology, one of the fruits in the fruit basket. You see here a lot of services, like legacy one, commercial ones, whatever. We have something called a Payro workspace, which is, as definition, is directly a vanilla Kubernetes control plane entity. As such, you can download the kubeconfig and start using tools like kubectl. We can list namespaces, see some stuff is already there. That's not a real cluster, however, we don't have pods. And for the purpose of this demo, let's try to create a simple HTTP bin service. It comes from the Acme ABC provider. This is an example that we are building out together with the upstream KCP project maintainers who we all hired for this project. And this is essentially the order document, which is just a YAML file, a very simple definition. And the idea is that everybody shall understand YAML files. This is the bare minimum required. In a matter of seconds, the service is up and running. We can extend the demo by creating virtual machines using an infrastructure, a consortium of 5 different Netherlands providers called EcoFed. And when you have this diversity of infrastructures below, you can allow yourself to apply certain strategies, like creating the VMs in the cheapest location at the moment, or the greenest location, where the wind is blowing, for example. This order interoperability between providers we call platform mesh. I mentioned KCP projects because using Kubernetes resource model framework beyond Kubernetes is not a proprietary thing for us. So this is already a CNCF project in sandbox maturity level at the moment. Okay. Some facts for the project. Started 2025 with multi-100 millions of euros of public funding. Will end 2027 plus one optional year, plus further prolongation is under discussion. As you saw, the scope is really huge, so a little bit of a challenge. And now, 2 words about the spillover requirements. So how we allow others to reuse everything that we achieve with the Payro? Well, we decided to be altruistic and to open source all projects. There is, however, a catch. Open source doesn't mean necessarily free to use. And even if they are free to use at the moment, licenses changes. We all see that, unfortunately. So the missing part, beginning of this year in KubeCon London, we announced NeoNephos Foundation under the Linux Foundation Europe. So it's kind of a sibling for CNCF. And we decided to donate all these projects coming from Payro in NeoNephos. Currently, 3 companies are in the governing board. This is SAP, T-System, and StakeIt. And I can say it, Gartner is no more SAP project. Gartner is now a NeoNephos project. And other companies are welcome to join if they follow the NeoNephos vision to make cloud native sovereign. Here is the already open source and donated projects, more than 10 with different maturity levels. Some of them, or most of them, are under heavy development. And we are solving common problems, providing standard solutions. At the end, we can play for this positive sum game in cloud native technology, from the bare metal up to the cloud platform layer. Thank you.
Okay, test, test. I swear, last time you see me, maybe I drive you home in the taxi. I'm not really sure about this one. But yeah, it's the last time you see me. And it's a lightning talk, so I try to be very quick. I calculated with a little bit less time, so I have a little bit more time, so a little bit more talking. So lightning talk, yeah, let me run through it. So abstraction. I want to talk about abstraction. So when I prepared everything, I was completely full of energy. I'm like, okay, I'm going to show you the best abstraction, making some nice bridges. And then I saw this tweet from Darren Shepard. If you know him on Twitter, he has an opinion. He's a person with a strong opinion, let me say like this. And he made an opinion about abstractions. So he says, curl and bash, that's all I need. And all the abstractions you folks are creating, trying to make life easier, it just makes everything harder. And I'm like, oh, okay, that's good. When a person like him complains about this, then my talk is doomed from the start. But yeah, let's try the best. Okay, let's continue with my storyline. So abstraction, I wanted to show existing abstractions, so coming to art. I'm not an arty person at all, so I just looked for some abstraction art. So this one is Yellow Mountain. Everybody see the mountain probably, me not. And then we have another abstraction here, this one, and it's a composition red, blue, and yellow from Pierre Modrin. And you see the clear things, putting everything into larger shapes, getting rid of the details, and so on and so on. Again, I'm not an art person. I think this is money laundering, but then again, I don't know about this one. So, title, abstracted, the higher the faster, the higher the abstraction, the better we go. That was my idea until Darren destroyed everything. So, yeah, you know me, I talked before. So abstraction in art, I just talked about this, getting away, distancing yourself from the real world and using shapes and forms and so on to express what you wanted to say. In this case, a yellow mountain, which was just some splashes of color. And how is it in tech? So this is something you may already know, because again, hey Engin, what you're talking abstraction. We have abstraction in software development. So data abstraction, interface abstraction, control, and so on. So we already use it in many, many cases, and we see also the benefits. So we can manage complexity, increase reusability, and sometimes also increase the maintainability if it's not too over-abstracted everything, and we have to debug through all the layers. And how does it look like? I have a Java background, so I grew up with this kind of stuff, having here the DAO, SAO, whatever layers in between, and then you can say user service, get all usernames, and you don't care how it works, you get a list back of the usernames. Okay, and because AI again, so I asked ChatGPT, make me a picture about software development by ChatGPT, and it comes up with this one. So quickly go over this. So what's hidden, the implementation details, algorithm, data structure, and we have real-world appearance. I mean, that's the comparison to the art abstraction, and what's exposed, interfaces, API, methods, and in art it would be shape, colors, form. That's and then our goal is to simplify complexity, enable reuse, and here on art was focus on core and emotional elements. Okay. And mechanism, function class modules, interfaces depending which language you're using, and then here with art abstraction you saw with the shapes, like using simpler shapes and so on. Okay, abstraction and platform engineering. Let's move away. So next step, abstraction software, abstraction and platform engineering. Again, the big question I want to collect all of you. What is platform engineering? This is platform engineering, or if you don't have platform engineering, you have to battle to get what you want, and it takes ages that stuff gets delivered. So this is when you ordering infrastructure in a company which don't have a platform engineering team. So platform engineering, behind it's the whole, it's a platform team which builds and maintains the internal developer platform or self-service infrastructure that people can consume, and you get everything free house, the best golden paths and so on built in. Okay, so again, the abstraction, what's going on here in infrastructure, we have the layer of infrastructure. What gets abstracted is our raw servers, Kubernetes and so on. We get high-level resources like cluster databases, and a team just requests here a Kubernetes cluster, no need to script some details out of it. Deployment, same. people really love the Heroku way to just say, hey, it's simple deploy, so the platform engineering team takes care of all the YAML, of all the scripts for the deployment process, but exposes here a simpler way. Runtime services with logging and so on, security and policy is the same. I have to rush a little bit more through, and scalability is the same. Just tell the system, please scale, and then the service does it. You don't need to think about the details. Okay, how is this abstraction delivered in platform engineering? Either through platform APIs or CLIs, Pulumi components, Terraform module, Helm charts, self-service portals where you just click on the button and does the thing. And GitOps, for example, is also a way to abstract and to deliver this way. Okay, so what are the benefits here? So developer productivity, the dev teams can focus on code and features, consistency, compliance, everything is here according to the standards in the company, reliability, cost efficiency. This is a big thing. People may not see what the costs are of the things they're creating. So here we can have everything in check through policies and so on. And most importantly, accelerated onboarding. When we change teams or get new hires, they can quickly board on, get the stuff done, order stuff through the portal, and so on and so on. Okay, so 100%, this person cares about this, that we have this benefits for abstraction and platform engineering, your CEO, and if this is not caring, then at least your manager will ask you about this. So yeah, you got now the points for the abstraction. So let's head to the last point, so abstraction in Kubernetes. So the Kubernetes API is a prime example for abstraction. We can hide all the details around container, networking, and so on with some high-level declarative interface. Let's have an example here, so let's jump over this one. Here, for example, we already know the Kubernetes API objects like pod deployment service, where things are defined, but the actual implementation, what goes underneath, is taken care from Kubernetes. So that's one thing, the inbuilt objects. And we have also another way, I don't want to spoil the next talk, but there is another one going for example. So another way of the Kubernetes abstractions to create your own CRDs. We are CRD-centric abstraction. And here we can create our own objects in Kubernetes, for example, database and canary release, independent what is actually using underneath. We have here consistent validation. We can run against the OpenAI schema. We have the lifecycle management in the system of the controller who listens to the CRD, can execute some stuff like an operator, for example, and it's extensible. Okay, what's an example for this one? Again, I don't want to spoil the next talk, so one thing I really like and use a lot is here the Kubernetes Resource Orchestrator, CRO. I will jump quickly over this because there is a talk after this I did not know about, but have a look, how does it look like? So you have a big thing, you know, written everything, but the user actually has just simply to use this created abstraction, and everything else which is inside in Kubernetes world is hidden here. Okay, check this out. So we talked about abstraction. We had 2 minutes left, so there's positive parts, but here are also some of the danger zone parts if we go too crazy with our abstractions. So if we go too crazy with our abstractions in Kubernetes, we come in a situation that we have some leaky abstractions. So we are not, the abstractions fail to fully hide. This happens when people say like, can you add this, can you add this, can you add this, and you keep on adding the stuff, but make it in a way that it exposes the actual system underneath, because after a certain point you're like, okay, it's not that easy to make everything configurable without people knowing what's going on in the abstraction. So here's something, mitigation strategies for this. Put in escape hatches, purposely escape hatches, do the testing, and most of all, educate the users what the abstraction you're providing is capable and what not, so people know about this, and then maybe get some feedback to create a new one which fits more the system. Another point which is called here the gold plating is over abstraction. If you create an abstraction which is too generic to handle everything, and you have to follow here the Yagni principle, you aren't going to need this. and only abstract what you really need, and incremental refactoring and regular reviews, 50 seconds. Last one is when your company abandoned the stuff, you know, you created an abstraction, everybody in the team, in the company uses it, and the core maintaining team is like, we have to go to another project and you are stuck with this, so that's also a dangerous thing. Okay, conclusion. 30 seconds, like, yeah, I know. So let's head over. So abstracting complexity, so that's something to use here, to use the Kubernetes API to hide implementation details, to create here an abstraction. Empower developers, so that's very good. And the last point is built-in safety and observability into your abstraction, so people don't have to care this, they just consume it and they get everything free house delivered. Okay, 2 seconds, Q&A, no Q&A, and that's it. I'm really gone now. So, thank you.
Test. All right. Hi, everyone. My name is Vukadinoff. As I mentioned earlier, I'm a Senior Specialist Solutions Architect at AWS, where I guide our customers on how to run Kubernetes at scale. And my other full-time job is being a mom of 2 amazing girls. And today I'll tell you a little bit about them. The older one likes dogs, and the little one likes cats. And at our dinner table, it is a constant debate. Which ones are better, dogs or cats? So I figured I'd take this opportunity to gather some data and to bring out to my girls so we have better discussions. And I know probably you're thinking right now, oh, she's going to make us raise hands. And before you start rolling your eyes, I want to assure you that is not what I was thinking. In fact, I was thinking, how about we get a proper application to do that, like this one. This application consists of 3 microservices and 2 databases, a cache database and a Postgres database. And if you were the developer of this application, and if you were to deploy the microservices to Kubernetes, and the databases as managed services, how long do you think it's going to take you? And while you think about that, let me state some facts. Kubernetes just turned 11 years old this year. That means we have been deploying applications like this to Kubernetes for the past 11 years. After a hello world, this here is one of the simplest sample applications there is. So can you tell me how it is that in a large organization, on average, a developer will take an entire working day to deploy this application? Let me repeat that. We have been deploying applications like this for the past 11 years. And it still takes developers a full working day to deploy this. Why is that? Well, let's break it down. If you have to deploy the microservices, probably the platform team provided a Helm chart and some tool that under the hood uses Helm install, and a developer can deploy this in roughly 2 minutes. How about the databases? How would a developer deploy a database and link it to the application? Well, probably they'll call some pipelines, Terraform, CloudFormation, whatever your choice might be. You'll probably call first the the networking pipeline. And you'll get some output, like the VPC ID, the subnet IDs. And you copy these and you pass them to the infra pipeline. that hopefully would give you not only the database, but the credentials to access that database. And you have to know what those are, and then take them and pass them to the Kubernetes pipeline. And if this happened to work the first time, do you know what the developer does at that time? Well, they sit around and they wait, and they watch that database for the next few hours. Because at some point in the next few hours, the compliance pipeline is going to run. And if it disagrees with some of the settings of that database, well, it's just going to delete it. So if we were to look at this and evaluate what's happening here and why we're here today, and why we're using pipelines and what exactly is not working with pipelines, well, the first and foremost is that they're not composable, meaning we do not have a standard way to take the output of one pipeline and pass it to another pipeline. They're not self-healing. For those of you who are using Terraform, you probably know that Terraform fails often for no apparent reason whatsoever. So if that pipeline did fail, that developer now has to go and talk to the team who created the pipeline. And also, pipelines don't have a single source of truth state file for the resource. And if you're using Terraform, you're going to probably tell me, well, Terraform has state. We have a state file, right? Yes, but that is the state of the pipeline. And if the infra pipeline created the resource and showed me green, and the compliance pipeline deleted the resource, where's the state? Where's the source of truth? As a developer, how do I know? I just want to know, is my database up and running? And probably you can tell me that, well, AI is going to help us. Well, I'd say AI is going to just duct tape it all together, and under the hood, we'll still have this. So is there a better way? Is there a better approach? Should we reevaluate the approach to start with? And I do think there is a better way. We've been using it for as long as we've used the internet, just not for infrastructure. So why don't we use APIs that are composable, self-healing, have a single source of truth to do that? In fact, Kubernetes is actually, under the hood, API machinery. And since 1.16, we can extend the Kubernetes API. And there are actually open source projects that extend the Kubernetes API easily to provision infrastructure. One of these resources, one of these open source projects is ACK, AWS controllers for Kubernetes. And it does give you controllers to deploy different AWS services, such as Elasticache and RDS. So we can install those controllers, and a developer can deploy those databases in minutes, just like the microservices. And then there is one last thing left. And that one last thing is the connection between all of these, the glue that should put it all together. And that all-purpose glue for Kubernetes resources is CRO. CRO is the last missing piece of the puzzle to utilize the Kubernetes resource model to its full potential to deploy applications and their dependencies. AWS open source CRO last year at KubeCon North America in November 2024. In January, that's just 2 months later, Google and Microsoft joined the steering committee as maintainers of the project as well. And last week, CRO became part of Kubernetes SIG. So how would a developer, how would we use it? How does it work? Well, a platform team will create this abstraction that would include an application and its dependencies, and we call it a resource graph definition. And the developer can then easily instantiate this resource graph definition, which will create all the resources and all the pass all the values between those resources. So that we can go from this, or not we, but the developers can go from this to this. And I will show you a very short demo. This demo includes kubectl apply, and please run. I don't know where my mouse is. Okay. Okay, so the point here is that YAML file that you saw, a developer can apply. I don't have, okay, this is not, the demo is not starting, but it's really just kubectl apply and applies that file, and we get the status of deployed. Please take your phones up, because we did deploy this app, and I need that data. Oh, shoot, what happened? It's not, I'm not sure what's happening. I even took it off and it's not reacting. It's freeze. I did plug it in, but nothing happened. Okay, while we wait, please take your phones out. Okay, we're rebooting the system. In the meantime, you can go to vote.dogs vs.cats.us. vote.dogs vs cats.us. And I see already the votes, like you can see them real time. Sorry, you're gonna look at my laptop. And while you're voting, I just wanted to make sure, because this is being recorded, and if my girls are watching it, what? Oh, there. Oh, come on, this is like, there we go. Cats are at 32, dogs are at 68. And again, this is being recorded. If my girls see this, we want to make sure this is for the dinner table. We're not getting a dog or a cat, regardless of the results. All right, thank you. We got 40 votes, and it seems like dogs are at 63%. I had one more slide that is crawl.run. So please go to crawl.run if you want to get started. And thank you so much.
Test? Okay, cool. Okay, hello everyone. Thank you for joining the session. My name is Dichev. I'm a cluster solutions developer at SUSE. And today I'm going to be talking about two-node high availability Kubernetes cluster. Is that a myth or reality? So we all know what is high availability. The main goals are minimize downtime, protect against data losses, eliminate single points of failure, most importantly, support continuous operations. That means we always try to make our services run whatever happens. And the heart of every control plane, the heart of every Kubernetes cluster is the control plane. So in the control plane, we have several control plane nodes and different components running there. The one that is responsible for high availability, that's etcd. It's a key value store, and it's basically storing all the state of the Kubernetes cluster. And there is a special formula or a rule, similar like Einstein, but more simple, how to calculate the quorum of a Kubernetes cluster. So the quorum basically is the minimum number of nodes that we need in order for our cluster to be operational. And as you see from the table, it's a bit blurry. We need at least 3 nodes. So even with 2 nodes, our cluster is not high available. We cannot survive if there is a node failure. So yeah, we always need an odd number of nodes, right? Well, why do we need the 2-node high availability cluster? Well, we are seeing in today's edge computing trend, Kubernetes clusters are getting deployed out of the centralized data centers towards the edge of the network. So there are benefits, of course, for that, but there are also challenges. So imagine if you have like several hundred locations. So if you are able to like deploy a 2-node cluster instead of 3, so we get a huge cost saving. Not to mention the operational efficiency and other factors. So there are industries like telco, retails that really benefits from this, not to mention the emerging Edge AI, local LLM deployment and stuff. Yeah, Kubernetes is modular. You can extend it, different APIs for whatever you can think of. Unfortunately, there is no database storage interface or whatsoever. We get stuck with etcd for the better or for the worse. However, there is this project called Kine. It's under the K3s ecosystem. So Kine, it's an etcd shim. It translates the etcd API to SQLite, Postgres, MySQL, NATS. It's integrated into K3s, but you can use it instead of etcd with your upstream cluster. So you don't need to use K3s. You just configure Kine, and you point it to your high available data store, which comes to this. So I started working on an experimental data store. It's based on SQLite. It's remotely accessible via the PostgreSQL protocol. So it is compatible with Kine. It needs only 2 nodes, a primary one and a secondary one for high availability. How that works, you see just now. So with 2 nodes, there are challenges. So as explained earlier, etcd solves one particular problem with the quorum. That's the network split brain detection. With the 2 nodes, you get an even split where your network, let's say, has gone. Well, in the edge, in some situations, we are in control of our network setup. So if our nodes are connected via a single connection point, or even better, if they are directly connected, we could rely on the link status in order to prevent the split brain detection. However, there are more sophisticated network setups even in the edge. Multiple switches, switching redundancies, things like that. And optionally, we could rely on this new concept called a network tiebreaker. A network tiebreaker could be basically your default gateway or any manageable network appliance you have in your network. So, of course, the nodes must be in the same local area network. There are ways to have this in the cloud, but that's another story. And going to the configuration itself, it's pretty much simple. You have two nodes, micro 1, micro 2. You run Calculate on the first node. Then you run Calculate on the second node by joining it to the primary one. Then the replication starts to kick in. With K-trace, it's simpler. You don't. It doesn't matter if you started first on micro 2 or micro 1. You just point the K-trace instance to your data store endpoint. It's localhost. And that's about it. And there is a demo. Not sure it's going to run. Can we put it on full screen somehow? OK, so we get only this. OK. So both the Calculates have been started and joined. We are starting K-trace on both nodes. And yeah, you can query the cluster from both nodes. So both nodes are active. So there is no passive node. Both nodes are active. You can query the cluster from both ends. You can do whatever you like. So we're deploying just an Nginx here, adding the service. Yeah, the pods are running on both nodes. We'll see that just in a second. Yeah, the service there. So let's see, both nodes are active. And this is just testing the service from both ends. And what we're going to do, we're going to add a virtual IP manually. So we could test our Nginx from a third party. This should run faster, but OK, so this is the virtual IP. Now we're going to test it from a third party. And yeah, it's running because it's pre-recorded. That's why it's running. Right. So we're going to simulate a node failure by rebooting the primary node. So primary node is gone. So our virtual IP is also gone. So we're going to move the virtual IP manually with this remote to the second node. Yeah, it's still not moved because I didn't click the button. OK, so the nodes are still there. So adding the virtual IP on the second node. Yeah, it's accessible from third party. And now we're going to see it on the browser. Yeah. And that was about it. Thank you. Start if you like it.
Hello, everyone. First of all, I want to thank you for staying till the end. I know it's been a long day. My name is Desi. I'm DevOps engineer and founder of CreateTech. For the past few years, I've had the chance to work with big companies like PokerStars, Nexo, DraftKings, seeing different approaches to building, scaling, and breaking things in production. And today, I'm about to talk about GitOps. Now, I know some of you might say, oh no, another buzzword. But GitOps is not just a trend. It's a practice which can seriously change how we ship software. When done right, it can speed up deployments, it can improve reliability, and it can bring confidence to your teams in their production environment. So what exactly is GitOps? At its core, GitOps is using Git as the single source of truth for your applications. Every change goes through Git, versioned, reviewed, auditable. And then automation tools like Argo CD or Flux make sure your actual environment matches what is declared in Git. So how does traditional CI/CD differ from GitOps? In traditional CI/CD, your pipeline pushes directly into production. With GitOps, your pipeline updates Git, and then the GitOps operator, like Argo, applies the change. This small shift from push to pull is what makes difference. It gives us predictability, full traceability, and much safer rollbacks. Of course, no approach is perfect. Here we can see some of the advantages of GitOps. Every change is auditable. You can see who deployed what and when. Rollbacks are trivial. Just revert a commit. Collaboration across teams is better as developers and operations speak the same language, Git. And infrastructure stays consistent across environments. Of course, the learning curve may seem steep at first, and teams need more discipline in their peer reviews. And in large organizations, managing many Git repos can get complex. It's not magic, it's practice which requires commitment. So why is GitOps better? Why is it worth the effort? Because it reduces the human factor. No more wondering who deployed what at 2 a.m. No more configuration drift in your environments. This level of confidence is a game changer. To wrap it up, GitOps is not just a buzzword, it's a mindset shift which makes deployments faster, safer, and less stressful. Thank you for staying with me till the end. I'm Desi from CreateTech, and I hope you leave here curious to bring GitOps into your teams.
So we've actually reached the end. I'm sure that everyone is eager to join the cocktail. I'm certainly kind of tired of hearing myself talk all day. I want to thank you all for attending. Without you, this conference would really not be what it is. Same stands for our partners who made a lot of this possible. And last but not least, I'm going to say goodbye to you, and I really hope that we see each other again next year. But before that, I want to invite the main people responsible for organizing this event, which are Ioana, Orlin, Vladi, and Spas.
Give me fuel, give me fire, give me that which I desire.
All right, I'll try to be super quick. First of all, thank you very much, everyone, for being here with us today. It's almost a year effort for all of us and all the people who helped that to happen. Especially, I want to thank all the people who are doing the catering, the coffee, the technical team back there. Thank you very much again. So. We cannot promise we're going to do it again, but I think we can promise we're going to do it again. So see you next year, I hope. Right. See you next year, I hope, and thank you very much, everyone.
Just want to say I'm very difficult in talking, but this event is a dream come true for everyone, and I would like to thank you, everybody, participating and contributing to this event happening today. Thank you.
It's all about the community. Thank you.
see you outside. We're gonna have some drinks for a little bit.